his name.
Yeah, because I dealt with that same claim just yesterday with someone else. It's always that bridge. It's only that bridge. Don't know what anti-flat Earth video it comes from. I was just imagining it's like whatever fucking McToon video just dropped yesterday, and that's the claim we're gonna hear for the next week, you know?
It's funny because, I mean, I was actually thinking I think about certain claims I haven't heard in a while, and I wonder when they're gonna come around again, and I was thinking about that bridge in particular, and then people started coming in and asking about it. But it'll be a while, and then it'll stop, and then it'll be Cavendish, you know, for 2 weeks, and then it'll be TFE and whatever, but this
I
Artemis
haven't heard
mission should be
Cavendish
interesting.
drop in a while.
You haven't heard what drop in a while?
Cavendish.
I know, that's what I'm saying. We just you gotta wait for the algorithm to pick it up.
We just had like a week of maps,
Yeah, that too.
so I don't know what we'll get. Well, we'll get bridges this week, I guess.
It's gonna be all Artemis all the time.
Yeah, that
I'm
too.
I'm hoping it's gonna be like after TFE, and all these cocky globers are gonna come in and telling us how a rocket shot in the air proves the Earth is curved and we have nothing to stand on.
They don't realize that like nothing has changed. You know, it's like none of our arguments are based on rockets. It's nothing to do with that. You know, you could launch 100 more rockets. It's not going to change anything. You were wrong before. You'll be wrong after again.
Right, and why do none of them question the value, even if this was real, the amount of money that's being spent to supposedly shoot a rocket around the moon. When
Yeah.
people on the earth are having real problems and none of those are being solved. But sure, let's spend billions to shoot something in the air. That's fine.
Yeah, even in their paradigm, the entire thing is not justified. Scientific pursuit, exploration of the cosmos. It's like, yeah, we don't need to be doing that shit right now, and you haven't fucking provided any valuable science. It's like you've grown lettuce on the ISS about 7 times. You know, you can recycle your piss in a coffee. Well done. It's you're not really bringing much back to Earth here we can work with.
But what about Velcro?
Well, the Globers need their Velcro. We know that. That's their in case gravity suddenly fails solution. You know, got Velcro bunkers so we won't float away.
The Velcro claim, like pretty much every single one of their invention claims has been thrown under the completely debunked. They didn't invent Velcro or Tang or pens or freaking anything. Absolute clownery.
Does anybody remember the joke that NASA invented? Was it the ballpoint pen to write in zero
Yeah, I was
G,
just thinking of it,
and
Jedi.
Russians just used a pencil?
Yeah. Thing is, you tell that to a Glober and they're like, fucking stupid Russians.
Dude, I've got the funniest clip saved of that clown Josh Ingersoll going on this emotional rant about how amazing NASA is bringing us products like Velcro, and he was just like he was just bullshit. Like I guess he was just regurgitating something he heard, but the way he spoke with such passion and confidence about how amazing NASA was. And then I've got another clip of us explaining to him that they didn't invent it and just how quickly he just admitted that he was completely wrong about that. And that I've got other clips of him saying, yeah, he's wrong about a lot of the things he says. He just kind of repeats. He's got a good memory and he just repeats things that he got told, and he likes being called out, blah, blah, blah. But it's just shows the level of just bullshittery some of these so-called space nerds or space qualified space engineers, I guess you could call him, go to
You
when
really
they're
wouldn't expect that from someone of his caliber, quotes, you know.
well, that's all he does. All he does is just repeat things. I
The
questioned him
Velcro,
about
memory foam, ballpoint
Yeah.
pens, that's like pleb levels. They should be repeating them talking points. He should be giving us the actual scientific data they've discovered, you know.
Right, but that's equally as bullshit. That's what I've noticed from him. I mean, he was saying things like, if the sun was local and the sun was just moving away from you, you would still be able to detect things like X-rays coming from the sun that aren't affected by the atmosphere. Because he's like, yeah, the light would attenuate the visible light. The atmosphere would attenuate the visible light, but there's things like X-rays. And he's like, you would still be able to detect that. And I'm like, oh, that's interesting. Let me look it up. 30 seconds later, it's like Velcro is one of the things that gets absorbed first by the atmosphere, and you wouldn't detect any rays coming from the sun
Velcro.
through the atmosphere. And
You mean
straight
X-ray?
away he just conceded. He's like, oh yeah, I guess I was completely wrong about that. I was just talking out of my ass. But when he said it, he was so sure of himself, tending to be sure of
Yeah,
himself.
you said Velcro there. Velcro would get absorbed by the
Oh,
atmosphere.
X-rays. I said X-ray. I meant to say X-rays. Yeah.
But Josh could comfortably say Velcro is absorbed by the atmosphere, you know?
He would. Yeah, he could.
He would just be like, so, you know, he's so comfortable lying that he just does it as easily as breathing, you know? It takes a special kind of person to do that, you know? He's perfect for his job.
I mean, he said he just a salesman for satellite parts. That's what he was.
Is what he is. He's like TED Talk material, you know.
Yep.
But I find it very interesting though when people talk about, you know, NASA's contributions to society, they come up with things like the space pen and Velcro. You know, we spent billions of dollars for
It's
Velcro.
absurd, isn't it?
Like, do they not hear themselves?
Didn't they start like ready meals, like uneatable food that's vacuum sealed that you have to heat up?
I bet they
The
I
army
did.
think
probably
that's the
did that, didn't they?
military.
Yeah,
Yeah.
it's the army that did that. Yeah, so not them for that either. Damn.
MREs and that.
Don't forget about Tang and memory foam mattresses.
Yeah, there's nothing about NASA and what they get up to, what they claim they get up to, that's like based in any type of like pragmatism or, you know, justification. It's just it's all unreasonable, even if heliocentrism was real. The only like reasonable argument a Glober could make is to maintain nationalistic morale.
It was to take people's minds off the Vietnam War.
And we already know as flat earthers that that is the main purpose of NASA, you know, among some other things. They're just they're an optics company essentially. public relations. I mean, don't know if Yoda, are you here?
Okay, so I've just quickly Googled what NASA have invented. Apparently, they invented super soakers, so water pistols.
Super soakers.
Yeah.
Because we didn't know how to pressurize water before now.
Oh. Oh, dear.
So did everybody's like garden hose back, pre-NASA, just have like the one crappy setting of no pressure
I
that you couldn't
reckon.
get anything done with?
Yeah, don't forget Teflon.
What's the backstory there, Jedi?
For what, super soakers?
Yeah.
Okay, so what it says is super soakers. This popular water gun was accidentally invented by NASA engineer Loney Johnson while he was working on a new heat pump. There you go. So one guy accidentally, because he was working for NASA, it's just one guy happenstance across this. You were right about the memory foam. There's a CMOS image sensor. Technology inside every smartphone camera and GoPro was invented by NASA's JPL to miniaturize camera for interplanetary missions. So small lenses. Cordless power tools and vacuums. To extract lunar core samples, NASA partnered with Black & Decker to develop portable, battery-operated drills. This technology led directly to the dustbuster and modern cordless tools. Wow, thank you.
Lunar core
Scratch-resistant
sampling?
lenses. Pardon me?
Lunar core sampling? Do they claim to have
Yeah,
done that?
To
you need a
extract
vacuum
lunar
to pick
core
up
samples. That's
petrified
what it
water.
says.
Oh my gosh.
I mean, I'll question AI. AI usually turns around to go, yeah, I'm sorry about that. I'm stupid. But yeah.
So yeah, they could construct the lunar buggy, play golf, do all the shit they did, but they couldn't pick up stuff off the ground.
Yeah, $37 million for those buggies. Made from the cheapest materials ever.
Yeah, I've got the meme.
Wow, NASA's technology's gone into Nike Air shoes. That's fantastic. No wonder they cost so much. Those are space shoes. Space blankets, they invented those. Those lightweight, heat reflective emergency blankets that we see everywhere after marathons and whatnot. Yep, NASA.
Yeah. Of course.
You got
All right, here we go, Jedi.
okay.
Debunking you dumb AI. All right, with my dumb AI.
Right,
So
speedos in a minute.
the claim that NASA invented super soakers is false. Super
Cool.
soaker was invented by Lonnie Johnson, an aerospace engineer who worked on projects for NASA and the United States Air Force. But he invented the super soaker on his own. Super soaker on his own at home, not an
Wow. Okay.
app.
Yeah, that was typical for NASA because one guy tweeted and said his father was on the Saturn V era of NASA, and he said at least 50% of NASA employees were working other jobs or other gigs or something, either on the clock or off the clock.
What was your next one, Jedi?
Speedos.
What, like
So
budgie
speedos.
smugglers?
Yeah.
Speedos.
Let me read this. So Speedos LZR Racer swimsuit used wind tunnel testing and fluid flow software from NASA to reduce skin friction drag. Yep. So Speedos. It gets even more interesting because down the bottom it's telling me what the common misconceptions are. Thanks. So NASA is often incorrectly credited with inventing Teflon, Velcro, and Tang. While NASA used and popularized these products, they were invented by other entities before the space program.
The claim that
So-
NASA invented Speedos is false. Speedo swimwear brand was founded in 1914 in Australia. The
I
company
thought that was
behind it
Australian.
was originally McRae Knitting Mills and became known as Speedo International. That predates NASA by decades.
Wow.
Wrong country
What do you
also.
what do you think about this, Jesse?
I just got here.
Okay,
But, I
Swag
mean,
Boy joined.
you've been here for like 5 minutes. But fair enough.
it could be that maybe
Selective hearing.
it could be maybe the Australian government was actually knew about that NASA would be formed one day, and that they were knitting them some fast underwear.
Yeah, that makes sense. Okay. Swag Boy, you here?
Yeah.
Hello? Can you speak up?
Hello.
Hey, your
I'm
mic is pretty
speaking.
muffled. Can you?
Damn. I
Can you
don't
say
know,
hi?
man.
Okay, that's a little bit
Hello.
better.
Hello.
Hi, that's a little better. How you doing?
Doing fine.
Yeah. Hey.
What about you?
So, I'm fine, thanks. So, you came in and you asked us what we thought about Artemis 2, and
Yeah.
then people offered their opinions, and then you told us all we were dumb. So, I was
Yeah.
wondering why you said that, and yeah, I just thought we could kind of get into that because then you also said you were dumb. So, that kind of invalidates your opinion. But I'm willing to hear you out.
But the problem is you're making things up. You don't have any proof that they're faking it, okay?
We've got
Okay,
all the proof in the world.
what we asked you for was proof that the surface of the earth was curving at the given rate, and what you replied with was a rocket. Can you explain to me how shooting up a rocket proves that the surface of the earth is curving?
Hmm. I did not know that you mentioned curvature. I was saying that to prove the Earth is a sphere, that's why I told the rocket and shit.
So can you shoot if the earth is flat, can you shoot a rocket up into the air?
No.
So
Yes,
you can't
actually.
shoot a rocket into the air off of a flat
No,
surface.
no, no,
That's your
no, no.
contention.
I don't know. I don't know about that.
So you don't know whether it's possible to shoot a rocket up off of a flat surface?
I don't know.
Okay, then.
Does it always have to be curved surfaces the rockets leave
Nope.
when you're setting up a rocket? Do we have to
Not
make sure the
necessarily.
surface is curved?
No,
Okay.
I guess.
Do we have to make sure it's level?
Mm,
Is it possible to shoot rockets off of level surfaces?
sorry.
Is it possible to shoot rockets up off of level surfaces?
Yeah, I think.
Well, yeah, of course.
Yeah,
Put a rocket on your table,
yeah,
launch pad, that'll be level. Unless you want to aim it at an angle, you could shoot rockets off of pretty much any surface, I would assume.
yeah, yeah. You can.
I got him there, Fences. Back to you, mate. It wasn't so hard in the end.
Thanks for taking over because I was kind of speechless at that. So, so we've ascertained that indeed rockets can launch off of a flat surface. So, can you explain to me why a rocket launching would prove that the Earth is a ball?
Because they will like make videos and like it's live. I don't know.
Okay, but again, that has nothing to do with the surface of the Earth. So, can you explain how the Earth's surface is curved? Because I've seen videos of many different things that aren't real.
Wait, do you believe in gravity?
Okay, this is not relevant. Can you try to stay on topic?
Yeah, I can.
Okay. Okay, cool. So we can rightfully discard a video as evidence because we obviously have videos of many things that aren't real. So that's not proof for or against your claim. What we need is an actual measurement of the surface
Well,
to
you know,
show
it's
that it's
hard to
curving at
measure the Earth. You know,
I'm sorry, can you say that again?
it's hard to measure the Earth.
Okay, but somebody had to have measured the Earth, right? Because we are given a radius value for it.
Yeah, but it's hard, and
Okay,
the people
so
who
who
have
did it?
done it,
Who?
uh,
Can you explain? Like, you can just like post your citation in the text chat. That would be
Just
cool.
just a quick question. What do you think would be harder to measure 66 feet of curvature over 10 miles over the surface of the Earth, or to build a space rocket and send it to the moon?
to build a space rocket, or yeah,
Where are we up to? I zoned out for a couple of seconds. It feels like an eternity. What's going on?
I don't know. This guy said we were dumb for questioning the rocket launch being proof of the Earth being a ball, but he can't
Okay.
really explain why.
Oh.
I think he's just
Oh.
kind of given up, you know.
Oh. I
this guy,
understand the silence then.
this guy.
Hmm? Pardon me.
All right. He's got a new talking point, and he's written it in the side chat. So the first thing
Oh.
we need to check is if he's able to say the word. Explain your
Nope,
point. Tell us the name.
nope.
Go ahead. Say it.
I can't.
Say
Come
it.
on, dude.
Hey,
Can't
hey,
pronounce that name. That's hard.
It's not a
Sorry.
good start for your Eratosthenes argument, not being able to even say
Yeah.
Eratosthenes.
Was he the
Eratosthenes. Yep.
was he the famous Chinese person or the famous Greek person?
Uh,
Was it
guys,
ancient
I got
Greek,
a question.
philosopher, polymath, whatever, astronomer?
Hey, hi there, everyone. I got a question. May I?
Yes, please. Sorry to interrupt, but yes, please. You sound more alive than this other guy does. Would that be okay with everybody? Shh.
Yes,
Yeah, yeah.
approved.
Thank you. I mean, this is the
Approved,
first
approved.
time for me to join you guys here,
Oh,
and
welcome.
yeah, thank you. I have a quick question. Now the mainstream idea says it's round or it's curved, right? Now,
Yes.
now my question is that what would be different if it was flat?
Not quite sure how to take that question. Does anybody else want to take it before I get
Yeah,
confused?
yeah. If it's flat, NASA owes us $1.1 trillion.
Well, they
What's
could
the
have still
difference?
charged us that much for dome cleaning or something.
I mean, my question is all about
Do you know they're
what would
not?
be different. What would be
Maybe that's where
different?
the money went.
Yeah.
So it all
That's why
comes down
chemtrails
to
are up there.
money, right?
Sorry,
Hmm?
we've got waylaid from the point. Do apologise.
What I call you, man? You guys speaking?
I think it's a good question though. What would be different?
What would be different?
Yeah.
But
What
we
would
everybody already experienced the Earth as a flat stationary. It depends. You would have to get more specific with your question. So
Yeah.
nothing would change that the Earth is already flat. So other than you actually realizing that you're living a delusion with your worldview, um, yeah, it would depend on each person's situation. What would change? But you're still going to experience the Earth as flat and stationary every day of your life, like you already do right now.
But like as a mechanic, if I need to turn a round nut, I use say a pipe wrench. If I need to turn a hexagonal nut, then I use a socket or something. You know, it makes a difference. But what would be different for people if Earth was flat versus was a globe? On the light switch, if the light comes on, that would be the same on a flat Earth or a globe. What would be different, and how would it be different in real
well,
If
life?
it was if it suddenly became the heliocentric model, you would probably everyone would instantly die. So there something that would.
Yeah, exactly. We wouldn't be here.
Do explain.
Or let's just get a terrarium that's deeming like that's filled with life and water and not cycles that take place. It's self-sufficient, and we're just gonna remove the container and just pop it in a vacuum. Little Jesse can be in there saying, "What's gonna change?" And then your head will explode or something like that.
I want to see that.
Well, so is this problem related to a sudden change from one to the other, or are you saying that it just this would be a difference if it had always been that way for the entirety of Earth's history?
I guess it would never have developed in the first instance, so we wouldn't even be here having this conversation.
But why not? What would not have
Because the
worked?
first gas molecule would have fucked off ages ago and never have returned, followed by the next one and the next one and all the rest.
Okay, what are your base assumptions and your logic on that conclusion?
Gas expansion into a vacuum. Being
Okay,
as the
what
gases I produce, I presume, has got some energy from somewhere. I don't know how far back in the story we're going to need to go for the creation mythology. But for this instance, we need the formation of gas pressure. And if we've got, let's say, an outgassing, the gas is going to go out into the available vacuum. Why would it come back?
maybe it has weight?
No, why would? What do you mean? Maybe it has weight. No, why would it come back? It went up high up into the sky and then came back down for some reason. The gas expands. It's got energy. It's going to go in that direction until it has a physical collision with something else. Power of
So,
indefinite expansion, right?
well, let's explore this. What is your position on uh, the pressure of gas in an undivided area? Like, will the air pressure be inside my house all the same pressure, or will there be more pressure
No,
at the
there'll be
floor?
multiple variables, multiple temperatures, multiple densities. We can talk about this all day, but we're talking about how we achieve gas pressure in the first instance for your creation mythology to start. Right, we're talking about what would be different. I'm saying we wouldn't even be here having the conversation because we wouldn't have achieved gas pressure in the first instance. Because if gas was produced, it would have dispersed into the vacuum. You said it had weight. Now you want to say, well, I can read different gas pressure. No, gas expands into vacuums, doesn't it?
But
Fill space.
does it expand equally in all directions, or does
It
it have a
spells
bias?
freely and randomly in all directions. We're going to be talking about some very differential variables if we're going to talk about there's maybe some more gas here because there's more gas produced here compared to over there where there's less gas produced, so there's less density. We could be here all day, but ultimately we're trying to achieve gas pressure. And at the moment, I'm giving you what gas is produced, and we're in an unlimited available space. The gas is gonna it's gonna start wandering around in that available space, right, until it hits something and changes direction.
All right, so we agree then that inside a container, like my house or whatever, my cell phone barometer will measure a greater pressure at the floor than at the ceiling. Are we on the same page there?
I'm sorry, did you just call your house a container for
Well,
gas?
you can if you like, but
No,
No,
I mean,
no, you said that, not me. Your gas is not an airtight your house is not an airtight container for gas.
how
okay,
not?
I don't mind calling it a not
Okay.
a container. So,
Okay.
are
Yeah,
we on the
because
same?
let's be realistic here. Your house is inside a pressurized container.
Is it warmer at the top of your living room? Is it cooler at the bottom? How's your heating flow? You got mini drafts. We're trying to achieve pressure, dude. Stop trying to get to. Stop trying to get to. Well, when I go up a mountain, there's less pressure. Therefore, insert gravitational idea about the slow dispersion of gas and gravity before we get to the vacuum of space. That's where we're going, right? Now, we're talking about what would be different. Well, how would we achieve pressure? You're saying the gas has weight.
I swear that's completely broken when you say that gas have weight. When you call weight every direction, that's stupid. I'm so sorry for that because what I heard that weight is that downward force. Gases don't have that downward direction. Gases move all directions. So are you calling gas pressure weight? No, it's not. So a molecule of gas can't weight it, can't put it on scale because it moves all direction. So if you want to trick that scale, that measurement, you will have to press on that molecule of gas in every direction to stop it from moving. So you'll have to confine it. That's not measuring the weight of that molecule of gas or those couple of molecules, of bunch of molecules. Doesn't matter. When you're confining them, pressing from above of those molecules by putting a sealed container, putting them in sealed container, you are not measuring the weight of the gas. Put the same gas in a balloon. Will it measure the same? No.
It's my turn. So we could, though, take a container of a fixed weight and weigh the container without the gas in it, and then weigh the container with the gas in it. And then the difference in weight would have been the weight of the gas that we added into it, right?
Sorry, the container's
No.
physical, like solid matter that has a direction downwards. The gas is omnidirectional, moves freely and randomly in all directions, like it's doing in the container. Stop trying to use this conjuring trick to invoke that the gas inside the container that's moving in all directions is just going downwards.
Yep. Change that solid metal container into a balloon, rubber balloon. The same amount of gases inside this different containers. It changed the measurement on your scale. So why is that? Yeah, you're just letting those gases move a little bit more freely inside the rubber balloon that can stretch compared to the metal container that is specific that has a specific volume. It can stretch. It will just confine. That's why it's called gas pressure. It's confined gases. Gases being pressurized, being sealed inside a specific volume. So I am not measuring the weight of the scale. Again, try again.
So what causes the difference in measured weight of the container?
No. We've got something in a vacuum producing gas at the moment. We're trying to figure out what would be different. Remember, you're the one that's trying to be demonstrating how it wouldn't be different because we would all still be here. At the moment, we've got the first gas molecule that's been produced, whatever, and apparently it's got weight. Okay, that's not a direction just downwards, though, is it? That's not how gas behaves. Gas is going to move off in a direction and maybe hit something and change direction. This gives gas the power of indefinite expansion. You understand the issue here, right? Stop asking us questions. We're asking you.
Well, I understand my paradigm.
Yeah,
was
I
asking
know.
you to
We
kinda-
understand your paradigm. You're saying that the gas has weight because gravity and shit stops the gas expanding into the vacuum for some reason, and an actual violation of that law because the law says it works in this way. You says yeah, but no, it works in this way. So that's a contradiction to the law. You understand that, right? The law says this, you say yeah, but no.
What law?
Second law of thermodynamics simply is expressed as gas expansion into a vacuum. The mixing of ideal gases, this is all different types of gases, they will mix. Doesn't matter about their molecular mass or whatever, they will mix.
Well, according to my paradigm, my model's paradigm, if there were one molecule of gas on Earth, it would hit the ground and bounce up, but it wouldn't
Hit the
continue
ground.
at a constant velocity. It would be slowing down due to its own weight acting against its velocity until it would reach a zero velocity and then start falling and then bounce again, right? That's my paradigm, right?
Yeah, but that's just made up bullshit.
Okay, so it sounds like you're saying my
That's
paradigm on
broken. That's broken. You're violating the first law of thermodynamics. So where that kinetic energy were spent on? When you're saying that that molecule will just lose its speed.
Yep. Fuck the temperature. Nope.
What? So when you're
Sorry.
following,
It's only just struck me how funny that was.
yeah, he's when he's trying to follow the second law of thermodynamics, he forget about this first one. So what?
I think it's hilarious that it's fallen out of the sky in the first place.
right now.
torn all day. Where myriad snowy quartz stones lift and the hoofprints vanish away. The roadside flowers too wet for the bee expend their bloom in vain. Come over the hills and far with me and be my love in the rain. The birds have less to say for themselves in the wood world's torn despair. Then now these numberless years the elves, although they are no less there. All song of the woods is crushed like some wild, easily shattered rose. Come be my love in the wet woods, come where the boughs rain when it blows. There is the gale to urge behind, and Bree are singing down in the shallow waters aflutter with wind, from which to gather your gown. What matter if we go clear to the west and come not through dry shod, for wilding brook shall wet your breast. The rain fresh golden never this whelming east wind swells, but it seems like the seas return to the ancient lands where it left the shells before the age of the fern. And it seems like the time when after doubt our love came back amain. Oh, come forth into the storm and rout and be my love in the him, stick him in a scupper with the hose pipe on him. Early in the morning, way and up she rises, way and up she rises, way and up she rises early in the morning. Put him in the bed with the captain's daughter. Put him in the bed with the captain's daughter. Put him in the bed with the captain's daughter. Early in the morning, way hey, and up she rises. Way hey, and up she rises. Way hey, and up she rises early in the morning. That's what we do with a drunken sailor. That's what we do with a drunken sailor. That's what we do with a drunken sailor. Early in the morning.
Hello, everybody. Hello. 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 Hey, man, bro. What, bro? Hmm? Hello. How are you, bro? How are you?
Hello,
Good
brother.
morning. Hello, bro. How
Hey,
are
what's
you?
up, AG?
Bro, how
Hope
are
all
you?
is well with everybody.
Wow. I'm good as you.
Can't complain. Wouldn't make a difference if I did.
Where from, bro?
Today's going to be a good day.
Bro, where from?
I'm from Earth, same place as you.
What?
I am from Earth, just like you.
What it is, man?
Well, the exact location doesn't matter. That would be too close to doxing. I don't care where you're at, but you and I both come from the same place, Earth.
Yes.
All right, then.
Yes, bro. Bro, bailar usted.
Have you just joined, John? AG, I mean.
I'm just chilling, getting situated for the morning.
Nice. I feel like I hadn't seen you for a while. I hope everything is good on your side, mate.
Been busy the last month. But it's all good. I'll update you on everything later.
Cool. Yeah.
Yep.
Yeah, I haven't been around that much either, to be honest.
Yeah, man. How life gets that way. It becomes busy very fast.
Yeah. Sure does. Especially with the kids, right?
Yeah, man. They never give you a break.
Yeah. Tell me about it, dude.
When
I
you
need a
become a
break.
parent, there are no days off.
Yeah. I need a break. I might just book a day off and not tell anyone. Just enjoy myself. Maybe go
Be like
golf.
the guy on. It'd be like the dad on Malcolm in the Middle, and every weekend just go somewhere by yourself to get a break from the family.
Yeah. Yeah, I started playing golf recently, so I wanted to play golf, but as a dad, it's very hard because it's like 2, 3 hours, isn't it?
Yeah.
So I get a lot of stick when
I
I go.
never got into golf, but I realize now that the only reason to play golf is just to hang out with the other dads and get a break from everything.
The game is awesome, but it is so fun having, beers on a buggy on a sunny
Yeah.
day. You got 17 holes left to go, you know what I mean? And you're like, oh, it's going to be a great day.
Yeah.
Yeah. Doesn't look like we've got anybody on the Globey side in the house today. Shout out to the bros though. Flat Earth Judge, Batman, Kalahman, Kathos. Is Kathos a flat earther? I'm sure he is. Can't remember. Pretty sure he is, isn't
Yeah, I think so. I've seen him around enough.
he? Yeah.
What's up, Matt Will East?
In the end, what? You say something to me?
Yeah, I was just saying welcome, dude.
Oh, what's up, man? I'm in the airport, bro.
Fair enough.
Nice. Where you going?
Houston town.
Nice, dude. Business or pleasure?
Both. I gotta go see my wife.
Nice. Nice, bro. Be sure to take photos of the flat horizon while you're up there.
I can turn the camera on the flight.
Yes, sir. That sounds like a great idea. I took some great photos when I went on my last flight. Put them in the
Actually, I
group chat.
can't. I don't have permission.
Oh, really? Thought you would have. Where's my photos? I can't find mine. I took a great photo of the sun. Now I've lost it. Ugh, too many photos. I give up.
Got a couple things to do, but I think I'll idle in here for a while. Hopefully, my presence encourages others to join. And
Yeah,
the more of us in here, the more people join in. So
very true. Yeah, man. Do what you got to do.
yeah, we've been gone for about a month, so I got a month's worth of chores and other crap to get caught up on.
Oh, you're not. Oh, you've been away from home.
Yeah,
Ah, okay.
that's why I
Yeah,
wasn't
we'll
so. Like I said, I'll tell you more about everything later, but we're getting
Yeah.
situated, so it's all good.
All right, brother. Yeah, man. Welcome to the channel.
Hey, Roots.
Hey, what's up, Dave?
Hey, I heard you
See you, bro.
mention golf. I got a golf question for you. Do you keep a little Coriolis calculator handy with you? Like, you got 150 yards to the stick, so you got to calculate the earth motion and everything. Correct.
The Glober's wish, but that is such a great question because we're talking about a high-speed ball taking an arc above a spinning surface. That's a great question.
I mean, if it does it to bullets, why not golf balls, right?
Exactly. I mean, I can drive about 230 yards, and that's at a ball speed of like, I think I'm like 80 miles, 90 miles per hour.
Wow, that's your top drive, man. Back when I was young, I used to hit 300, 330 all the time.
Yeah, I only started about 2 months ago,
Okay.
and I basically haven't been using the right technique, so I think I'm trying to use strength because I hurt my back hitting it with all of my power, and I'm starting to realize you don't need to do that, do you, to drive further?
No, it's really more about being more fluid with your swing and making a smooth motion through the ball, if that makes any sense, you know?
Yeah.
That's what my
Yeah.
golf coach. My golf coach telling me that when I was like 12. So
It's like you aim through it. You hit just past it so that as it passes through, it knocks the hell out of it, right?
you just allow your momentum to get all your power instead of trying to consciously create power. If that makes any sense.
You just use the circular motion.
Yeah, I'm still learning that at the moment. It's that's why it's so addictive actually, because you start to pick things up and improve, and then you start chasing that, that development.
So if we were really on a spinning globe, golf would be very challenging in reality, wouldn't it?
Oh
If
yeah.
the Earth was actually in motion on every shot, you'd have to calculate for it. It was just a few inches, you know what I'm saying?
Yeah, you would notice the Coriolis effect, wouldn't you, as it travels?
Even affect you on the green putting, right?
Well, if they're not detached from the ground, I don't think the Globers would say that. But I hear what you're saying. I
I
mean,
reckon the direction.
the professional golfers can hit a ball exactly where they want it to land, and that level of precision, if there was a Coriolis or a rotating surface underneath, they would have to take that into account in high pressure sports. They have the money, they would have put the money into these devices. That everyone would have one with their rangefinder, but they don't.
Like if anybody, probably at some point in his career, somebody asked like Tiger Woods, "You ever take Coriolis into account?" He probably would have laughed, you know. What
Well,
you
if you
talking
did, then
about?
wouldn't it make a huge difference which direction you hit it, like whether you're left-handed or right-handed?
Yep. Whether you're
You
shooting
talking
north
about
or
golfing?
south. Yeah, we're talking about how golf proves that the Earth doesn't rotate under the ball.
Yeah, I'm left-handed, and when I swing, the ball shoots way off to the left. It's just because if I don't hit it straight on, it clips the ball and gives it a counterclockwise rotational spin if you're looking upon it from a downward angle.
Yeah, I think that's just called a fade, isn't it? You're
Dave,
fading the ball because of the way you hit it.
Yeah, and if
there's
my
a bit of
right-handed
feedback,
friend
Dave.
clips it the same way that I'll clip it, it'll fly and go the completely other way.
Everybody's voice is kind of doing feedback through Dave's mic. It's echoing through.
Dave, sort your echo out.
He's
My
got it.
bad. I'll mute.
Yeah, but
We
obviously if
know
the Earth was a ball, like Dave was saying, the ground is rotating underneath the ball, and if you're hitting the ball in, let's say, a direction that isn't eastwardly with the rotation of the Earth, the direction of the ball is going to have different, different amounts of
this.
this Coriolis effect,
If
but
I swung and the
should be
ball was
included.
going in the same direction as the rotation of the Earth, the ball would not go as far as if I swung against the rotation of the Earth. That would kind of prove the Coriolis effect. Same thing with a plane flying east or west. It would supposedly arrive at its destination faster or slower depending on the direction that it's going.
There should be fast travel.
Yep, east should equal speed. West should equal drag, right?
Yeah, right. I should have to go, if I was at the equator flying west, I should have to technically fly over 1,000 miles an hour just to be able to keep up with the rotation of the Earth, or faster if I wanted to actually make it anywhere, but that's not what we experience.
Exactly. You don't need to play golf for long to recognize whatever direction you're shooting in, unless the wind is involved. If you swing that club in the same way, you know how far that club's going to take you, right? It's very precise golf. Certain clubs will take you certain distances. So if there was another effect, you wouldn't have that precise club expectation in every direction, would you? But you do.
No, you wouldn't. But now, what about if I got a small craft like a helicopter? Let's say it had no advanced systems in it. It was just completely manual flown, and you take off and you hover. You just hover. You don't go in any direction at all. Wouldn't the Earth start accelerating a rotation below you?
So this is where a lot of globers say no, the atmosphere rotates with the surface.
Okay, then you would not take into account the Coriolis effect when shooting
Yeah.
long distance sniper shots, when flying, when doing anything. You wouldn't take it into effect at all. Then that's as simple as
Exactly,
that.
because everything moves with it. Exactly.
Well, I believe some of the better globers who I've debated, they'll correct the other globers and they'll say no, it depends on the relative direction to whether you
They
would
will
expect
say
to
that, but
experience that.
they'll
And
also
gravity.
say that it won't happen on a plane because it only happens with a projectile, not with something that has consistent force applied to it, right? So that's another argument that they'll state. So, like you're saying with the golf ball effect, we don't experience it, and like you're saying with long distance sniper shots, we don't experience it. The longest sniper shot in the world, what was it, like 4 miles or something like that, over 4 miles away? They did not take into account the Coriolis effect, and if it was actually a thing, the shot would have been so far off from where it hit.
Yep. And the amount of money that's up for grabs in these competitions, there would definitely be technology companies, selling these products to help calculate that for them, some quick math. But
I
they
was
don't
told that
exist.
the Earth rotates to the east 1 mile every three and a half seconds.
Is it that drastic? Is that what it translates to? 1 mile every, did you say 3 seconds?
3 or 4 seconds.
Wow. Sounds huge.
I believe that's at the equator, though. Like, for example, if you were at the 60th degree north or 59th degree north, I believe the rotational spin is supposedly 750 miles an hour. They claim it changes depending on where you are because of the shape of the Earth, supposedly. Which would mean if you're at the direct North Pole, you would just experience a rotational turn, not an actual spin, because it would be spinning at technically 0 miles an hour. It would just be rotating like a lazy Susan.
Yeah, but I also think, even tennis and stuff like that, the fine margin sports are a good indication because there's so much money in it. This is a good indication that if this did exist, there would be tech to deal with this in all sports.
Didn't Neil deGrasse Tyson claim that somebody won the Super Bowl because Earth moving, like Earth spinning or whatever?
Exactly.
The damn equation and everything on this Twitter or X.
And so that's millions and millions of pounds in prize money. People would invest into the tech if they could measure this, wouldn't they?
That's true. Gamblers like good odds.
Next time that I bet on football, I'm gonna put all in on the team that is playing due east. Because the team playing due west, every time they throw that ball or go for a kickoff, it's just not gonna do shit.
Yeah, there you go.
Oh, no thanks. Cutting out,
dude.
We can't hear you.
I had an amazing argument last night with somebody who was using ChatGPT to try to prove that the Earth was a globe, and so I gave them some measurements of a personal observation that I made, and they were like, oh, they plugged in exactly what I wrote to them into ChatGPT, and they said, well, ChatGPT says your math is wrong. I said, okay, ask it why. So they did, and it says because there was missing variables. So I said, what are the missing variables? Ask it that. It gave all the variables that it wanted. I gave all of those variables to him because I recorded them. He put them in and it did the math. And then I said, okay, what are the numbers? It gave the exact numbers that I gave him. And I said, now ask it, is that possible to see something from that far away, from the perspective height and from the height of the object that you're viewing? And it said no. And I said, okay, ask it to explain how much curvature would be covering the object at that distance. How much total coverage would there be? And it gave the exact same information that I gave. Yet, in the photos that I was showing him, the object is still visible. But ChatGPT just kept reiterating, well, something's wrong. Well, yeah, something's wrong. Your math is not mathing. The math is correct, right? Supposedly. But because the image is still visible, something's wrong. And the thing that's wrong is that the math may be correct to itself, but it is not true.
Dude, that's so funny you said that. Only yesterday I had this thought, and it was so out of the blue. And my thought was that flat Earth would eventually break Skynet and ChatGPT, because eventually they've got to admit elements of truth. And I've just got this vision that you can break your ChatGPT with flat Earth, but there's not many subjects you can do that with.
Yeah, there's not many, and you can't directly, because you can't expect, like, if you're showing ChatGPT an image of something from a distance, you can't expect it to fully depict exactly. I mean, you could totally take a picture of a mountain and send the picture to ChatGPT and ask it what mountain is this, and it'll do a lot of cross-referencing on photos
Yeah.
to try to depict what mountain it is. Like, for example, I took a picture of the volcano Redoubt from like 72 miles away. Technically, it should still be visible, right? And it told me this is Mount Redoubt, looking at it from this angle, and it appears to be X distance away, but I told it the true distance from the viewpoint, and it just simply disagreed. You know, it was like, well, no, that's wrong. It's not at that distance. That wouldn't be possible. You would only be seeing like the very top 400 feet of the volcano, but you're seeing the shoreline. And so it's like, nope, sorry, that's not that far away. But I've taken like the actual coordinate measurements of where I was and where it is. So there's, you know, it's saying something is wrong, not that, not that the picture's wrong. Its math just is not adding up to what is being experienced.
Basically, it had no rebuttals. It just said nuh-uh.
It pretty much said nuh-uh, yeah.
I love it. And it's even funnier when the Globers come in with their Chat GPT crutch. Like, they think they can take on the world. They can take on anything with Chat GPT. Hilarious.
Yeah, and I had to ask this gentleman that was using ChatGPT to argue with me last night. I had to ask him, like, what math do you think I'm using that's different than the AI is using? I'm using the math that you believe in if this Earth were curved. I'm using the radius of the Earth that you believe in and the drop over distance along with the refractive index, which all that takes into effect is water temperature, air temperature, the density of the air, and the humidity. And all of those are recorded by weather stations and weather buoys. And so when you're looking over a distance of water in an area, you can get the expected maximum and minimum refraction. And just to be nice to the Globers, use the maximum refractive index that is possible. I have a photo that you would have to be over 100% refractive index to be able to just see the top, like 600 feet of a 20,000 foot tall mountain.
Yep. Yeah.
And I had someone say, oh, well, you're lying. You were not at a 12-foot viewpoint. I said, okay, then let's go ahead and search in this area what the highest elevation is within let's say 10 miles of me. The highest elevation was only 1,000 feet. So to be nice, I put in that I was at 1,000 feet high at a distance of 229 miles, and it still said that I would, with maximum refraction, I would only be able to see the top 380 feet of the mountain, yet you can see the entire thing and the shoreline across the water.
Okay, and how did he respond when you said that?
Well, like when somebody starts to dismantle their current worldview without actually having a good foundation to stand upon a new worldview, they kind of get into this sense of loss where they fall apart and they try to prove that it's wrong, but it's not wrong. Yeah, they just kind of reach this point of anti-acceptance, but at least they're looking into it. So all you can do is hope that they go and research it more themselves.
Yeah.
That's kind of where the conversation went last night.
And that's the biggest win you're gonna get, self-admitted, from the Globers. Like, don't expect any of them to concede to your points, right? That is as good as a win, basically.
Oh yeah, I've been a flat earther for like 14 years now.
Yeah. Wow. Fair play, dude. You're an early one.
My dad was a flat earther my whole life, and I used to think he was like nuts when I was younger, when I was in school. He would like tell me this stuff, and I used to just like look the other way, like, sure, dude. Like I was a stuck-up teenager.
No way.
But,
So was it your dad who convinced you, or did you just go do independent
no one
study?
can
And
convince you of it themselves. You must independently study it to truly believe.
Yeah.
So, although my dad gave me a lot of really good information, I then had to take what he gave me, what I personally had learned in school, and go and test it. I even went, like, I hit this little point of rejection, where I was like, what, I'm going to take physics and prove my dad wrong. And I took college physics, and it literally, like, I went to go learn the theory of gravity, and my physics professor told me those are all theories. He was like, that, like, there's 12 current different theories of gravity that are taught between all the different schools and this and that. And in history, there's been 80 plus different theories of it, and none of them are testable or provable. So he told me, in this class, we only focus on the things that we can test and what we experience. And it was a very good physics class, I gotta say. We did a lot. Most everything was done off of like electricity, electrostatics, electromagnetism, things pertaining to like Coulomb's law.
It's pretty eye-opening when the globe earthers tell you the same exact thing that the flat earthers are saying.
Do you have any model like we can debate on?
They read a textbook and they just believe what's in the textbook. They don't actually study it and apply it to the real world. That's the difference. Is you have to apply the math that you're being told and test it, because math is math. The math is going to be correct, but what they're stating the variables are, that's what you're not experiencing, because you try to put those variables in and you don't get the answer that you're observing.
It's like, well, Einstein said that math doesn't refer to reality.
Guys, is there any like model that if I want to debate on, like to see if it's consistent or not, is there any model for flat earth?
We can debate with you if you want to debate a subject, but we're not going to debate a model.
But I should know what am I debating on. Like,
there's no model, but the plane that you live on, for as far as you can see, and as far as is testable, is flat. There is no flat Earth model. That was whole thing started by the Flat Earth Society, which is a fake anti-flat society that was made to push false propaganda to people. So every time you see a disc floating in space,
what you say is still a model. You are saying that Earth
No,
is a
you're
flat
not
and
understanding what he's saying.
it goes as far as it goes.
No.
Isn't that what you say?
There's no model. There's no distance to the edge. We don't even know if there is an edge. We don't even know. We don't know. So there's no model.
The null hypothesis does not require a model. The burden of proof is on the claim. The globe's the claim. The null hypothesis does not require a model.
So yeah, Hunter, please understand our position. Our position is not, we don't believe in a model. We believe in empiricism. Do you know what empiricism means?
You guys believe in that we don't know because
It's not a belief.
Ignore me.
Because
Are
far as
you the type of guy who just waits for someone to stop speaking and then you just say what you want to say anyway? Or do we have a combo? I asked you a question, dude. Do you know what empiricism is?
No, I don't.
Okay, good. Well, that's where we argue from. So it's important that you understand that our position is based on raw data taken from the field, from outside. The world itself is measured, utilized, and experienced as a flat plane. Do you understand that we don't measure curvature or motion directly on the Earth? Are you aware of that?
Curvature directly on Earth. You're saying that you think it's flat because I don't
it's
get it.
measured.
Can you explain it a bit better? I don't get it.
Yeah, we think it's flat because that's how it's measured. We don't measure curvature. So the claim on the table is from the globe side. The globe claims that the Earth is curving and spinning, right? But when we take measurements, we measure no curvature or spin. So the question is, how can the Earth be curving if we cannot measure or experience the curvature? How can the Earth be spinning if you cannot measure or experience the motion?
Look, you're saying that because we cannot we don't have a device to measure it.
There
But I
may
could
not be a
repeat that.
specific. Say that again.
He's asking if we don't have a way to measure the curvature of the
No.
Earth. We have ways to measure drop over.
The globe Earth. They say that it's because it's too big. It's almost impossible to measure it. Like you
That's
can
what
go
they
on
say.
top.
Okay,
Yeah,
so
that's what they
then
say.
if
Go
that's
ahead.
what they say, if that's what you believe as a glober, then at let's just say at 200 miles away, how much drop over distance should there be? How much curvature should be blocking the distance at 200 miles?
200 miles.
Given the radius of the Earth and drop over distance.
How much is the radius of Earth?
3,959 miles.
3,200. I don't know.
No,
I have to.
3,959. 3,959.
So it's like.
Can someone post the chart inside chat?
15 times more, right?
Yeah, so you're looking at around 26,000 feet of curvature.
No, what it's saying, if you go up like 1/15th times of the Earth, you will see something, right? That's what I'm hearing.
No, you're not following. You're not following. What he's trying to tell you is at 20 miles, sorry,
No,
at 200 miles, at 200 miles, there should be 26,690 feet of drop. So that means the horizontal view that you have is going to be skewed and blocked by 26,000 feet of curve.
That means that a distance of 200 miles, an object would have to be taller than 26,000 some odd feet for you to even just barely see the very tippy top of it from 200 miles away. But we don't experience that. And you can even add in, I know you believe in refraction and you think that it bends the light up around the curve and makes it look flat. So you can go ahead and plug in the refractive index, the date and time of the place you're at, at your location, and it'll give you the expected minimum and maximum refractive index between two different areas. And then you can go to an Earth curvature calculator with the refractive index on it, and you can input all your numbers and see how much curvature there should be total, drop over distance, how much there is including refraction, which will be slightly less because the light will be bending upwards supposedly, and it'll be bringing what is over the curve back into view at a certain amount, and you're going to realize that you can see much further than you should be able to.
You see, I don't because I haven't done your math. I can't say you're wrong or right because I haven't done it. But you making sense to me. It just what I'm coming from is that flat Earth. You might be right. I'm not telling that, but what I'm saying is that what's the point of flat Earth? Like, what's problem it's going to solve?
The problem is not that. The problem is that it's not the truth to believe in the globe model. That's the problem. Is so many people believe it's a globe, and they don't realize the true reality that they live in. They're living a lie, and I don't think that that's healthy to live a lie, even when you're not aware of it. So for your own good, it would probably be better to know the truth.
To me, it's too inconsistent. For example, your time is. I think the flat Earth should.
It's not inconsistent.
I can't say some on top of my mind. For example, your time is probably different from mine. Like
Nope.
you might know what time is it where you live.
Time zones are strictly political. Time zones have absolutely nothing to do with where the sun is. It's all political.
So where the sun is right now in your
It's
country?
nothing. I'm just telling you that time zones are strictly political. China has like 3 different time zone locations all in one time zone. They cram them all together.
Yeah.
So they don't care
Why
about
do you
what
think
time
is
it is.
that?
It's
Why do you
because
think is
I
that?
just told you it's strictly political. Politics, that's why.
Because it's a globe. Like there is no other explanation. It's a
No,
globe, and you need.
because you know nothing about time zones then if you're saying that because you have no idea how they function. It has nothing
No,
to do with
I
whether the
know.
Earth is flat or round, dude. Time
No, it
zones are
has to
political.
do.
No, it doesn't. I know you believe that it does, but I'm telling you it doesn't. You can look it up yourself. They're strictly political.
AG, do you have image perms? If I send you a couple photos, can you post them in side chat?
Yeah, I got you.
Maybe Hunter's speaking on just the time being the position of the sun in relation to your location. I mean, that's no
Now that's
problem.
a physical location. I agree. Yes. Time zones, though.
Isn't it?
Okay, can you go ahead and just failed to send? Hold on, retry.
I sent you a friend request too, so you may have to.
Maybe I have to. Yeah. Let me see. There you go. Just as soon as you post those 4 images in side chat, I'll send my message.
I mean, it is sort of like a cognizant
Go ahead
question.
and. Sorry.
No, I got you. I was just saying. There we go.
So
like
go ahead and look in the side chat at the photos. The first 2 photos, the first one is just the graph of the drop over distance of the globe. The second one is a straight line of sight distance from my exact position where I was when I took the photo. And, I put it on a little thing so you guys could see. The third photo is not a photo I took. That's a photo that's probably about 50 to 70, no greater than 70 miles away, but I wouldn't say any less than 50 miles away, looking at Mount McKinley. The next one is a photo that I took of Mount McKinley from 229 miles away. Below is all the math. You can see that there's no blockage, even at the base of the mountain. It's not blocked. You can compare it to the other photo that is, let's say, 60 miles away. you can see the same amount. You can actually see a little bit less with the closer one because the trees are closer, they're big, so they're blocking a little bit of the mountain, you know. But as you get further, you still have this, it'll look the same. And then I have all the math, coordinates, and everything input down there. Did the guy that we were talking to leave?
Looks like it.
Nice.
Typical, man. As soon as you show and tell, they disappear.
Yep.
I mean, I'm sorry I couldn't provide a CGI photo of the flat Earth model for him. I think that's what he wanted, but I don't believe anybody could get that far away.
I tried to be quick. I guess I wasn't fast enough.
No, it's no, it wasn't you. It's just he's probably hopefully he's gonna go question himself and his beliefs.
You know what it is. It's the 8-second attention spans from TikTok. They can't focus.
Are you guys all also over in like over in the politics server?
Yeah, man.
You
We
guys
get around. We got a couple guest stars.
to that chick. Her old name was like what, Bimbo, and she changed her username to like Ippo or something. Holy crap, dude! We just gotta ban her. Like she does. She can't learn anything.
Russian. Русский есть?
Hello, hello, welcome. If you could speak English, that would be great.
English, okay. Hello.
Hello.
Сейчас напишу. Переводчик.
Hello. Have you come to talk about flat Earth?
I am from Ukraine. Okay.
All right.
Nice.
But that doesn't answer his question.
Why are you here? Why did you join the channel?
I'm very lazy.
Well, at least you admit it.
Ща. I speak English very poorly. Okay.
Fair enough. Well, feel free to listen in and learn then, if that's what you want to do.
We can help you with your English. We talk about science and specifically geometry. So we like to talk about the Earth, whether the Earth is a ball or whether the Earth is how it presents itself, which is flat.
Okay.
No, you're not. You're not stupid. You just don't know English very well. Don't worry about it. I guess we can just continue chatting amongst ourselves.
Andy's gone.
Had some really good chats with Yoda about internal navigation systems. If you've never spoke to Yoda about that kind of thing, ask him about Shula tuning. Very interesting. Being as we were talking about Coriolis and rotation. Definitely worth asking him to expand on. Yeah, you too, Yoda. We've just been talking about Coriolis and the rotation of the surface. That's why I mentioned the Shula tuning. Yeah, will do, Yoda. I'll try and keep up with you. Right. Yeah. It always comes back to the grid system, right? And the misinterpretation of that data on a grid system. It's the difference. It's secondhand, isn't it? It's the same problem over and over again. Secondhand transformed data. Yeah, Rayleigh, we were discussing golf and how the millions and millions of pounds of prize money that's available in golf would warrant a company to invest in a device that allows them to make the calculations. Sport is very competitive, and at any edge they can get, they would take it. The amount of tech that you can get for sports like golf, if Coriolis or the rotating surface under the ball in a certain direction was a thing, there would surely be technology that they could sell to golfers to make a quick buck, or companies would be buying it for their golfers to give them the edge.
No, I guess it only works in football, where the rotation of the earth move the goalposts, a quarter inch.
Yes, as I said earlier, I think I broke up, but as I said earlier, this is why Dallas Cowboys have oriented their field east to west, because their kicker, he really can only kick about 10 yards, but because the goalpost is moving towards him, he makes it every time.
What
I've
a
heard
what
a
a
lot of
what what a
excuses
globe
out of
hack.
Cowboys, but that takes the cake. Tell you what.
That's a globe proof right there. Dallas Cowboys.
Yeah, I asked Gemini AI what factors are the most important for long range shooting. Coriolis did not come up in the top 4.
That would be the top. That would be the top thing, like, without a doubt. If that I would be accounting for. If a target was moving, that would be the first thing I'd be like, okay, how fast is it moving? Let me lead the target. So on. That'd be the number one thing.
Yeah, the top one is how much the bullet has to drop over the distance. Number 2 is air resistance. Number 3 was wind. And I can't remember what was number 4. Oh, 4 was spin drift.
Yeah. Would that come under the sensitivity of the instrument or the gun?
And it was saying that if they miscalculate the wind by 2 miles an hour, that can cause the bullet to move 7 to 15 inches.
2 miles an hour. As I said earlier, the Earth is said to be moving at 1 mile every 4 seconds. What do you think is a more devastating argument to the globe? The lack of curvature, I mean, not a globe, or the lack of motion? Which one? Which one would make it so you can't have your model?
I'd say curvature.
I'll take motion because if the Earth, like I said, if the Earth was moving, then flights from London to Singapore could never happen.
So they could still, I guess, they definitely can't have their model without curvature. I'd imagine. Could they still have their model without motion? I'm not sure.
Well, we did have the model without motion for maybe 1,000 years or something. That before the year 1500, that was the globe model, the geocentric globe model. So yeah, lack of curvature would be more devastating.
Not just that, there's all sorts of relativistic arguments you can apply, which makes it damn near impossible to be able to test these things. Whereas with curvature, it's more straightforward, right? We've got an 8-inch per mole drop. We know how much it should be curving over a certain distance. If we can demonstrate a laser parallel to the plane, then you're in deep water, really, as a glober.
I
For
don't
sure,
know.
but if it was not in motion, then their calculations for gravity, then you couldn't have gravity as they know it. I don't imagine, and if then you couldn't have the the size of the globe, because you wouldn't have gravity. You wouldn't have no explanation for the position of stars and the universal uh, mode of gravity for falling objects, which then gives you the you can then derive, so they say, the size of the sphere. I don't know.
Well, so you're right about motion, and the idea of gravity didn't come until after geocentrism fell out of favor. But 1,000 years ago, people did believe the Earth was a globe, and some people had gotten it the size fairly close without believing in gravity. So why would gravity matter?
I don't know. I haven't thought it all the way out yet. Like, where's the most detrimental part of it? I get. I haven't thought it all out yet.
Well, gravity would ruin the whole galactical model, right?
Right.
You wouldn't have a heliocentric model without gravity. You can still have
Right.
a ball, you just can't explain why things go down.
Yeah, you could have a geocentric explanation, and that's why I'm saying that they did for before the year 1500.
Yeah, but what would the model really explain at that point? That's what I was like. What would the
Sunsets, moon season, the moon phases, seasons, and ships going over the horizon, disappearing bottom up, stuff like that.
but then what's the sun? Like in that model, they're saying the sun is what are they explaining?
It's a large object rising and setting and moving in the heavens relative to a stationary Earth. And it would explain time zones and why it's dark in India when it's light in the United States and vice versa.
Yeah, maybe. I don't know. It just seems like if that were the case, when you get to some of the other parts in the argument of okay, well, why doesn't the sun change angular size? All this stuff, without gravity, without the objects being as massive as they are, as far away as they are, so on and so forth. It wouldn't be some sort of satisfactory explanation.
Yeah, the motions of the heavenly bodies would have been more mysterious, but the angular size of the sun is just distance, and so I guess the geocentrists would have said something like, "Well, the sun goes in a circle around the Earth, and so it doesn't change distance. That's why everybody always sees it the same angular size from sunrise to sunset."
Yeah, I'll have to think about the ways to. It would make it like an untenable position without gravity.
Well, it wasn't untenable for at least 1,000 years is what I'm saying. I mean, in fact, geocentrism has been more popular historically than heliocentrism. So if you consider 500 years a short time, we've only, people have mainly thought that the sun was the center of the solar system for only 500 years, whereas the idea that the Earth is a spherical Earth is the center of the universe was around at least 1,000 years. And all those 1,000 years, nobody had any idea about gravity, so they didn't have to have gravity to explain anything.
Yeah, but it wasn't really accepted, was it? I mean, it wasn't even taught in like high schools and stuff like that until after World War One. There was still a flexibility, and there were still schools that taught the Earth was flat right up until the 60s.
How a lot of schools? I would assume it would just be some weird religious schools that had taught that the Earth is flat in, like, let's say the year 1900 or something.
No, it only became like a mandatory part of the curriculum after World War. I think it was World War One. Yeah, early 1900s, 1940s. I think it came with some reformations to the education system. But yeah, this wasn't like a widespread view until much later, like very recent. In fact, it
So
was rejected.
are you thinking that maybe in the 1920s most people would say the Earth was flat?
I didn't say that, did I? I said that
No, I'm asking.
it wasn't mandatory teaching in schools until after World War One.
Right. No, I think you're probably right. I mean, look, a lot of people back then, people barely, not that many people graduated from 8th grade.
I'm just saying it's not as well embedded. You're trying to make the case that it's fairly new. I'm trying to take that further and say, well, it's mainstream wise, it's even newer than people give credit for 2,000 years or 1,000 years. I don't think that's the case, dude. I think some institutions were pushing it, but the majority in the whole weren't necessarily buying into it.
Yeah, I know it's new.
Like you're right.
I know it's new because, like, the way that Roots is saying, because there was no method for disseminating the information. So it's new in regards to everybody holding that belief. They wouldn't even have access to share that belief. There was no way to disseminate the information.
Yeah, but people are uneducated about a lot of things. I guess I was talking mainly about the educated elite, what their beliefs were. The teachers of the school, maybe.
It was definitely a top-down movement, came from authority. It was integrated into society, but there was a lot of pushback, even to the point where the moon landings weren't really that I'd say the moon landing was your turning point, where a lot of people who were on the fence decided, okay, it's a ball. They went to the moon. I think without that moon landing, I think the globe Earth would have been in a lot of trouble, to be honest.
Well, I mean, even if we'd never had the moon landing, people use GPS and satellite TV. I mean, satellite TVs have been working since the late 80s, so maybe that would have been the new turning point.
Yeah, but it's a bit different. Satellites don't need to be in space necessarily to work, whereas the moon landing is either true or it's a hoax, a full hoax,
Yeah,
right?
that's true. That's true.
It's a bit different. I don't know. I just feel like people like to make out it was everybody has known that Earth has been a ball since ancient Greece. I just get sick of hearing those ignorant comments. Not saying you
Right.
said
Well,
it, Matthew.
yeah. So guess I would say educated people have believed that the Earth was a ball since ancient Greece, or many educated people have. Maybe during the Dark Ages, people forgot, but yeah.
Well, listen, Greek. The Greeks had a cosmology, right? And it wasn't a globe, right? So whether Aristosthenes was a real person or not, it didn't take hold into the culture. There wasn't a new movement in his day. Nobody wrote about him, dude. He basically didn't exist in terms of primary source evidence. So that is just a story, right?
Well, yeah. There's no primary source evidence of Plato either, so ancient
Well,
history is kind of mysterious.
it is, especially when you're dealing with ancient Greece. It is. I do have concerns about history and a lot of ancient Greek history. So if that's all we've got, you know what I mean, then there's no other like evidence that the majority of the world were becoming globers, because the cosmologies didn't change. The Romans carried on the flat earth cosmology after the Greeks, right?
But
And if
I
the Greeks
I don't know if
truly
there's
had become enlightened, if the Greeks had truly become enlightened and it was widespread, the Romans would have known about it. They knew about all the ancient Greeks, apparently.
Yeah, I think they had read the ancient Greeks. I don't know history well enough to know. Well, yeah, two separate questions: what the scientifically minded Romans thought, and what the normal Roman peasant would have thought. Who knows?
I think we've been told a lot of myths that are convenient for the lot of stuff they're trying to push today. But a bit like the globe, it's if you use this epistemology of using primary source and then looking for cross references in the time of the person, Aristosthenes it's a story you either believe or you don't at this point.
Right. I mean, I generally trust that history is right, so I think Eratosthenes probably existed and probably did that measurement and calculation.
Yeah, I don't know how much digging you've done into history, but I've seen enough copy and paste. I've seen enough. I've seen enough to make me question. It may sound like I'm over questioning, but I've seen enough about that ancient Greek period to question a lot of what happened, so-called ancient Greece. But that's another subject.
Well, yeah. I mean, obviously, history is complicated, and historians spend their days like trying to look at sparse sources and figure out what really happened because, of course, historians are trying to make their own conquests look better than their enemies and stuff like that. So it's complicated to figure out what really happened.
Yeah, especially when you've got an authority who's pushing the ecclesiastic records as truth. Now we've got a biblical spin, and if you go against it, you're actually not just going against history; you're going against the whole church, right? So
Right.
they've made it very hard for you to go anywhere else apart from the agreed upon chronology that we've got.
And printing books was difficult there, so it's very easy to get rid of a couple copies of a book.
Yeah, in fact, there are lots of books that we know used to exist but don't anymore. We have no idea what they said.
Yeah, if you count up how many times the Library of Alexandria was burned down alone, you can start to see someone was clearly trying to get rid of information. Like coincidences are, you know, if it's happened 27 times, you've got to start asking if they're all coincidences. All the books burnings, all the removal of the old world information, you could see that there is a conscious effort to change what we fundamentally believe. Just after the Dark Ages, maybe 1600.
And parchment was also extremely expensive, so a lot of times books were just recycled. They washed off the ink off the parchment and reused it.
Yeah, if only you could go back in time with a Xerox machine and make a bunch of copies.
I think we'd actually be truly horrified at the actual reality, to the point where it's probably not worth it. And the more digging in history I do, the more I recognize that people probably don't want to know any of this because your whole identity could be at threat, right? It's a testy subject.
Yeah, I'd rather know the truth than not know the truth.
Yeah, I'd love to get into it a bit more with you, but this room is reserved for the flat Earth, so I won't take us down the history rabbit hole. But yeah, maybe one day we can talk about it, dude, because some of the anomalies in the Dark Ages, some of the lack of continuity, and the solar and lunar records and the star constellations don't match the periods of history that events have been attributed to. And when you start looking for patterns, you start noticing certain things that are happening, you can very easily put together a story where history has been retold, where identities have been taken over, where societies have been made up but potentially copied and pasted from previous. So yeah, there's a lot to the Dark Ages that we could get into potentially, but today's probably not the day.
Sounds interesting. Okay.
Yeah, and book burnings, book destroying was extremely popular during the Dark Ages. And like even today, you can't even get accurate information.
Well, no, because we're standing on the shoulders of liars, aren't we?
Well, this is information that should be gathered today. Like, should be recent information. Can't get it. Like the news just said, Elon Musk is the first trillionaire. No, he's not. There's trillionaires that have existed for a long time. You just never hear about them.
Oh, like who?
The Rothschilds, the Vatican.
Well, the Vatican's a group, but and the
They still
Rothschilds is
have
a
assets
family.
in excess of $7 trillion. But if you ask what their assets are, they'll say, "Oh, a few billion." That's a complete utter lie.
I know what you're saying is true because I looked into this, and there is a list of people who are removed from the public, like the Forbes lists. There was a whole documentary about how there's a whole group of people who don't get mentioned in the Forbes list because um, they have an agreement basically to be kept out of these discussions about wealth. So yeah, there's a whole list of people apparently who don't get included in those lists.
Yep. And they got their wealth by stealing trillions of dollars from the people. So that's also why they don't want to be mentioned. 'Cause during the 1930s, there was a U.S. senator who uh, went and did a speech there and charged the Federal Reserve with treason. That they were allowing, in the U.S. Treasury as well, they were allowing notes of $80 billion to be taken, processed, and paid for out of the U.S. Treasury, and they were not going to government programs. They were being stolen.
Who was doing this? He said.
Oh, the bankers, the white collar
Right.
criminals. And people still think there's gold in Fort Knox. Despite it never being audited recently.
What's that line in the Bible? God help me, my people are dying for lack of knowledge. The lack of skepticism, I think, is more fitting.
Yeah, I'm skeptical of a lot of claims of mainstream science.
Oh, really?
Mainly the methodological naturalism that they claim is the cause for all the different species. So I don't think naturalistic evolution happened.
So how do you think it happened then?
Intelligent design by a creator.
Okay. No, I didn't know that about you. Yeah, I mean, it doesn't. With my issue with evolution, I don't know if you hold the same view, but the idea that evolution is real, it must fit with all of the other natural, like the natural laws. So, for example, entropy. And entropy is basically increasing disorder over time, and that's, I believe, what we can see. The idea that more order over time develops into more complex and more orderful, that doesn't exist within nature. So for me,
Yeah.
it doesn't sit with the natural law of entropy that we're aware of.
Yeah, I think you're right.
I mean, I have other issues as well, but that's what put the nail in the coffin for me. Is there anything else that you're skeptical of, Matthew, apart from evolution?
Oh, well, the basic culture, the big lie of culture, which is if you buy enough things, that's what will make you happy. If you spend enough money or have enough money, that is the key to happiness. I don't think that's true.
Yeah, nobody believes that. Who believes that?
Well, well, people act like they believe it.
Yeah, I definitely don't believe that, dude. 100%. I believe you can get your life so miserable that you can have all this money and just not know what to do with it because you're so fucking miserable.
That's the only thing that's real and matters.
Say that again, D-Town.
Said love is the only thing that's real and matters, bro.
I don't know why, but I didn't catch it the second time.
Can you hear me now?
Yeah, I can hear you better now.
I said love is the only thing that is real and matters anyway, bro. Tangible.
Right.
Yeah. Also, it's temporary and all that. Love is real, man. I've had a house, I got a nice job and all this. None of this shit matters, dude. And then this shit fills you up. Love does, though. Yeah, my wife and my kid. I live for forever. I don't need anything else.
That was a
Yeah, well
wise comment. Yeah. I saw a guy on an Indian guy from a village, very poor. He won a competition where he won this really flashy SUV car, and he didn't seem excited or happy. And the guy said, "You're not excited." He said, "It's just a car." But he's sitting there thinking, "Well, this guy's from one of the poorest villages in the area, so he expected more." Anyway, when he got back to his village, they cheered him on like he was a celebrity. The whole village come out to see him and congratulate him, and then he started crying. It made me realize that, these material things, they don't mean shit, but as soon as he saw his village's reaction and the way they embraced him, it broke him. That's the power of love, isn't it? Really, that even the poorest person in the world is not impressed by material things. Hey, what's up, Killian?
Yo, good day, Brother Roots. Hope all is well. Midday 24/7. Hope all is well.
All is well, sir. Thank you. Good to see you, bro.
Amen. Many returns, brother.
Now we've got a few people join. Good timing, guys. We are looking for a new topic, so if anybody wants to speak up, now's a great time. Just to remind you guys, this is the 24/7 Flat Earth channel. So what we discuss in here is geometry, science, a little bit of philosophy, but it all needs to be around the orientation of the world. So if you've got any questions, speak up. Mo in the house as well. What's up, dude?
Hey, how you doing? Hope you're having a blessed day.
All good, bro. Long time. Hope you're well.
I am. Just enjoying the sunlight a bit, the heat, the warmth, the beauty, nature.
Lucky you, it's grey as hell over here.
I'm sorry to hear that, man. I was going through that last week. Last week was just everybody was just, I don't know, in a state of spiraling depression, bro. Whoever you talked to, nobody had any will to live. All of a sudden, everybody is smiling today and, all doing good. So that's good to see.
Yeah, good, bro. That's awesome. We had a terrible week as well last week, but then we had about 2 weeks of pure sunshine. In the UK, that's unheard of, dude. So we feel blessed
That's
already.
nice. I'm happy for that. You guys got lucky there. That is rare, man. It's almost as rare as in Germany. Well, Germany is almost as rare as you guys, I should say. Germans have somewhat of a decent weather.
Yeah, not 2 weeks straight though. That's rare.
Yeah. Have you had any good debates lately? Any globies actually, starting to turn around?
I'm here trying to push the narrative, but I'm not getting anywhere.
Who is Matthew? A globie, a flatty? What is he?
Glober.
So you really want to talk to him more?
Yeah, feel free. Matthew is, I would say, a resident glober, which he's
Man, that's
around a lot, but he's good. He's good.
well.
He's a good guy. He's honest. I like that.
Oh, thanks.
Let's see. Have a debate on the topic of Earth today, or enjoy the sunlight.
I think you and Matthew have a little chat with Matthew. Matthew sound like you've got a bit of time there, Matthew.
I have to get going in a little bit, but yeah, I have some time.
That was a call from another flat earther. Don't talk to Matthew.
Tamo secondo.
He left.
Probably an important call. So Matthew, maybe you can help us out with the conversation we had earlier. We're talking about high-end sport like golf. We're
Okay.
talking about how Neil deGrasse Tyson said in a famous interview that I think it was the Dallas Cowboys won a Super Bowl because of the Coriolis effect, or the rotation of the Earth, I should say, under the ball. But if that was the case, why is high-end golf with very, very high-end winning prizes? Why are they not incorporating any of the spin of the Earth in high-end golf, where it's extreme precision?
Yeah, my guess is that the difference it would make is less than the precision of how you can hit a golf ball, so it doesn't make. I don't think Coriolis makes any difference in any sport except for long range, target, competitions, rifle competitions.
Right, but then we hear Neil deGrasse Tyson telling his stories about how somebody won the Super Bowl, and then we know that I think No Tank said earlier that every 4 seconds at the equator, a mile passes under the Earth because of the spin of the Earth.
Right.
So, if it's going to affect a football, well, golf balls are hit further, 300, 400 yards, right, with higher speed as well. So, wouldn't it be more important and more relevant because of the speed and the distance in golf than any other sport?
Yeah,
And golf
probably
has a lot of
so.
money.
Except, like I said, except for long range precision shooting competitions where it's like 1,000 yards, a kilometer or whatever.
But do you get what I'm saying here? The amount of support that these golf companies give pro golfers, because it's so competitive and there's so much money in it, there would be a whole market for devices that would help them understand the orientation and the spin of the Earth. This would definitely be implemented. They have the money,
It
they
would
have
be
the
if it
means.
made a big difference.
Well, you're saying
I-
it shouldn't, but the math
I'm
says
saying
it
it probably
should.
doesn't. Right. I'm
The math.
saying that the amount of difference it makes is probably lower than the amount of precision you can hit a golf ball with.
Do you believe the
I mean,
story about Neil deGrasse Tyson told about the Super Bowl win?
I suppose he had his numbers right, because when you kick a field goal, it's going pretty far, and in that particular case, I think it missed by just a few inches this way or that way or whatever. So I could see it making a little bit of difference, but again, that difference is more like after the fact, not something they could plan for ahead of time, because the precision of how they kick those balls is they just want to try to get it in the field goal somewhere.
Oh, I get it. Yeah, I get it that yeah, they're not going to be able to in football, probably, but in golf, with further distances and higher speeds, those few inches become tens of inches over 400, 500 yards, right?
Right,
And
probably
to
so.
say that tens of inches or even inches don't matter in golf is just a
You
lie.
guys like if the earth is flat.
Yeah, yeah, that matters, obviously. The point is that I don't think you can you can't hit a golf ball that precisely. Let's say, for example, that you knew that Coriolis was going to make your shot go 3 inches to the left or to the right, or 3 feet to the left or to the right. How could you do something different? Because you're not aiming that closely anyway.
Yeah, I'm not, but the high-end golfers are, and they can put a ball pretty much where they want it most of the time, especially the very top end of that category. They really can. Tens of inches makes a big difference on a green. Inches makes a
Yeah.
massive difference on a green. And the amount of money in golf, it doesn't make sense to me. That there should be a device, or there should be something that they're using just to be sure. Just so that, even if it's just so that they know where to be more liberal, all right, at least I know there's going to be a slight force on the ball. Regardless of how drastic it is, it's good to know that. So for me, it doesn't make sense that the instruments and tech isn't being developed for this.
Wouldn't any wind make zero out whatever gains you might have had by knowing that anyway?
Possibly, but the wind is very much measured and taken into account in high-end golf. Like, it's really important, the wind, because yeah, they take that into account. The amount of garbage that they create for the golfing industry that is just useless, not needed, but people still buy it to try and improve their game by a tenth, by a smidgen. You don't
Yeah, you're
understand
right
how
about that.
addicted these golfers are, and if there was a device that would improve accuracy, trust me, they would be interested.
Yeah, and they're very rich, so they can spend lots of money.
Exactly. That's my point. My point is, in this particular industry, this is the one sport that there should at least be a device existing. Your average golfer may not own it, but the high-end golfers, they really would. It would give them the advantage by a few inches. But nothing like that exists.
Yeah, I'm not aware of any such machine. I know they sell calculators for target practice and like long range competition, rifle competitions, but I don't think they do anything like that for golf.
Yeah, I think with shooting though, I think it's to do with the bullet drop and calculating the angle at which you want to shoot based on the amount of bullet drop you'd expect. That makes sense. Trying to hit a target eyesight, right? So the bullet drop matters. But I don't think there's any device that takes into account the Coriolis.
Yeah, I'm not that familiar with either sport.
I just know from speaking to people who've been in the army, mortarmen, artillerymen that we've had in here or on the home server. And obviously, I know it's mentioned in the manual, but I've never met a gunner say, yeah, this is actually a practical thing we have to do before we line up a shot. So yeah. I just find it very hard to believe this tech doesn't exist.
Yeah, I don't find it hard to believe. I think makes it. I mean, I don't know why it doesn't exist, but it doesn't bother me.
Welcome to the channel, everybody who just joined. Good time to join. We're looking for a new topic. We stick to the Earth and its orientation. Feel free to ask any questions. We've got Globers here. We've got Flat Earthers here. Let's get going. Get started. I guess it's just me and you, Matthew.
Can you guess how much
Yeah,
Coriolis might
because
affect the shot at 1,000 yards?
I think it was on the order of a couple inches, but I don't remember. Somebody told me once.
Well, the video I saw from a sniper said potentially 2.8 inches.
Do you remember the distance?
1,000 yards. That's typically where long distance shooting starts, is 1,000 yards.
Yeah, that sounds reasonable.
But 1 degree, 1 mile per hour off on the wind, and you're 7 inches.
Yeah, so if Coriolis has only that much difference in 1,000 yards rifle shot, it seems like it would be even less distance or less of effect on golf balls.
Well, it would depend on the direction you're shooting, right? My question
Right.
is,
But
if you're shooting eastwardly, shouldn't your ball travel further?
if you're shooting towards the east, the ball would hit the target slightly than expected, and if it was the west, slightly lower, I think.
Funny how guns don't have compasses on them, right?
Right. I mean, some of those
Be helpful if they did. I would have assumed it'd be helpful to have a compass on a gun.
but if Coriolis is only making a difference of 3 inches and a 1 hour mile an hour difference in the wind makes a difference of 7 inches, then it seems like the wind is going to overcome any gains you might have had by knowing which direction you're shooting.
There are
And
calm days when they
it's
shoot.
also a good thing those shooters have all these little cheat sheets and calculators to help them. Because if they had to manually do the calculations on paper, it'd take them about 30 to 35 minutes just to do one shot.
So what about an aeroplane then, Matthew? We know that they fly an aeroplane regardless of whether they have an internal navigation system. You fly the plane the same.
Right, and that's a good example. Like, it doesn't matter if you're 3 inches off when you're landing the airplane because the runways are pretty wide. So, as long as you get close enough.
That doesn't ring true with the accuracy and efforts they put into keeping people safe. The orientation of the airfield is going to have an effect as well. If you're landing on a runway that's moving in a different direction, you're going to get pressure on the tires as it lands. You're going to get a force, angular momentum, whatever you want to call it. Those wheels are not designed like that. They're designed to land in a straight line.
Yeah, that's why you got to line up with the runway and go straight in. I mean, there's a little bit of you can land with a little bit of crosswind, but if the crosswinds are too high, they can't land.
Well, they can land, just it's called a control crash.
Right.
Yeah, see that the problem occurs when you take off from London Heathrow Airport and your earth spin is one particular speed there, and then you try to fly east towards Singapore where the speed is almost double what it is at London. And so Singapore is moving away from the aircraft, and so the aircraft should never catch up to Singapore.
Oh, nice.
But they do.
They do. Yeah,
Which
that's the
tells you
point.
what?
It,
Yours not
it
spinning.
tells you. No, it tells you that by the time the aircraft gets to Singapore, the relative speed relative to the ground has caught up. Because it flies in the air, not on the ground.
Yeah, but it flies too slowly. You would have to fly at supersonic speeds to catch up to Singapore.
Uh-oh.
No, I mean it catches up slowly, gradually over the hours of flight.
Are you just saying that because planes land, or are you saying that because you understand the math, or where's that coming from?
No, I understand. I understand the ideas, the geometry. Like if you took off at the North Pole with 0, speed relative to the center of the Earth, and then you flew all the way to the equator and tried to land on a runway that is moving 1,040 miles per hour, It sounds like it'd be impossible, but the plane does pick up some of that angular speed as it's flying towards the equator or towards Singapore.
So back to relativity.
Right,
That
because
pesky relativity that can't be experimented with.
no, relativity, motion is measured relatively. Like both motion and speed are relative numbers. One thing versus the other, either the airframe to the air, or the aircraft to the ground. That's why we have ground speed versus airspeed.
No, I get that. I'm just saying in respect to the Earth, we can't confirm that, right? So we just have to choose to believe you or not.
What about the Earth rotating? I mean, I think we have. Yeah, it's hard to tell that the Earth is rotating just by looking at it, but using logic and reason, I think there's good reasons for saying it does.
Is all of that logic and reason based on what we observe in the sky? 'Cause if it
Yes,
is, then we have
mostly.
to make. So then we have to make an assumption, right? That the sky isn't the thing that's moving. You have to make that assumption.
Right, that's
to
what
begin
happened.
with.
Yeah, that's what happened about 500 years ago with the switch from geocentrism to heliocentrism.
Yeah. It's just so much to have to believe, dude. Like, why can't we just know that the Earth is a ball? Why do we have to believe it?
I believe lots of things. Do you mean belief with no evidence? Like pretend that things are true? Mark Twain said belief is knowing, or he said faith is knowing, or believing things you know ain't true. But that's not what I'm talking about. I'm not talking about believing things that aren't true. I'm talking about finding the best explanation for what we observe.
Yeah, but if you did that in a court of law, when you're investigating a crime, it's not good enough. It's not high enough standard. But for some
Yeah,
reason,
you need.
for epistemology and cosmology, it's fine. We can take it further. In fact, we can build on it, build some law around it. Like that, to me, is suspicious because we already understand the standards required in order to prove something, right?
Yeah, I wouldn't say that science proves things. I'd say it comes up with good explanations, and then we have different criteria. Look at a bunch of different explanations and see which one works the best, which one is the simplest and has the best explanatory power, and that's probably the one that's true.
Right, but if you're building all of that off assumptions that people are assuming are proofs, then what you're doing is misleading people into believing that there's not you, but the globers are misleading people into believing that we've got direct evidence and proof using the things that we've discussed, curvature, motion. They'll have you believe that you can prove that directly, the curvature or the motion. Which is why I like talking to you, because you're one of the few globers who will admit, well, no, directly, you can't prove that, but obviously there's enough evidence to say the model works, right? And that's fine. I respect that, but most globers don't do that. They'll have you believe there's direct
Yeah.
evidence for curvature and motion.
This is like getting into epistemology and philosophy of science stuff, but I use the example, well, we can't prove that water is H2O if you're using that standard of proof. But I think there's good evidence, you can do electrolysis and chemistry works and the description of how water works. And, chemists think that water really is 2 hydrogens and 1 oxygen generally.
And why do you believe that we can't prove that water is H2O?
Because we're just looking at a bunch of different evidence and different experiments, and the explanation of how it happens is based on the assumption of atomic theory, that things are made of different elements and molecules
Molecules,
stuck
you
together,
mean?
stuff like. Yeah, so you can't prove that, but it is a great explanation, and I would say it's true because seems to be right.
Why do you think that we can't prove that?
How would you prove it?
It's
By being
what we have
specific.
already proven, okay? So you guys mean that you can't prove that the material is formed with molecules and atoms, right?
Yeah, so I guess it depends on what you mean by proof. Like, obviously, if somebody said, "Oh, could you prove that water is H2O?" I would say, "Well, yeah, I think there's good proof for that." But I would mean by proof, strong evidence in the lab and the chemistry stuff. If you're talking about though proof as like a logically deductive, incontrovertible argument, like here's the premises, here's the conclusion, using these logical syllogisms, I'm like, well, now you're talking about mathematics and logic, so I don't think you can prove it in that sense, because I think that's just for math and logic.
In terms of proving that the water is formed with 2 hydrogen atoms and 1 oxygen atom, it consists of molecules formed with those 3 atoms, right? So this is just the names given by the scientists, okay? They just found out that water is combined with billions of molecules, and each molecule is combined and it is formed with 2 similar atoms and 1 atom, and the scientists named them what? Hydrogen and oxygen, right? So this is
Right,
just
I agree
naming
with you.
them after discovering that it was formed with molecules, right?
Yeah, that
I
sounds
don't
reasonable.
think we have to prove that. Yeah? And you
Yeah,
guys
so you're
have a
saying that
deep understanding about.
you're saying it's sort of a linguistic argument that whatever it is, we have named that to be water. If you have 2 hydrogens and 1 oxygen.
Okay. Yeah.
I mean, in reality, we can prove things, right? I think it depends on your epistemology. If you've got an epistemology where, you know, we could be in a matrix and this could all be a simulation, well, then, yeah, I suppose you can't prove anything, right? And if you hold those types of epistemologies, then great. I feel like the way you've explained it is leaning towards that type of epistemology, where for me, you know, we can do tests and we can be, if you want to say proof, then I just think you just need to be more specific. You need to be very specific, but if you are specific enough, then you can prove things.
Yeah, I hear what you're saying, but I'm saying that many scientists use the terminology explanations rather than proofs. It's just maybe those of us colloquially can say proof, but really what we're talking about is, hey, we have enough evidence that this is true, so therefore we're going to say we've proved that it's true. And if you want to use that way of talking, that's fine.
Yeah, if you can
But
replicate the experiment, and anybody can do it, then it's pretty safe to say it's a proof. It's been proven. For example, water, right, at sea level will boil at 100 degrees, right? And I'm talking about water that you would take from a stream or from a tap. So if we keep specific and we talk about water from a lake will boil at 100 degrees at ground level. That's something you can prove, dude.
Yeah, I'm happy to say that you could prove that.
Right. So certain things can be proven. Then, would you agree?
With that, yeah, using that way of speaking and that definition of proof, yes.
Specificity. Yeah.
Like what? What is hard to prove? Or what is impossible to prove? That is well known to us.
Well, we're just talking about the idea if you take water and raise it at sea level to 100 degrees,
You too,
then
mate.
that's an example.
Did you dinner? You need to tell Mum you need to eat soon because you've got football in 1 hour. We've got to leave in just over half an hour. Yeah. Yeah. Oh, sorry for the hot mic.
So yeah, when I say that there's evidence for the globe, I say things like moon phases, the constant size, angular size of a full moon, seasons, the success of GPS satellites and satellite TV. I wouldn't call any of those proofs. I would call them evidence that the globe is the best explanation for how all those things work.
Based on the assumption that the ground moves, right?
Based on just, I'm talking about looking at all the different explanations. That one turns out to be the best.
What would you say is the best evidence for the ground moving and not the sky then?
The rotation of the stars at night and the rotation of the sun during the day, and the evidence that those are far away, so that it's more likely that we're rotating than that the whole universe is rotating around us.
So the fact that we have two celestial poles, basically.
The two celestial poles is more about the shape. You asked about the motion. The motion would be just the fact that the stars move, yet they're very far away.
But if there's a kinematic equivalence to whether the ground's moving or the sky's moving, how have you determined that?
When you're talking about motion, you're always have to sort of specify the frame of reference. So you're right that mathematically it could be the whole universe is turning around us, or it could be that the Earth is rotating. But I just think it's simpler to think of it as the Earth is rotating.
Why? Why is it simpler? Because of the model.
Right, because we can easily calculate the positions of the planets as ellipses. The rotation of the Earth around the Sun is an ellipse. Same with the Moon going around the Earth. Like these are all simple, straightforward mathematical models, and so it's more likely to be true than some sort of complicated cycles and epicycles like Ptolemy and his Greek friends did 2,000 years ago.
Yeah, I'm not vouching for Ptolemy, definitely not. But like, isn't that a bit just not lazy? I don't know if that's the right word, but isn't that just like too convenient? Doesn't it bother you that you're having to just make these assumptions and you're just going with it for the sake of it? Like,
yeah, that's what explanations are.
It's
There's
not
that you
exclusive,
just
but none of that's exclusive to a ball. Could all be happening on a flat Earth. We could
what
have
can't happen on
two
the flat
celestial
Earth is
poles. Yeah, go ahead.
what can't happen on a flat Earth, to my knowledge, is the idea that the full moon is the same angular size for everyone on Earth. Well, let's just say within 2% all night long. And so that means that the full moon is the same distance from everybody all night long. And then how does it appear at different places in the sky depending on where you are?
Well, that could be a combination of perspective, and for all we know, the moon may not be a solid object. Like,
It looks like one.
it does, but holograms look solid. Doesn't mean they are.
That's
Yeah.
true.
No, I guess I'm interrogating you a bit more than I probably need to, but yeah, I just
Well,
if I
I'm
was in
happy to answer.
your shoes, yeah, I'm just think if I was in your shoes, I just trying to figure out how you can be so blasé, I suppose, about the fact that there's a lot of assumption needed at the very beginning, right? There's nothing exclusive to a ball, really. Like we're making assumptions about the moon and the sun, but if it wasn't a physical object and we understand perspective fully, quite which could be what you would expect on a flat Earth, created by a creator.
Oh, I forget that I can't post images here. Oh well.
Don't know if any of the mods are on who want anyone can give Matthew the perms.
It's all right. You can click on the link if you want to see it. But in general, I think there are some things that work better if the Earth is a globe than it does if the Earth is flat. And constant angular size of the full moon is one of them. Or the sun every day too, but that's a little bit harder to see.
Hello.
Hello, how's it going?
That's good. How about you? Why no one talking?
So I want to debate.
What do you want to debate?
I say that the Earth is not flat.
Good. Present best evidence for being a ball in space, then. Go ahead.
Well, you can go and learn what you don't understand, but the flat Earth model does not explain things properly. Like, you get what I mean? Like, for example, how does the night and day happen?
Irrelevant. You need to ask a better question. What is our best evidence for Earth being flat? That's what you should be asking before you ask irrelevant stuff about the sun and the moon and the stars and all that shit. We're talking about the Earth in here. Ask the question.
Okay, my country had sent a lot of satellites to space.
What are they going to prove?
Yeah, it doesn't have to prove anything. Like, we can just spy on all the Earth and, you make space weapons while you still think the Earth is flat.
You're being very weird right now. Present evidence for Earth being a ball.
It is not a ball, it is spherical.
Same thing. You know what I mean. Okay, we call it spherical. We can call it an
Okay,
oblate
you can
spheroid.
go. You can go and watch Professor Dave Explains.
No, I've
You know
listened to
him?
Dave and all of his idiots. They come in here all the time. We talk to them all the time. What is your best evidence for Earth being a ball or spherical, if you want me to call it that?
Well, we have seen the Earth from space, and we had
Have you?
pictures.
Okay, let's do that then. Let's do the pictures. What height was the satellite at when it took the picture of Earth?
Well, I don't know. You can go
No,
to
your
the
claim.
NASA website,
Your
or
claim.
there
Look,
are a lot of space agencies. You can go and ask about specific pictures that you want to understand things
I
about.
would no, I wouldn't ask you the question if I didn't already know the answer. I know the height that the satellites are at, which they take the pictures of Earth from. Okay, but you don't, and it's your claims. You need to look it up, and then you bring that back here, and then we scrutinize it with math. Can you actually take a picture of Earth from, let's say, 250 miles up? That's where the ISS is at.
They do all the time. You can go. There is a live stream for NASA where it streams.
I've seen it. It's not
This
live, dude. It's not
it is
live.
live, and it
No,
is from space.
yeah, they stitch it. It's 250 miles up. Do you know how much you can see of Earth from that height? We're gonna do the math, you and I.
No, I don't. Well, I just want to say that me being ignorant about these things doesn't mean that the Earth is flat. Plus,
No, but
I can go and
that's clear.
learn, but you just say, "Oh no, how could it be?" and that's
No, I
it.
don't.
You don't understand something, and
I
instead of trying to understand, you say that it is not nonsensical, and therefore it is false. And then you bring a
haven't done
model
that.
that doesn't explain anything.
I haven't done
A
that.
flat disk.
As a matter of fact, we don't claim a flat disk. That's what you saw on TV or some kind of weirdo flat Earth society shit. Nobody here claims a flat disk in space. Okay? We are claiming that Earth is the floor. It's the foundation of the universe that you and I live in. Okay? You are at the floor. Okay? And it's flat on account of water being flat. About
Okay,
72%.
gravity is real. Do you agree?
Which gravity do you want to discuss? But I don't think we should sidetrack, okay, dude? There's 80 different kinds of gravity. We can talk about gravity, but we're going to discuss the floor first. Why do we say that the Earth is flat? That's the question you need to ask. You should ask me.
Let me guess. Why do you say the Earth is a floor?
Yeah, I'll show
What
it
the
to you.
hell does that mean?
It
The
means
Earth
that
is a planet. The Earth is a planet, bro.
It's the foundation that we're standing on, and we're looking up into the sky, and we can see things go on up
Actually,
there.
the Earth is a very small planet compared to other stars and other
You don't have any
planets.
evidence. You don't have any evidence for that. We're not going to talk about the sky. We're going to talk about the Earth first. Okay. So now
Oh,
I'm going to
so did I go to space to verify? Okay, I might
can't
be an
verify it from
astronaut when I
space.
grow up.
Listen to me. You can't verify it from space because from the ISS you can only see 3% of the Earth's surface. Do you realize that? You can Google it right now. How many percent of Earth can you see from the ISS? Google it. I'm going to educate you first before I can debate you because clearly you don't know
Okay,
any
sir,
numbers.
I'm gonna Google it now. So what do you
Okay,
want me to
I'm waiting
Google?
for it. How many percent of Earth can you see from the ISS?
How much of the Earth can I see from the
How
ISS?
many percent? Do you know what percent is?
Yes.
Yes. How many percent of Earth can you see from the ISS?
Okay, one second. How many
Absolutely.
percent
Oh, we have a
of
lot of time.
Earth can be seen from the ISS?
What percentage would you imagine you would see from a 4,000
Let's not sidetrack here. I want to hear
mile
this answer.
radius
Okay,
sphere?
it says the short answer depends on whether you mean at any single instant or over the course of its entire orbit. At one exact moment, you can see between 2.5 and 3% of the Earth's total surface area. And over time, because the ISS is constantly orbiting, it eventually passes over and sees roughly 90% to 95% of the planet's habitable surface, covering
Yeah.
about 90% of the human population.
All right. So the space balls that you have seen, clearly they're not taking from the ISS, and I'm going to grant you that they can see 90% when they fly around the ball, if that's what you think they're doing. Okay. But the problem is that when we take those pictures that they send us, so here, look at the chat. Are you able to see the chat?
Okay, one second. I'm gonna look at it.
Nobody else post something in chat while I go over this, please. There's a picture in the chat posted by me. It looks like Earth. It looks like the space ball you think you live on, right? Have you seen pictures like this before? Don't worry about the numbers. Just look at the picture.
What a cool picture.
You see the picture
Is
of Earth?
this? Yes.
You see all the blue stuff? Do you know what that is?
Water.
Yeah, it's water. So here's the thing. They sent us pictures of Earth like this one, and they say this is where you live. So when we look at that, clearly you can see that the water is curving around that ball, correct?
Yes.
Yeah.
Exactly.
So we decided let's confirm if that's actually the case, and there's a very easy way to do that. In that picture, you can see some math that we have done. If Earth has, I don't think you know the
But
radius of Earth, but
I
it says.
don't understand math. I'm an idiot in math.
That's why I'm going to explain it to you like you're 5. We have been given a radius. Do you know what the radius is?
Yes, the radius is, the line from the point of a circle to its circumference.
Right. So that value that NASA has given us is 3,959 miles. Can you repeat that back to me?
3,959 miles radius.
Exactly. Right. And because we know that radius, we can easily calculate how much water needs to curve over specific distances. And there's a chart there you can look at. So for 10 miles, for example, Earth has to actually curve 66 foot. That's about 20 meters. Are you a metric guy or imperial?
Nah, I'm a metric.
Right, me too. I'm from Sweden, so we can do it in kilometers. Over 16 kilometers, there has to be about 20 meters of curvature. You can go to any AI, they will confirm this for you. You can even go to earthcurvature.com. That's a calculator, and you can type in a distance, maybe 10 miles. It'll tell you 66 foot of curvature has to exist between point A and point B. Do you understand so far?
Yes, sir.
Good. So because we have been told that Earth's radius is 3,959 miles, we can use math to figure out how much it needs to curve. We already went over that. Now, here's a method that you can check for yourself, and almost everyone in here has checked for themselves, right? So you find a friend and a 10-mile wide lake, that's 16 kilometers for you. You have your friend bring a mirror, and he can flash that thing from the other side. If you see that flash, since your friend is maybe 180 centimeters or 6 foot tall, that's like the average height of humans, right? If he's 6 foot
Yeah.
tall, you should not be able to see that flash. In fact, your friend would have to be 30 feet tall for you to see
Okay.
the
I
flash. But
I
water
heard your
doesn't
point.
curve. Yeah, but I want to go over the laser one as well, right? So water doesn't curve. That's why you see that flash 10 miles away. Now, if you want to measure this, and this is what we need to do, right? To confirm that the space ball is real or sphere, if you place a laser 30 centimeters over the water on beach A, you shoot that laser 10 miles away, 16 kilometers, to beach B. If you're living on a ball with the radius 3959 miles, that laser has to end up about 50 foot in the air over the beach B. Do you understand? It has to, because the curvature
Okay,
is...
you know what? I think the Earth is flat. You convinced me, sir. The
No,
Earth is a
I don't
flat
want... As a matter of fact,
thing.
that's how you got into trouble the first time. That's why you think you live on a ball. Someone convinced you, right? But this is a test you can do yourself. The fact is that
Okay.
when we do these laser tests, we shoot them 10 miles out, 1 foot over water. The laser ends up 1 foot over the water on the other side because water doesn't curve; it's flat. I'm going to paste the
Yes.
laser test that you
Okay.
can. When you have time, you can watch this laser test. Someone did a laser test over 21 miles. There should be 266 foot. That's almost 100 meters of curvature.
Yes.
It's not there. So the video is in the chat. When you have time, you can go watch it. Now we can talk about
Okay.
anything else.
So thousands and millions of people who work in space agencies are fucking liars.
No, I don't think they're lying. I think it's tradition. You know, when the first time someone told you you lived on a sphere, I was probably in
Oh,
third grade.
they are all manipulated, right?
No, it's just tradition. They didn't ask the right
Tradition.
question.
But I'm a traditional guy.
Why do you think your teacher in third grade told you that you lived on a ball in space? Because she believed it 100%. Because somebody told her. It's just tradition at this point. Nobody goes out and check. We took these
Yeah.
pictures from space and we checked. Water
So,
doesn't
but
curve.
can I ask some questions as I'm a flat earther now? I want
Yeah,
to learn
go
more
ahead.
about the flat earth model.
Absolutely. Now you can ask questions about space and satellites and all the other shit. Go ahead.
Okay, how do we explain eclipses?
What's your problem with them?
Like, the eclipse happen because, you know, the position between the planet Earth, the moon, and the sun. So on a flat Earth, how do we explain this?
Are you saying that it's the Earth's shadow on the moon when there is an eclipse?
Yes.
Can you prove that?
Well, I just want to tell you that I don't know exactly. I can go learn about that, and then later I'm gonna come back and tell you.
Yeah, that's better. That's better if you read up on it a little bit. And if you can prove that it's actually the Earth's shadow, then we can talk about it. But until then, it's pointless.
Okay, until then I say peace, and I'm so proud because I went live on YouTube.
Yeah,
Bye.
you did. And you were very civil. It was a pleasure to talk to you. If you have more questions, feel free to stay. Maybe you can listen. A lot of people are going to come in just like you asking the same questions.
Hello, human.
Hello, Nee. How are you? Okay, so the other guy left. YouTube listeners, hope you enjoyed our little discussion here. How are you doing, Nee? What can we help you with today?
I'm good. How are you doing?
Great.
What?
Yeah, I'm great.
Oh, sorry. I'm not here clearly.
Okay. I'm doing good.
Yeah, me too.
Alrighty.
Where are
Anybody
you
else?
from?
Oh, I'm from Sweden. Where are you from?
Sweden.
Sweden.
Vietnam.
Oh, okay.
Sweden.
Greetings.
Wait, let me search your country.
Yeah, it's in the north.
Sweden. In the north of what? Of where? Europe.
Yes.
Oh, the north of Europe.
Mm-hmm.
You near Norway and Finland.
Yes, I'm right in the middle of between Norway and Finland.
Well, Finland. So sorry about my pronunciation. Not good at
That's
all.
okay. The Finnish people forgive you.
Oh yeah. Mm. Oh, beautiful country.
Yes.
So why is so quiet in the room?
Not too many people are here now. Most people are listening. Right now I'm talking, and if somebody else were to talk, I would let them, and then I would go on mute. We only do one-on-one here if we can help it.
Oh. 24/7 flat Earth Discord. What does it mean?
Well, it means that we talk about Earth here. Some people believe that we live on
Oh.
a ball in space. Have you heard about that?
No, no, no.
You think you live on a ball in space?
No.
Oh, okay. Great. Where do you think you live? What's Earth to you?
Somewhere I can eat ice cream.
Yeah,
I don't
sure.
know.
Right. Well, our claim is that we do not live on a ball in space, because we can't
Yeah,
confirm it when we try it out.
it's so crazy.
Yeah, it's a little bit crazy, actually. People think the Earth is spinning, but we don't feel that.
Yeah.
Yeah, great.
I don't know what to say.
That's all right. Maybe someone else will come in. We'll talk a little bit to them. Or you can look at the chat. There's some interesting stuff in there. We did a laser test over 21 miles, and the water wasn't curving.
Mm. Wait, let me read. No thanks, I quit critical thinking.
Oh, yeah, that's funny. We scroll up a little bit to my post with the Flat Earth Judge 52 minutes after the hour. It's a good post. So you can prove
We
to
have
yourself.
been told
Hmm.
the Earth's radium 3,989 miles away can use implement. How much work the need to curse over this thing? Did you use ChatGPT for this one?
No, I wrote it myself, and I've actually done that
You
test
wrote
myself.
it? Everything?
Everything.
Are you a scientist?
I'm very good at talking about Earth. I've studied it a lot. You can call me a
Oh.
scientist if you want to.
Oh. It will end up 1 foot over the water on the other side. Honey? What is this picture? You write it? You make it?
Somebody else made the picture, but the calculations are correct. Over 10 miles, water has to curve 66 foot. That's about 20 meters. But I promise you, in your lifetime, you probably stood on a beach somewhere and you saw further out than that. So there is no 20 meters of curve.
It's crazy.
I know it is. It is crazy. Nobody told you about this before. Huh? You've never seen water curve your whole life, yet nobody has, because water doesn't curve. Have you ever gone ice skating?
Not yet.
Have you ever gone ice skating?
No.
But you know that water freezes in the winter and it becomes ice, right?
Yeah.
So you go to a lake, you don't have to skate uphill 20 meters and then slide down to the other side. It's completely flat. And you know that they say that the earth is covered in water, 72%. Have you heard that the earth is covered with water about 70%?
Oh, yeah. Yes.
Yeah, so if earth is covered by 70% flat water, it cannot be a ball, correct? Yeah. So there you have it. Yeah, that's good evidence for it not being a ball. Something to think about. If you want to, you can look at the picture, you can study it a little bit. Maybe you want to look at the video right underneath. There was a 21-mile test with the laser. No
My
curvature at
brain
all.
gonna blow.
Yeah.
Explore.
Oh, you're very gracious, actually. Most people freak out, but you seem to take it with stride.
Interesting.
Yes, it is. Very interesting. It changed my life when I found out, for sure.
You just like oh no, my English is so bad. I don't know.
It's all right. That's why I pasted it as text, so you can probably even translate it into your own language easily. But I think you understood it. You seem bright.
Yeah, but in the picture, I don't understand. So complicated. So many numbers there.
Yeah. You can go to, if you want to play around with it, you can go to, I can type in a site here. Let's see. Let's see.
Meaning no straight lines even at the microscopic above. What does it mean?
If you want to play around with it, you can go to earthcurvature.com and type in, for example, how much curvature should it be over 20 miles, and you will see it. You can even use kilometers if you like the metric.
Website?
Yeah, it's at the bottom.
Let me search it.
There.
Ooh, what the heck is this? Accurate calculator. Calculator. You are supposed to see it.
So let's say that you're 5 foot tall. You type in, let's see, what does it ask for? It asks for your height, right?
Oh.
Curvature.com. So it says the distance.
Hi there.
Oh, you can just type in like 10 kilometers or 16 kilometers or 20 or whatever. Over 20 kilometers, you calculate that. There should be 31 meters of curvature. But there isn't. You know this. Water doesn't curve.
What's up, guys?
What's up?
I think I need to go now. See you
All right.
later.
Well,
Really
come back
interesting.
anytime. Come
Have a
back
good day.
anytime.
Yeah.
We're here 24/7.
Have a
Yeah.
nice day.
Yeah, you too. All right. Anybody else have any questions about Earth?
Yeah. Did you already know that the Earth is flat?
Yeah, I know it. We just went
How
over
can
it.
you prove it?
Yeah, I pasted a proof 52 minutes after the hour. If you go into chat, there is a post by me starts with the words, "We have been told." Can you read that?
Yeah.
Yeah, go ahead. Read that, and when you're done, we can ask you questions about it.
But did you not ever seen the space
Yeah,
and
I've seen pictures from space of Earth, so I
pictures
decided to
from
go.
the moon and
Yeah, I've seen them. As a matter of fact, in that post, there is a picture of Earth in there, isn't there? The round ball, do you see it in my post?
yeah,
You see all
yeah,
the
yeah.
blue stuff? All the blue stuff on that Earth picture is water, right? So water curves around the ball. Agree?
I see, but
Yeah. You can see that the water curves around the Earth, right? Everywhere. You understand?
no, sorry.
Okay. Well,
But
maybe if
I can understand your point of view.
did you read all the text in the post?
I'm on.
Yeah, take a little time to read that, and then we can discuss it.
Are you here?
Oh yeah, definitely. Not going
Um,
anywhere.
I've read all the text that you post, but I have some some things that you should know. Um, about the light refraction on the laser test, there are some error because you know that the Earth's curvature is measurable, but the effect is small over short distance. 10 miles is far too short to see the curve with the naked eyes, you know?
Oh no, it's not a problem. Over 10 miles, there has to be 66 foot of curvature. That's about 20 meters. So if you see something that's 10 miles away, you shouldn't be able to unless it's over 20 meters tall. You've seen things 10 miles away your whole life, islands, boats, things like that, because water doesn't curve, it's flat. I'll even grant you some atmospheric refraction if you wanted to. We can take standard refraction, that's about 15%. So now instead of your friend being 30 foot tall, he's 29 foot tall. I mean, it's not that much of a difference. I could grant you 50% refraction, it's still not going to help you. There's no I can, as a matter of fact, let's see here. If I grant you 120% refraction, which is insane, that never happens. I'm not even sure we can reproduce that in a lab. But let me do that. Your friend would have to be 9 foot tall for you to see his mirror flash. There are no humans alive that are 9 foot tall. Water doesn't curve, my friend. You can go test this yourself. You've never seen curving water your whole life. It's flat, with or without refraction. But I just gave you 120%.
And how are
And
you so
you
sure it's flat?
And you never try to travel by plane to see that the Earth is not flat.
Well, I fly a lot at work, right? But look, do you know that the ISS, they claim it's 250 miles up? Do you know that they can only, how much do you think they can see in percent of the Earth? You can Google it. How many percent can be seen from the ISS of Earth?
It's because the Earth is really big, but the
Yeah, it is
astronaut
big.
in the
You can
space
only see.
can see that the Earth is not flat.
No,
You
no,
know?
we did that, right? I granted them the ball. My whole life, they showed me the picture, and I was like, dude, I can see Copenhagen on that ball, and it looks like the Ura Strait, the strait between Sweden and Copenhagen. It looks like it's curving. And when I went there, and I looked, and I saw, little birds flying around on the other side, and the white sand on the beach on the other side. That thing should be covered by 20 meters of curvature. There was no curvature, so I knew that the picture was fake. That's why we
Wait,
can't we try to
Why the
confirm their
pictures are
pictures.
fake?
may I say something?
You mean
Of
that the
course, I mean, because
pictures are created
look,
by astronaut uh,
May I
and the
say something?
government?
it's bullshit, okay? Because when we look at the picture,
Bullshit.
there should be curvature between Denmark and Sweden. There is none. I've been there.
And you don't
May
believe
I
what you
say
see?
something?
Yeah. I mean, we have hundreds of these tests. As a matter of fact, in the chat, there is one 21-mile laser test in the Great Salt Lake in Utah.
May I say something?
Wait, just a second. I'm
You.
talking to this guy. You can go after
Sorry.
him, okay? Hang on a second.
Sorry.
So
And
look,
why
dude.
don't you
Look,
go into space?
that was my point before. You can only see 3% of Earth from the ISS. There's no way they can take a picture of the full ball from that height, okay? So they stitch it together, they wrap it around the ball, it's all flat. And then they show it to us, and they even admitted it. In 2012, when they released the new iPhone, every iPhone had a picture of a ball Earth on it. Maybe you remember. It was the background. President Obama even stood up and he had like a little speech about it. Oh, we finally have a picture of Earth from space. And then 3 years later, NASA came out and, well, not exactly. We had our graphic artists take thousands of pictures of Earth, and then they stitched it into a big, like a square or whatever, and then they just kind of wrapped that around the ball. And then one of their guys was responsible to add colors and clouds and all of that. So it's all done in Photoshop because it has to be, because we can't take full ball pictures from the ISS. Anyway,
So
so
what at the end of the Earth if it's flat? Like void? Like the space? Or
well, we're just thinking about it as the floor of the universe. We're on the floor, right? And most of it, because they say that Earth is covered by about 70% water. Have you heard that before?
no?
You haven't heard that Earth is covered by about 70% water?
70?
Okay. 70. Yeah, that's
It's
what they say. You can Google it. They
really big.
say Earth has about 70% water covering the surface, right? So if water is flat and 70% of it is water, then it cannot possibly be a ball. So I don't know the shape of Earth. I'm not making a shape claim. I'm just telling you that most of the surface is flat. Now we have mountains and things like that. That's called topography, obviously.
But the
But
water is attracted to the
yeah,
center of the Earth.
yeah, we can't prove a center of the Earth. Nobody has been there. But anyway, think about the place you live as the floor, the ground floor of the universe. Whatever you're on a flat surface. Whatever goes on in the sky goes on over a flat surface. Moon and the sun, they circle above us. They have their paths. They do that. All you know is when you wake up in the morning, you see the sun coming in from the east and it goes away from the west, and somebody else sees it over on that part of the earth as it's coming in from the east and it leaves in the west. That's all we ever seen. Nobody's ever seen a orbit or anything. As a matter of fact, we only see things cross from one side to the other. Same thing with the stars.
But
Not that that has
it's
anything to do with
the
Earth.
warping of space-time, but the mass of the Earth. It's for what
Dude,
the
don't
water
read
is attracted at the center of the Earth. You know?
warping of space-time, dude. You're word salading now, but that's normal. Just chill and think about it, okay? There's no such thing as warping of space-time. That's some bullshit that Einstein or whoever was controlling him made up. And we can't prove it either. I mean, if I tell you to prove space-time, can you do that? No, just a theory.
But can you? Never mind, Doxit.
Einstein was dumb as a rock. It's just ironic that his name actually means one rock.
And you think that we're lying to you?
No, I don't think anybody's lying. Who told you that you lived on a ball in space? Probably your third grade teacher, right? You think she knew? She just told you because that somebody else told her. It's tradition. That's all it is. We got to break free from the tradition because it's wrong. We have technology now where we can shoot these lasers 30, 40 miles. They didn't have that kind of tech when they thought that they lived on a ball, but we do now. So that's why flat Earth is growing, because we can actually prove it now. And I gave you a method so you can prove it to yourself too. Take a friend to a 10-mile wide lake, have him flash that mirror. If you see the flash, you know that water doesn't curve. And honestly, if I'm asking you in your mind, you don't have to answer it even. Do you really think water curves? You never seen that. Of course it's flat.
And you think the moon is flat too?
I actually don't know the shape of the moon. I'm not going to make a claim about it. I can grant you it can be a sphere for all I care. It doesn't change the fact that the surface of Earth is flat.
But you can see it.
I mean, a telescope only has one lens, right? You can only see one thing there, so you can't actually tell if it's flat or curved or round or anything. You see a 2D picture, don't you? But it could be round, like a ball. I don't mind. For all I care,
I
it
don't
can be
know. I don't
a
know, bro.
sphere. I know. It's tough to take it all in. Think about it for a little while.
Where are you from? America? USA?
Yeah.
It doesn't
Yeah.
matter where any. It doesn't matter where any of us.
I'm
Like
just chit-chatting a
matter.
little bit. Keep it light. So I'm from Sweden. That's in the north, in Europe.
Is it's just to know what's your below, you know? Because I'm in France. I'm French, you know?
Yeah.
And um the sun turned around us.
Yeah, you see it come in from one side and it leaves on the other side. It's just
And we
perspective.
turned around the sun.
That's what they say, but nobody has been able to prove it. It's actually funny that they tell people it's the opposite of what they experience. So no wonder people are confused. Because when you're a child and you go outside, you see the sun clearly move. But the globers people, the heliocentric people, they tell you no, it's actually the Earth moving. The sun is standing still. So they're telling you the opposite of you experience, and that kind of it's a way to brainwash people, to be honest with you. It's not healthy. They also tell you that Earth is spinning, rotating, but you don't ever feel that. So it's also the opposite of what they say. Could be
Okay,
that
but
it actually is standing still.
okay, I know. But why almost everyone think differently?
Tradition. As I said, somebody came up with the idea a long time ago. They preached it, people believed it, and now everybody just keep supporting that story, right? But they can't prove it. And
But
when we go out and test it, it doesn't measure curved; it measures flat.
can you prove that it's just tradition?
I'm being gracious. Some people would say that there are people out there who actually know and they're actively lying. I can't name a single one, so I'm just going to say that it's tradition because that's what makes most sense to me. Why else would they lie? I mean, I can't come up with a good answer for that. So, and I don't know who they would be. Do you?
No, and you don't feel like proving it's yourself because
Oh,
all
it,
the data that you read is made by another persons, you know?
which data?
It's some data of
Are you making this up, or do you know? Is it the belief of yours, or do you actually know what you're talking about now?
I know what I know.
You know you live on a ball, or do you believe you live on a ball?
I know that live in
All you ever experience.
ellipsoidal shape. It's not a ball. It's
Oh.
It's a ball, but it's
Spheroid.
flattened
Flattened.
on poles.
Is it? Is
you
it
know,
an O? Is it an
in the north
oblate?
and the south of
Is
the
it an
earth.
O? Is it an oblate spheroid?
Yeah.
Yeah, that only means that they have 14 kilometers extra at the equator. In the scale of it all, you can treat it as a perfect circle or a perfect round ball. 14 kilometers is nothing compared to the radius of Earth, which is claimed to be 3,959. Now, if I asked you to repeat that number, could you?
And what about
3,000.
gravity in the earth? Because when you are in the peak in the top of Everest, you are most light.
That's 8
But
kilometers, isn't it?
when you are
8 kilometers.
in deep deep cave, you are more weight, you know, loud.
Well, you make if you
um,
want to make that claim, you're going to have to present evidence for that because we haven't seen any weight differences anywhere. As a matter of fact, there was a project a few years back, the Gnome project, where they sent like this little gnome around and they weighed it on every place and they couldn't find any differences.
it make difference.
Yeah, if you have evidence for anything like that, feel free to present it.
You can feel it.
You can feel it. How?
But why are you think that the the Earth is literally flat? It's false, bro. Wake up.
No, we measured it flat. I just show you the laser test. You shoot that laser 1 foot over ground, over water to the other side, it should end up about 60 foot in the air. It doesn't. It ends up 1 foot over the water because water
Did you
doesn't curve.
ever seen the Earth by yourself in the
The what?
space?
I've seen what?
The Earth.
The Earth. You can't see the Earth from space. We've never been far out enough. You can do the math on that. You have to be 8 up.
Did
You
you
have to
ever
be.
seen the Earth
No,
in the
nobody has.
space?
No, nobody has. I've seen pictures of it. And that's when I took one of those pictures and I went out and to check. Wow, it looks like it's curving over here. Then I went there, was no curve, no curving water to be seen. Have you ever gone ice skating, my friend?
I think that if you go there, you'll see.
I've been all over. I travel a lot. I've never seen curving water ever anywhere. And in the wintertime, you don't have to skate uphill 20 meters to slide down to the other side, but you should have to if you lived on a ball on a 10-mile wide lake. Doesn't happen. Ice is flat because water is flat.
Did you ever seen a big bridge?
Yeah, I've seen many bridges.
Okay, so a big bridge is curved, you know?
Well, did they design it that way, or is that what you think it is? Which bridge? Maybe you can find one. You think bridges curves according to Earth curvature? How long is that bridge? That would be like a mini Earth, like the smallest Earth ever. Like a
By
ping.
example, the Shanghai
Yeah, that one is about
Yangtze
100.
River
How
Bridge.
how long is it? 120 miles or whatever. There's no curve there. They
It's
didn't. They didn't say.
1,155 feet.
Yeah, there's
Like
no curve. There's no curvature over that distance at all. None. You can probably get the blueprints from the engineers. They didn't take curvature into account when they did that thing.
it's a little curved, like 1% of.
Maybe, but over that distance, it should be a lot more curve if the Earth was curving, right?
So the
Anyway,
the
you can
curve.
go to earthcurvature.com and you can type in the number, the length of that bridge, and let's see how much curvature there should be from one side to another. So no, there are no bridges that take curvature into account.
But the floor, you can see the floor, yeah?
See what?
See the curved on the floor, like big big fields, for example. The big fields are curved because
Are they?
the Earth is not flat.
Do you have any evidence for that?
Yeah,
Present it.
with
A field is not a good measure either. You should probably do this over water because fields can be topography, right? We can have curves in mountains and things like that. You get that, right? So pick some water measurement instead, where somebody has measured Earth curvature over water. That's perfect. We don't have to do it over land because that's impossible. People can just say it's the land that's curving.
bro, what you saying doesn't make any sense.
I know it's gonna break your brain, dude, but don't worry about it. Think about it a little bit and you'll be just fine. We did. We pushed through. It's called cognitive dissonance. It's when you have a strongly held belief and you're presented with new information, your brain's going to freak out. It's going to come up with all kinds of weird explanations. But if you can push through, you're going to realize quickly water doesn't curve. We
Bro,
live on.
with you, I feel like I'm losing my IQ
I
with you.
know. It happens. That's
Because
cog
that
dis.
doesn't make any sense.
I know it doesn't. The first time I heard it, I thought I was going to go crazy. Okay, just think about it. Go
But you're
do the.
American, and
No,
American are
I'm from
a
Sweden,
little.
not American. Swedish.
You're Swedish.
Yes, I'm from Sweden. I live in the same continent as you. It's called Europe. It's
Near
flat.
France?
Huh? France,
Near the
yeah.
France?
I've been to
Yeah.
France, yeah. I've been to Paris. I've saw the Eiffel Tower. Took the elevator all the way up. Beautiful country, good looking women, good food. I loved it. Anyway, underneath my post in the chat, as a matter of fact, I'll just post it again. When you have time, you can go look at this video. Some
Anyway,
dudes, they shot the laser 21 miles. There should have been 100 meters of curvature covering the beach, but we clearly see it in the footage here. They shot the laser 5 foot over the beach on beach A, shot it over to beach B,
bro,
ended up 5
we
foot
don't
over the
agree, but
water.
I think you believe that you're saying
It's
because
not a
you have
belief, it's a measurement.
some fake proofs, but
No, this is a
you believe
method.
what you're saying.
No, it's a method. You can go try it yourself. That's why I'm telling you, do not believe me. That's how you got into this trouble in the first place. If you think you live on a ball in space, you believed people. Do not believe me. I'm giving you the method. Go take a friend to a 10-mile wide lake, have him flash a mirror. If you see that flash, your friend better be over 30 feet tall.
No, bro.
Yeah, because that's how much it should curve between the two of you. If you're 6 foot tall, that's about 180 centimeters. But water doesn't curve, dude. It just doesn't. Now you can go check it yourself. Or you can look at the laser test I pasted in the chat. 21 miles should be 100 meters covered curvature, but you clearly see the beach on the other side. And the laser, it didn't end up 100 meters up in the air on the other side. It ends up 5 feet over on both beach A and beach B because water doesn't curve. Earth is
Bro,
flat, dude.
I don't agree, and
It's okay. You can think
um,
about it.
I think that you can think what you want, but
Absolutely. And you can as well.
thank you. But I don't agree, so I'm gonna go.
All right. Well, nice talking to you,
Have a
Kakuni.
good day.
Come back anytime. You too.
Yeah.
All right. This little Glober. We triggered his cog this a little bit. How are you doing, Cedarfield? I'm home in Sweden now. I'm eating Swedish pizza and kebab. It's awesome.
Oh, welcome home.
Tack ska du ha. Yeah, I went
Är
there
det
for
bra?
Sweden Rock, and that thing is over. Now I'm just going to relax.
Was it good?
It was fantastic.
Awesome. What was
Yeah.
best?
Probably Halloween. Offspring was good. God, there were so many good bands. Social Distortion. Joe and Jet was there. That was fun. Magnus Uggla was there. That was kind of cool.
Oh, how rock
I don't
is
know.
he?
Huh? How old is he?
No, how rock is he?
Yeah.
Wow.
Welcome back, Matthew Learns. We have Void
Hello.
Neo. Welcome. Hello, hello, hello. Amphibious J, Effie Batman. Kathos is here. Flatman Can. And Entity 248. Talking about Earth. Just had a pretty good discussion with the French guy. But he freaked out and he left. Which happens quite
What did
frequently.
he say?
He said, "You can have your belief and I can have mine. I gotta go."
Well, I suppose that's true.
Yeah, I agreed with him, of course. I'm not here to convince anyone. I'm just here to present the method, and hopefully people go out and check it out themselves using that method.
Yeah, I would say there's lots of methods, and I agree. I think people should do their own research and look around, go outside.
I like the mirror method because it's cheap and anyone can do it. And most people have the ability to find something that's 10 miles wide. Water. Yep, so that's where we're at.
Hello, everyone.
Hello, hello.
Hello.
May I ask a question if you are not busy?
Yeah, of course. Go ahead.
First of all, reach to you. Sorry,
There was a little bit of robot.
like 5 seconds later. So my question is, can you like
Can I what? You broke up quite a bit. Maybe it was just my connection.
No, I
Yeah.
couldn't hear what he said either.
Oh, all right then. Yeah, it was roboting for me. So
pure.
He says you gotta fix it. All right. It's still not fixed, Void. Maybe you can type your question in the chat. I'll read it for the audience. While we wait for the YouTubers, Flatman Can has a comment in the chat. He says, "Aren't you tired of watching them pretending to go to space?" Yeah, I am. Millions of dollars blowing up in front of us. Yeah, it's irritating. Meanwhile, we have homeless people all around us, needless wars going on, so-called leaders doing nothing to help the everyday individuals that are so distracted by this space lie. They used to say, "Oh well, gas is going up, food, rent, etc. No good wage up out there. So how is this good for anyone to believe in? You really think if we can go to Mars that there will be no war, no homeless, no taxes, etc.? Yeah, okay. If you say so, I show me here first." All right. So I read the comment. I don't know if anybody's actively lying, though. I think it's all tradition at this point. Nobody knows. They just think they live on a ball in space, and that's what they teach in schools and so forth, because they're paid to. They don't want to lose their job saying that Earth is not a ball. Flat Earth Judge, may I try again? Absolutely, dude. Just open your mic and try.
So, am I better now?
I could hear you ask that question. Am I better now? So I can hear you.
Okay. Yeah.
Sorry, dude. You're
First of all,
still
I'm
robot.
sorry for the connection.
Still
And
robot.
for my question, I want to say, you guys seem so smart and knowledgeable, and I really respect.
Yeah. We're here 24/7. If you can hear me, absolutely. So, YouTube listeners, we have this guy here. His name is Void. He's trying to ask a question, but he's roboting. I'm sure you could hear. So I wouldn't mind reading his question in the chat. But he says he's going to come back, and we're always here. So come back. Any other stuff we have in the text here? CB Games. Are you in the voice? CB Games? No. So it's pointless for me to answer your question. I can read it for the YouTubers though. CB Games says, "Why is the sun a circle when we see it? Why wouldn't it be flat? Like you're saying the Earth is flat." Well, Flatman Can has actually answered the question already. He posted the classic 4 different balls. Are they all balls? Only one of them is, of course. You've all seen it. And if you're on YouTube, maybe you can still see it in the chat there. So that's the explanation there. We can't make a claim about the shape of the sun. Could be a circle, could be flat for all I care. Could be round like a ball. I don't know. Doesn't matter
But
either.
it rotates, so we think it's a sphere.
Yeah, it can be a sphere. I can grant you a sphere. I don't care about the shapes of the things in the sky. It has nothing to do with the property of Earth's surface. So I always give it to everyone who wants. If they want a round shape, like sphere shaped ball, to be their sun, they can have it. What else do we have up here? No, not much activity. Should we check the YouTube chat a little bit? Let's do that. Let's cater to our good people over on YouTube a little bit. They don't get much love. We're going to give it to them today. If you are on YouTube and you want to interact, I'm going to read the chat right now. So go ahead. Have at it. Don't even have to come to Discord. We only have 8 viewers over on one of the streams. Boys, Poland of what move? I can't even read your username, dude. Why do you have such a long username? He says, I love the Philo guy. All right, that was a few hours ago. Sir, why don't you debate Professor Dave? Explains. We would. You can send Professor Dave over to us anytime if you want to. See if he joins. We've taken care of bigger fish than him. He's not even a professor. I don't know if you're still listening, but if you are, and if you know Professor Dave, just have him swing by. We'll
He teaches
we'll put
he teaches college classes sometimes. What do you mean
yeah.
he's not a professor?
Is he a real professor, like a professor at the university with the PhD and all of that stuff, or is he just called a
No, he
professor?
doesn't. The thing that you meant to say is that he doesn't have a PhD. So
Yeah,
he is a
maybe that.
professor, but without a PhD.
So he's a teacher.
He teaches college classes sometimes. I don't know how often.
All right. Well, we can have him over, professor or not. We can call him. I'll even grant him professor. Why not? It's fun. So the Professor Dave, if he wants to come in here, we'll put the newest flat earther, someone who joined us a few days ago, on him, and they'll crush him completely. So that'll be fun. Let's check the other stream while we're at it. We'll make it easy for Professor Dave if he comes. We'll be nice. One-on-one, no dogpiling. I hate dogpiling. I don't want to be part of that. Let's check the other stream. We have 12 people watching on the other stream. Flatloids. Habits are hard to break. Habits are hard to break, says James Gibson. Shout out to you. Yeah. They are hard to break. It's a hard habit to have, to think you live on a ball in space. That's a real hard habit to break. The hardest, probably.
Well, I wouldn't call it a habit. I'd call it more of a belief. I mean, I
It's a
believe it
strongly,
because there's nothing. I don't think anything better has come along.
yeah, it's a strongly held belief for most
Right,
people,
because it's
for
true.
some
That's
reason.
what I think.
Yeah. For you, it's a little bit different though, because you can probably steel man a lot of our arguments. So, but most people, you notice when they come in here, they don't know even the first thing about the Earth that they're going to argue for. It's kind of ridiculous sometimes. We have to first teach them. They don't even know the radius of Earth, but I bet you do.
Right, 39, 59 miles on average. Yeah, I know the
Yeah.
arguments that the curvature of Earth has never been directly measured.
Right.
That you can't feel the rotation, and that you can't have a vacuum next to a pressurized system without a container.
Yeah. Yeah. I don't usually go into the last one because it becomes complicated. Because then, I mean, there's so many things you can. I don't know. But the first two, I like. I like those. The spin and the curvature. Gas pressure without a container. I mean, it doesn't really prove the surface property.
Right.
You'd probably have some kind of dome around the ball if you wanted to. And if
I
someone
suppose
really
you don't
wanted,
need that though. The air pressure is caused by the weight of the air. Pretty simple.
yeah. I mean, I've heard some people, if you really want to kind of flat smack a flat earther, you say the universe is the container, and that's the end of the the argument there. you know. So I don't use it because I don't want to get into that because I can't prove anything about the container other than it has to exist in some shape or form. Otherwise, we would be dead.
And if you were to steel man the globe, what would you say the top 1 or 2 evidences that the Earth is a globe?
It's tough. I mean, the most common one that the people say is pictures from space, right? We've seen pictures from space. It looks like a ball. That's the most common one. I would probably use that if I was a glober. Probably have used it when I was a glober.
Okay.
What else? I don't actually know. I mean, because Earth measures flat. So what am I going to say? I can't
I
bring
would
up
say,
any of the sky
yeah, I would
evidence.
say,
Yeah, go ahead. Sorry.
I would say the sky evidence is pretty strong. I mean, including like the sunsets and moon phases and seasons and GPS and satellite TV and stuff like that.
Yeah, but I don't see how that couldn't happen over a flat surface. All of it. Like even Josh Ingersoll, who is our satellite expert guy, says that they can plot those paths over a plane, and they look like the flower of life. So he can't actually tell us for sure what path they are taking. Of course, he's going to argue that it's orbiting a round ball, right? But he can't prove it. And he's the guy who works there. You probably heard him speak about this. But anyway, sky evidence. I mean, if this was the Let's Prove the Sky channel, then of course we could talk about it, but it's irrelevant to the surface property, I think. People also like the 24-hour sun in Antarctica. I would probably use that if I was a glober, even though I can easily, explain it.
Yeah, that's been quite a shift in the past, I don't know, 6 or 8 years.
Yeah, yeah. The thing is, I'm in Sweden right now, and it's summertime here. It's going to be the longest day of the year here pretty soon, in a few days, 8th of July, I think. If you go up north here, you can look up and you see the sun circle above you. So why wouldn't that be able to happen on the south as well? South is just a point far away
Yeah,
from
it's
the
a good
north.
point. The curious thing
So
is that for you,
for me,
oh, sorry.
what?
The curious thing is for you, if you stand outside and watch the sun go around, it's going to go from left to right all the way around. And if you go down at the South Pole, 6 months from now, it goes from right to left. So it goes opposite. There's no
Yeah,
good
but
explanation about how it changes
I
direction.
explain that by the analemma. That's my theory about it. But again, I can't prove it. It's just my explanation. You've seen the analemma. It's an 8-shaped form, right? Of
Right.
course, it's going to come around on the other way, on the other side there. So if you
When
put
does
the
it
north,
switch directions?
if you put the north in one of the 8 rings, right, and you put the south in the other ring, there you have it. I don't know if that's the case, but I can't prove it. It's just an explanation, just a theory, not claiming anything. But you can roll your finger around the north point over on your kitchen table. You decide where the south point is going to be. Take it over there and rotate it a little bit over there. And there you have it. 24-hour sun in the north and 24-hour sun in the south. It's just 2 different points on Earth.
I like to use the example of imagine that you're riding in a vehicle, a car made of transparent glass, except for the tires. And you look at the tires, and if you look to the left, the tires are rotating clockwise, and you look to the right, they're counterclockwise.
Yeah, or if you hold a see-through, let's say you have a hula hoop, you know what that is, right? A see-through one,
Yes.
like the transparent one. Paste some stars that you make out of gold stars that they give out in school or whatever on the inner ring and on the outer ring. If you stand exactly inside of that hula hoop and you rotate, it's going to look like the stars are going from the right to the left. You move outside of that thing and still spin it, it's going to look like they come from the left to the right because you see the outer ring now.
No. Sorry, go ahead.
No, that was it. Did I break up or something?
Oh, sorry. Give me a sec.
Yeah.
Okay, sorry, I had to step away for a sec.
Yeah, I hear you.
Okay, say that again about the hula hoop.
Yeah, just give me a second, because now I had something happen
Oh,
here. Just a
good.
second. Yeah, so if you take a see-through, like a hula hoop made of clear plastic, you paste some stars onto the inside and on the outside of that thing. Or actually, you can just paste them on the inside because it's see-through, right? Now, if you're
Mhm.
standing and you're holding the thing above your head, start rotating it, you're going to see that the stars on that ring that you see, they're moving left to right or right to left, depending on which way you rotate it. You keep rotating it in the exact same um, like direction, and you step outside of it. Now the stars are going to come from the left to the right. When you're inside of it, they're going to come from the right to the left. Can you imagine this in your head? Or
Yeah, that makes sense.
yeah, so that would be an explanation. We're moving away to the south, and all of a sudden it looks like they're rotating the other way.
But it would still be clockwise or counterclockwise, right? I mean, you're talking about left and right or east and west.
Yeah, we can say
But if you're
clockwise.
talking,
So if you start circling it, it doesn't matter which way you choose. I mean, maybe you want to choose the way that Earth is claimed to spin, west to east. So that would be okay. Is that clockwise or anti-clockwise? I can never remember. I have to actually think about it. Let's see here. West to east. That would be counterclockwise. Okay, so you start rotating it counterclockwise. You're inside of it. The stars looks like they come from they look like they come from the east, and then they go to the west. If you step outside of the hula hoop, it's going to look like they come from the west and go to the east, because now you're outside of the hula hoop, right?
okay, I see what you're saying.
Yeah, it's just a thought experiment, not a claim. I don't know what's going on exactly in the sky, but I do know that the Earth is flat underneath it. Welcome back, Crystal. Good to see you. Marvis is here. Yoder is here. Debate Daddy.
Hey, what's up, guys?
Yeah, what's up?
Good afternoon. I'm driving, so I'll be back.
Yeah, good to have you back. I like what you pasted there in the chat, Yoder. The calculations. It's good for all the Globers. It's funny that we always have to first teach them this before we can actually talk about it. They have no idea. They're telling us that they can see curvature from airplanes and all kinds of stuff like that. But then you look at the math and that's impossible. Sachin is talking to us in the chat. I don't know if he can hear us because I don't think he's in the voice, but he says believing in flat earth is dangerous. As a matter of fact, it's more dangerous to believe in the ball. You ask those good people in Germany during the war when they shot radio signals from Germany and Denmark over England and bombed the shit out of the English. And they didn't think of it because they said that can't be done because we live on a ball. So a lot of lives were lost there before they finally realized that okay, it is actually working. They never said how it could be working because there should be several kilometers of curvature between those countries. But they shot those signals perfectly straight over to England. So I would say believing in the globe, at least back then, was very dangerous. Also, flat Earth isn't really a belief; it's knowledge. You can go test it.
Yeah, I would say the same thing. I would say that, from my opinion, knowing that the Earth is a globe is knowledge rather than a mere belief. It's knowledge and belief, is what I would.
Yeah, if you have the knowledge, feel free to present the measurements then.
So here's what's interesting. If you take 4 times the Earth's radius, whether it's kilometers, nautical miles, units don't matter. We can use statute miles. But if you divide 1 by 4 times the Earth's radius, in this case, that would be in miles, 1 divided by 15,800 and things, 840. So 1 part in 15,840 parts, but in this case, these are going to be statute miles, comes out to 8 inches.
Interesting.
This means we can use that relationship as a scaling factor to determine drop over distance and not have to use the parabolic arc formula that seems to confuse people because they don't have a sense of scale and how error can compound with that deviation.
That's a good point. And this is math. Matthew is probably taking notes right now. Is the order correct, Matthew? Fact check.
Yeah, I think 8 inches per mile squared is an easy enough thing to do, and it's an easy way to see how much the deviation would be over, up to a couple hundred miles. But if you want to talk about deviation, the same 8 inches per mile squared, the other way to talk about it is that the path of light or laser light would have to bend by 0.007 degrees per mile. So that's if you want to talk about the deflection, but that adds up over time or over distance.
No, that's also true. It's important to frame these within different contexts so that you appreciate the scale of what we're working with. So I think, Matt, you might appreciate this. I did a derivation myself of this. It's not a complicated one, but it's simple and I think illustrates your point here. Hold on, let me post it. Got to go to my notes. Okay, I've been posting this the past few days around, just trying to educate. All right, for the audience listening, I'll read it. So you can express the percent flatness of a curving swath like a square patch of a globe relative to a flat plane by using the below derivation. Now, mind you, this isn't looking corner to corner across the swath, which would be longer because it's a hypotenuse. It's rather looking at the square along each length side. So not the diagonal, but the side length. It's a simple formula. You take 1 and you subtract the length of the arc divided by 4 times the radius. So 4 times 3,959 miles is 15,836. So if you were to plug in an arc length of 100 square miles, using this, you could say the globe is 99.37% flat. And I think expressing it this way gives everyone an appreciation for the kind of error tolerance that we're working with over distance, and why in some cases you'll need exquisite precision, in other cases you won't. It depends on how good your measurements are. So CB Games says there isn't any standard mathematical definition for percent flatness. No, but this is looking at the arc as a percentage of flatness relative to a straight tangent plane. So if you look at a circle, okay, think about the unit circle. You cut the top in half, right? So you now have like a dome. That dome, you could say, is 50% of a circle, or 50% flat. Make sense? So when we take a
Yeah.
radius of 3,959 miles of that unit circle, and look at only a segment that's 100 miles long, what percent flatness is that? Well, I mean, it's, as I said, it's 99.37% flat. But here's the interesting thing about this. Okay, that's part one of the derivation. You can modify this. I'll post part two here. You can modify this to obtain a drop over distance. This, again, just a different way to look at it. If you take that arc length and square it, and then divide it by 4 times the radius, and then multiply that by 2, you get the drop over distance, in this case in miles. So you take 100 times 100 divided by 15,836 times 2, and you get a drop of 1.26 miles. And the way to think about this is you are at one edge of the tangent plane looking out beyond. You're not in the middle of the tangent plane. This is important because you have to understand the difference in like trigonometry between taking the central angle versus the half or semi-central angle. So what you're going to have is you're going to have a total of 1.21 miles of drop total over that entire arc length. But if you're in the middle, if you're in the center of that arc, like you're standing on the dome looking out on either end, the drop is going to be half that amount in front of you and behind you.
Yeah, that seems reasonable.
Right. Thank you for your vote of confidence there. I know we're chartering new territory here, applying math in ways that they don't teach you in school. Like, we're going to use math to evaluate how flat the Earth is. I've never seen that in any homework problem I've ever received. And yeah, this absolutely does relate to the 8 inches per mile squared derivation that comes out, which is described as parabolic, but I don't know if
Yeah,
you
yeah,
can
it's
even say it's
parabolic.
parabolic. Yeah, I
But
know.
it's close enough. I mean, if you want the real thing, you'd have to do the spherical formula, but it's close enough for a couple 100 miles.
Yeah. Yeah. Is that an actual formula proven to be real? This is testing the intrinsic or inherent claims of the math and the geometry itself. We're not subjecting this to an external validation test. We're just making sure that everything is consistently internally verified. And yes, it checks out. I mean, astronomers, for those who don't know, astronomers are almost at the top of their class when it comes to mathematics. They are some of the most brilliant mathematicians around. You don't get into a good astronomy program without having exceptional mathematics skills. So you got to be able to like write the same expression in different notation, like in, calculus or algebra. You got to be able to really be fluent between these things, and you got to know how to apply math rigorously too. So we've had hundreds of years of astronomers, the most brilliant mathematical minds, working out the internal consistent logic of the globe claim. And that's what we're challenging here. I mean, it's a tall order for us, a bunch of internet nerds, to be challenging, but that's what we're challenging. We're challenging to see if the math is not only internally consistent, which it tends to be, but to see if it actually applies to the real natural observed physical world that we inhabit. And our contention is that it doesn't. Of course, that's why there's disagreement amongst everybody on this topic, because most people in the world think it does comport to reality. But then the question just isn't whether it does in an absolute sense, it's how well does it comport to reality? If I was a professional surveyor and I said, hey, boss, I measured this flat swath, 100 square miles, to within 99.5% degree accuracy, I'd be entirely correct. And I still would not be able to conclude whether or not I surveyed a globe. So, how many decimals of precision do we need for statistical significance? It depends on the scale and what you're working with. You have to treat every case separately and uniquely, I think, in order to make that evaluation. There's not going to be any one size fits all. So, honesty check, Matt, you think I'm representing this fairly? CP Game says, I'm sorry that percent and flatness is not a real mathematic definition. If I have a circle, a circumference that I say is 100% of a circle, okay, and I chop off an arc segment of that, you're going to have less than that, right? So if I flatten out a section of a circle and compare it to the entire circular amount, then yeah, I think I can express that as a percentage. Isn't there a relationship between, radians of degree and percentages? You know? There's a direct relationship between radians and the radius, and it's why people often prefer to work in radians instead of degrees.
You trust the juice of lemon? All
Send in
right.
the clowns.
I am here with my cousin. Speak, my cousin. Speak. The leader talk about galletica. Di galletica. Dilo duro. Dilo duro.
All right. Hey, my friend, I don't think you intend to be hot micing, so I'm probably going to just hot mic you myself in this. Oh, wait, did he leave?
Yes.
Are you hot micing?
What?
Apparently not. Welcome to the room.
Thank you. I am Latin. If you don't understand my English, I'm sorry, but I am Dominican. I am not gringo and American and nothing.
All right. Well, welcome to the most advanced English room of the English Hub server. In this room, we discuss the philosophy of mathematics, science and technology concepts,
Yes.
geometry.
Oh my God. I like the geometry, but I am very bad in math. And math, I am very bad. I,
Well, that's fine. I mean, maybe we can help. If you want, you can listen to some of the discussions we have, and you can pick up new vocabulary from different fields of
oh,
academia.
yes. I would like know the new vocabulary. It's difficult, but I am trusting me. No, my God, please.
Tomorrow we are to go today. We are go today. We go.
Have you ever heard of? Hold on, I want to go back to this topic where, You know, CB Games said you can't express flatness as a percentage of a curve. You know, we do have ways to account for this actually. Like, you know, what about expressing angles of elevation or depression as a percent grade, which you see all the time in engineering, you know, like civil engineering. If you have a percent grade, you have an elevation or depression angle. So yeah, I'm directly addressing you, CB Games. If you want to mic up, that's cool. But have you ever heard of a percent grade before?
Earth is ball. Okay. Okay.
All right, now we know. We can all get out of here. Apparently, Earth is a ball. Fortunately, he didn't have time to stay to defend that claim. That's unfortunate.
All right, so CB Games looks like he moved on to a different topic. He says he didn't hear my response to the percentages, whether or not you can assess a degree of flatness. And I presented an example of measuring degrees of elevation using percentages, you know, and you can have degrees representing arc. But he moved on. He's now saying, and this is why I think he's starting to go into anti-flurf mode. If the Earth is flat and there's no obstruction, then why can't you shoot the same laser from the coast of California to hit a target from Hawaii? Well, first off, I don't care how good your collimation is, but even in a vacuum, there's going to be a diffraction limited beam footprint to your setup. Sorry, just the inherent imperfections of high grade scientific equipment will lead to that beam spreading out. But that's really just a minor point. a more major point has to do with the attenuation of that beam through a medium, as well as the scattering. So I'm glad you brought up Hawaii. One of our favorite discussion topics is what's called the combat laser test, or the air chaos laser test. There's a massive laser on the Big Island of Hawaii, part of the observatory. How massive? Well, it's able to shoot multiple frequencies of light out at the same time, propagating over the length of over 149-kilometer path. And these tests were conducted by the US military in conjunction with several major universities in order to study the propagation path of laser beams at different frequencies over 149 kilometers from Haleakala to Mauna Kea and vice versa. Within some of the more recent information come out of these tests, they discovered that, light refracts within a gradient index medium, where the gradient changes subject to variation depending on airflows and pressure changes, temperature changes, you name it. But they also found out that the degree of lateral refraction, that is side to side, was equivalent in magnitude to the degree of vertical refraction up and down. In fact, there's so much going on with this that they were able to say that the entire US standard atmosphere model itself, which is what surveyors use for globe refraction, is completely blown to pieces. They can't use it. And so they had to try and develop multiple models of their own, custom models, to explain and backfit the data. So yeah, we would agree with some of our detractors that light is subject to all kinds of wonky donkey effects when propagating through mediums such as the weather. But you seem to think that light propagates through a vacuum instead from places like Hawaii to California. So I really don't know if you're ready for the level of sophistication of your own requests that's required in order to explain these concepts to you. The very fact that you would ask, why couldn't a laser beam shoot from California to Hawaii, means you haven't really thought through the consequences of that question in the first place, to the degree of education that you should have for this discussion. All right, so now he's onto the moon. Now he's on the ships and over the horizon, and now he's onto this. So he's just gish galloping. CB Games, do you want to mic up, or are you going to stay a little chicken and stay muted this entire time?
The distance between Hawaii and California is about 2,500 miles, so you're very correct about your assessment here, Yoder.
Yeah,
It's way
I hope
too
so.
far. Yeah. Just for the listeners, that's the distance we're talking about. Obviously, we don't have the tech to shoot any lasers that far out, so and just the attenuation alone prevents it, right, Yoder?
Sorry, say that again. I had to step away.
The attenuation alone prevents it, right?
Yeah, you got it.
Yeah.
It gets absorbed, scattered, reflected.
Yeah. I mean, if you somehow could do this in a vacuum, then maybe, right? But we don't live in a vacuum.
So I've got a really good camera set up, and I've got a full spectrum conversion of a Sony A6700. Anyway, as I was saying, hold on, give me a minute.
I think there might be some shots from Jay Tolan when he's really high up, and I think he was able to see 1,000 miles or something with infrared. But 2,500 seems way too hard. It seems like it's too long.
Anyway, as I was saying, yeah, I mean, JTolan Media is a great resource for some of this. I decided to take my camera out to a point of observation nearby. And I live in the humid mid-Atlantic region of the United States. So I popped on a lens filter for 930 nanometers. Now, 930 nanometers is getting pretty deep into that specific area of infrared. I mean, so deep that you require about 4 times the sensitivity of your sensor compared to 720 nanometers infrared in order to have the same amount of contrast in your image. And I was met not by any evidence of Earth curvature, but a wall of humidity at about 35, 40 miles away that I could not see through.
Yep, makes sense. Welcome back, Doc.
So the problem wasn't so yeah, sorry, I had to step away for a second. I got lots of stuff going on, but I'm here now. All right, so the issue, so infrared is really good at dealing with like Rayleigh scattering. You can use the inverse Cordic law in order to determine how much your filter's wavelength is actually able to filter out various frequencies of light. So it's something like on the numerator, you could take like the blue frequency, blue nanometers. Is that like maybe 480 nanometers or something? 400 nanometers. And you divide it by your filter set to the 4th power. And then you take all that and you take 1 minus that, and that gives you the percent of amount of filtering that's done from that blue, which means I'm able to basically see through like 98 to 99%, filter out that much of the blue wavelength. Now, the reason why I could not see was not because for lack of seeing through Rayleigh scattering. I could see through tons of the blue, the wall of blue. What I was met with next was the density of the air itself, the humidity, the water vapor, the pollution, the evaporation of the earth and all the water in the earth just coming up and going up to the sky. It creates like a mist, a haze. And the best infrared can't see through that. This has nothing to do right now with refraction so much when we're just talking about this aspect of it. But it's more having to do with the attenuation of light that's beyond what I'm able to see. Now, the higher you go, the air thins out. Globers say, haha, that means Earth is a globe because gravity is stronger at the surface and holding more of the air and the water vapor down to the surface. That's a whole separate hilarious discussion that I won't get into. But the higher you go, it gets colder and the air thins out. There's definitely a lot more space for all of that air and water vapor to expand into because you're moving away from the ground as a limiting surface of expansion. And from higher up, you'll be able to see much further in infrared. You pop on a lens cap or lens filter and you zoom into the horizon from like an airplane height. From that elevation, even using a modest, 700 to 800 nanometer wavelength for infrared, as JTolan shows, you can see for hundreds and hundreds of miles. You can see terrain and land features that should not be visible if Earth is a globe, because we're now reducing the amount of Rayleigh scattering. We're above the thickest part of the atmospheric soup of water vapor and particulates. And we're now extending how far we see with high-tech imagery that's able to develop extremely good contrast between light and dark at extremely good sharpness with high pixel density And we can see and identify terrain features that would not be visible if it weren't for the fact that the Earth is not a globe. So J. Tolan Media presents this. He himself is a physicist and an engineer specializing in RF and optics. He provides instruction on his own YouTube videos on wave mechanics and photogrammetry, if that thing interests you. Some of his most astounding footage that I think is most verifiable shows mountain ranges at twice the distance beyond what they should be seen, in some cases 3 to 4 times that distance. You know, it's almost as if you were to take a satellite with its high-end optics, and people think of satellites as pointing down at the Earth to read like newspaper headlines from space. Well, imagine if you pointed that shit sideways. What Jade Tolan shows you from his professional experience goes beyond what most people would ever see in their entire lives. It's a true gift to have this man and his channel and his work available to us, because most people will never be able to witness the equivalent of a sideways facing satellite taking hyper zoomed images and hyperspectral imagery of the Earth. You know, his equipment is probably on the high end of consumer grade, if not a little bit into professional grade. But it just makes me wonder, what do well-resourced institutions have at their disposal? Did you know that the Hubble Space Program has a sister component to it called the SOFIA platform? The SOFIA platform is was a modified Boeing 747 with a huge bay door that opens up and reveals a telescope that's capable of long distance infrared, and I think it'll even do electro-optical. This telescope bears the same exact specs as the Hubble Space Telescope. Now, sidestepping some very interesting coincidences for a moment and looking at what it's capable of. Did you know that the SOFIA mission had like a 2-year operation to study the horizon using that telescope? That's right, for about 2 years, the same exact specs, design specs in Hubble Space Telescope was shoved into a 747 and flown around on multiple flights over that 2-year period to study how the horizon appears in hyperspectral imagery. Imagine what it's capable of seeing. Like if you thought J. Tolan's modified Panasonic camcorder 930 nanometer infrared was amazing, imagine what an aperture the size of a freaking Volkswagen Beetle would be able to pull in. And you know what's really kind of shitty? They don't make their information public. It used to be at one point, maybe almost a decade ago, but NASA yanked all that footage, all that information off the website for the long distance horizon studies using the SOFIA telescope. And to add insult to injury, after they had yanked it, they actually had a placeholder page that said, if you want this information, please email the administrator here. Contact information down below too. They even took that off. It's like they don't want the general public to even know that they did the study in the first place, and that's kind of weird, don't you think?
So I work for a private defense contracting company, and we take care of long distance missile surveillance stations. There's like roughly 40 of them throughout the area that I travel to and from, and they use tons of different equipment and technologies to see long distance. So the first one that is mainly used would be the radar. They use over the horizon radars to detect launches that are over thousands of miles away, like in the thousands of miles. Infrared cameras and imagery, and huge optical telescopes for personal viewing, like when you want to look over an area just to make sure you confirm what you're seeing on the radar. Just given how those surveillance stations work and how far they watch for incoming missiles, does not line up with, and none of that's public information either. You can't just go searching the stuff that they view and the exact equipment that they use, but you could search how far they can see. You can search their surveillance radius, and you'll find out that most of the time the nonstop radar systems that they use are over the horizon radars in a line of sight direction. That's how radars work. Radar does not see over a curve. It doesn't see past something that's blocking it. It can only see through a free of object area, thousands of miles away.
Man, that echoes stories we have. There's a guy who was traveling around 24/7 a while. I think he used to be a moderator. He brought us a similar story, except he was Air Force and worked on J-STARS, aerial overhead platform for
Yeah, you're talking about like the infrared satellites that they have. They're not actually satellites, but
I was, but this guy used to be on a J-STARS during GWAT and was describing how, even though he can't verify this and nobody can verify this independently, but what they were seeing from all the AWACS deployments and everything else going around in the area, that the entire battlefield was laid out well over beyond the curvature of the Earth's limitations. Yeah, so much that's attributed to satellites is actually ground-based, with satellites offering relays.
Yep, and I would also say that we have multiple different organizations throughout the world that get funded money for the simple fact of hiding the information that they're pushing. To hide the information, push other information, right? So like you're saying, they scrub stuff. So much stuff gets scrubbed off of the internet that doesn't follow the false dichotomy, and then false information is pushed with no evidence or observations to back up their claims. And we're giving some of these organizations over $60 million a day, government funded. It's a lot of money. That's a lot of stuff that they can do, a lot of resources that they can apply to get the information out that they want and remove the information that they don't want.
Well, that's just some enhanced OPSEC procedures, right? You sound like somebody I could drop a bunch of acronyms to, and then the black helicopters would come and we'd never be found again. So,
What was that?
you sound like the kind of person I could drop a bunch of acronyms at that very few people would know, and then the black helicopters would come and take us, and nobody would see us again.
I don't know. I work for a defense contractor through the U.S. and Canadian government, so I already am expected to know the information, but I don't think I would have black helicopters showing up. You might.
Well, I used to work for one of the majors too, and did other things. So one of the things I keep pressing people here, we sometimes get folks coming in from this field or tangential to it, is listen, we don't need anybody whistleblowing. The first person to start whistleblowing like classified, I'm going to report.
You're going to report the whistleblower?
Oh yeah, like you bet. Somebody comes in here and starts chucking around classified information that nobody should have by lawful means, I'm going to report that shit.
Because it's dangerous just to have heard that information.
Yeah, well, I mean, it's reportable. Just leave it at that. And we've had some instances of people on our team who have attempted that, and we tried to stop it. And yeah, we have reported, at least I have, in one particular instance. And folks, we don't need people telling us proprietary information, whether it's corporate proprietary or whether it's government proprietary. We don't need that. Nobody's hiding the flat earth from you.
They're trying to, but they can't hide your observations. They can't hide your own observations from you.
I would say that nobody's actually really trying to hide it. I mean, people involved in this don't even think about the globe versus flat conundrum.
Yeah.
So you got that happening. And then you've got a much, there are much bigger reasons for them to be classifying information beyond this. And even so, and the entire, I don't know how much I should get into this, but you cannot classify naturally observed phenomena.
Yep.
And by that I mean scientific observations cannot be classified. That's actually written within the framework itself. And I'm not just talking about, it's not in the NISPOM. You have to go to other things for that. So, I mean, there are a lot of folks on Team FE who seem to think that there's some kind of concerted effort to hide the discovery of flat Earth from the general public. Not only is that like, not only would that be, is that expressly forbidden by the framework of classification programs and standards for all of this, but it's also just impossible to do. Like, you can't hide it. Nobody can be stopped from taking a telescope and seeing too far. I'm sorry.
The issue is that people believe information that is just pushed out to them that is false and not tested, and they themselves are not willing to test it, and they just openly believe it because they're lazy. They're not willing to test it themselves. They just hear
Yep.
something and run with it.
And furthermore, when some of these folks, especially those working at these laboratories and conducting, capabilities tests of interesting technologies, and they discovered that they could actually use a flat Earth instead of a globe one, they will write this into their report, not thinking there's anything wrong with that and still believing Earth to be a globe.
Yep. And at that point, I think you're just lacking common sense and the ability to apply context clues. Compare information.
There are people on the inside who have deep suspicions about this topic, but they keep it to themselves and to a few trusted close friends, and it's not widely discussed.
They would lose their job. if they open up this
Potentially,
test bed
but
and
not
put that
not in all cases, I don't think. You know, people who understand like the intersection of higher geometry and maybe some physics and orbital mechanics, you know, they're going to know. But at the same time, they're also wondering how the hell this stuff actually works. And you know, to that I'd say, well, guess what, guys? The entire dual use technology concept is an entire industry unto itself. There are so many things that are either intentionally designed for dual purpose use or were not intended to be and discovered to have dual purpose use. When I go through the NASA technical report server, I can categorize almost everything I read into two broad categories. One of them is this guy believes in Einsteinian relativity as a cosmological framework for how he did it. And I'll read another paper. This guy rejects Einsteinianism and actually subscribes more to an electric universe kind of theory. Both of these reside in parallel and commingled amongst each other on the in the NASA technical report server. You can read on one hand where NASA scientists are chastising the other, and on the other hand, the other scientists are chastising the other on their respective use of their cosmological frameworks to interpret the same data. You have the Einsteinians versus the non-Einsteinians, almost seemingly in conflict. And one of the biggest case in points I can present that diverges from what's popularly believed, which is Einsteinianism, is a paper called Double Layers in Astrophysics by Dr. Hannes Alfvén from NASA, Swedish astrophysicist. He was not so much into Einstein, but into electric universe back in the 1950s and 60s. And he pioneered an entire field of study called magnetohydrodynamics, which offers an alternate explanation for space mechanics than ones dealing with relativity exclusively. He wrote in this paper back in the late 1980s, a foreword, which is taken from a conference that he gave when this paper was presented, and he was on the team of scientists who presented this paper, Double Layers in Astrophysics. He said that the billion-dollar Hubble Space Telescope data should not be left in the hands of astrophysicists with basically their quaint notions of Einsteinian relativity and gravity, because the entire universe, from our perspective, is governed by circuit theory, plasma, electricity. 99+% of everything that we observe through our telescopes can be explained by these concepts. And so we should actually entrust this data more to the electrical engineers who actually understand this shit, instead of people who are enamored by, science fiction.
Well, regardless of the observation, if you're claiming mechanics in space, you need to be able to test and prove those mechanics in space through observation. But we can't do that. So regardless of space mechanics, you can't prove or come to a definitive conclusion based off of observation. You can have all the theories that you
Well
want
said.
about. Same way I can explain to you, if you want to use it as an example, thinking about celestial bodies and viewing them from Earth, well, if I take a penny and I go and I place it 5 feet from me, I can see that penny. I can't read what's on the penny. I may not be able to make out Abe Lincoln's face, but if I get much closer, I can make out the details. If I place that penny across the football field from me, I don't even see the penny. I can't see the penny. It's too small. But if I pull out a camera and zoom in on it, that camera has good enough zoom, I could bring the penny back into view. And if I zoom in even further, I could read the things that are on the penny. So is the penny too small to see, or is it too far away to see, or is it both? Because
Yeah.
even if the penny's size was changed 100 times smaller and it was 5 feet in front of me, I wouldn't be able to make out what it was, even if it was closer. It's a size and distance thing. So when we're looking at the stars through a telescope and we're at X amount of zoom, I don't really, in my mind, I can't think of off the top of my head what the amount of zoom you would have to be to bring a star into a well-lit view, a large celestial body. And if I use that same zoom and, according to science, look at a further celestial body, at the same zoom, it's going to look much smaller. But if I zoom in more, it's going to make it larger. It's going to bring it into perception. And I'm going to be able to focus on it and see what it is. Well, am I actually looking further? Or am I just zooming in on something that's the same distance, that's smaller? Because both are explained. Both can be explained through different sciences. You can have either or claim and still be accurate according to what you're observing. Just like when you use a microscope and you look at a bee's body under the microscope, you can see the bee. You zoom in, you can see the veins and the paths within the wings. You can see all the individual little hairs. But then you zoom in even further and you can see the different parts that make up the individual hairs. Am I looking further, or am I just enlarging the image and bringing it into perception? We know because we have the bee physically there with us. We have the equipment physically there with us. We're not looking further. We're just looking closer. We're enlarging the image. And that's what we experience when we look at stars. If you look at a supposedly star that is closer than a star that is next to it, and you zoom in and you focus on them, you'll realize that the focal point is the exact same. The only thing that you change is the amount of zoom. You don't actually have to change the focal point to a much further point of focus. It's the same distance of focus. It's just you are at a higher magnification, bringing it into view.
I'm glad you brought this up. You're singing my love language. 53 minutes past the hours is something I want to show you. And I don't want to put you on the spot, but I'm going to ask you a question. Which one of these is closer? And how would you assess that the one that's blurrier is further or closer than the one that's not blurrier?
If I was just giving you my own assumption here, I would say that the one that is more clear would technically be closer, but that would mean that the one next to it, the one that's slightly more blurry, would be larger and further away. I don't know. You're gonna have to tell me the experiment and the placements.
Right.
The test.
Very good. Very good. That's exactly that's an honest answer, and that's what I would expect everybody to say. It's what I would say, right? Because we don't know where the focal point is.
Yep. I don't know what
we
one
don't
is.
know what the setup is.
Yep.
I'll show you that. I'll show you how it actually looks. And what you're viewing is something through a medium called a telecentric lens.
Mm-hmm.
A telecentric lens, when appropriately calibrated, destroys depth perception.
And
the
it looks
second
like
image
one
was
photo,
made without the
it looks like
telecentric lens.
It looks like the only difference between the two photos is one photo is at a higher elevation, like the viewpoint is at a higher elevation in the second photo than in the first photo. I don't know what the difference is in the focal point, but
yeah, the screw on the left, or bolt, whatever, is actually further away.
Mm-hmm.
And if we accept the second image is true, and it's because the degree at which it is shrunken provides that visual cue, along with its translation upward towards the vanishing line of our optical horizon.
Yep. I'm saving these.
Notice how the top of the screw and the further one on the left doesn't shrink as much as the bottom of the screw. In other words, from this alone, we can kind of deduce where the central focal point of the images of the lens.
Mm-hmm.
You can also see how the screw on the left is a little bit narrower than the one on the right. Our brains know how to interpret visual information like this, whether or not we have the language to describe it accurately. That's a whole separate matter. But the medium through which we view things absolutely plays a role in how we perceive them. It could very well be in the top image at 53 minutes past the hour that the left screw was closer, but our focal point was a bit further.
And you can almost experience, in accordance with that, a screw that is if one of the screws were 10 times smaller than the other, and they were placed right next to each other, you would have to zoom in on the smaller screw to be able to see the amount of detail you could see on the bigger screw, but you don't change the focus at all.
Yeah.
You don't change the focal point. You won't have to because they're the same distance, and that's what we experience when we look at stars in the sky that
It's
are
like the
very
same
close
focal
to
point.
each other. Of course, if you look off at a higher angle, it's obviously going to be further away in accordance to your position. But if you're looking at two stars or two celestial bodies that are close enough to each other, the difference is not there, and you do not change the focus. You may have to have a higher zoom to bring the smaller object into view, but that doesn't mean that it's further. You would be able to tell if it's further by having to change the focus to a further point
That's
of
right.
focus.
That's
Yet
exactly right.
we don't experience that. Anyway, I gotta go, but it was good talking. I'll be back in like 6 hours.
All right, man. I'll see you later.
Adios.
I'll continue on this, and then I have to go to sit back for a while. But next image shows two different points of convergence on the horizon. I mean, you can see how the ceiling and the floor converge to that point. And the point where you cannot differentiate the ceiling from the floor is the diffraction limit of what you're able to resolve. I get it that this is computer assisted, right? This is just a computer program, but it's simulating the Rayleigh criterion. All right. The reason why the top and the bottom look this way and why the focal point looks this way is because we're at an basically an equidistant point in space between the ceiling and the floor. But if we were to lower ourselves to the floor, it changes that angular relationship, which changes the diffraction limit. So in this image here, before I post the next one, I want you to note the rate of compression of the line going horizontally flatwise across the floor and flatwise across the ceiling. See those lines, how they appear? The further in the distance they go, at least out lengthwise to the horizon, they appear to converge at the same rate. Top to bottom. If we move the observation point towards the ground and count the number of squares on that checkerboard that we can resolve, we can compare the top with the bottom. Okay, it's like on the top image here, we have two checkerboards and we're sandwiched smack dab in the middle between them. And they're so big that they go out to infinity. The bottom image at 0 minutes past the hour, we've lowered our observation point to the bottom checkerboard and we introduced walls of a hallway in the middle of the image. We can see that the rate of compression of the checkerboard has increased along the bottom compared to the top. We can resolve more squares if we look up at the ceiling than if we look out across the ground of the floor of this, because the angle of view is wider. We have more information available to us before it reaches that diffraction limit of the optic. This is also why that you see that dark line where I circled on the right ground compression. There's a lot of checker squares on that checkerboard that's been compressed into that. And that's why it looks that way. But if you look on the ceiling at the corresponding same location, just higher in elevation, you can actually make out the checker squares. It's because you have a wider angle of view to that circle above on the ceiling labeled sky compression than you do at the ground labeled ground compression. Your diffraction limit of your own optic in this case has not changed. It remains the same. What's changed is the relationship of the angles that you have to these objects in the distance and they have to you. The narrower the angle, the more information is destroyed. This is also why things may appear to disappear bottom up given a vacuum condition in the distance. If you're closer to the ground, then the information from the ground gets mixed in with the information of the base of that object you're viewing in the distance and gets destroyed. And as that object recedes in the distance or you move further away from it, that object will get gobbled bottom up the more it recedes away from your view. Because that point of compression destroys all the information that would allow you to differentiate where the bottom of that object meets the ground that it's sitting on. All right, I have some work to do. I have to go. Sorry for the abrupt cut, but enjoy your day. I'll be listening.
Love you, Yoder.
Thanks, Yoder.
A tide breathes low where the edges blur. A voice of mist begins to stir. In the cradle of waves where the light bends thin, the currents carve paths where the stars begin. Each ripple a story, each crest a vow. We drift through the folds of the endless now. Rise, rise through the veil of tides, where the heart of the deep and the heavens collide. We share our anchors, we break the seam, awaken the pulse of a boundless dream. The shores we've known crumble under the swell, their truths dissolve where the silences dwell. A spiral of light threads the dark's embrace. We chase its arc through uncharted space. Rise, rise through the veil of tides, where the heart of the deep and the heavens collide. We share our anchors, we break the seam, awaken the pulse of a boundless dream. The water remembers what the stone forgets. Each drop a debt to the infinite's bets. Do we swim or sink or become the sea? The question burns where the soul runs free. In the churn of the deep we are forged anew. Our shadows dissolve and the dawns break through. No map, no chain, no fear to bind. We are the tide, the spark, the mind. The surge ignites, the heavens roar. We carve the path where none soared before. The tide recedes, yet its song remains. A whisper of light through the heart's soft veins. We stand transformed where the currents meet. The stars our roots, the sky our feet. Through the veil we glide, no end in sight. Born of the tide we become the light. kingdom made of ink to quiet down the noise so I didn't have to think. I drew a line to stop the tide. I built a wall to stay inside. Every mountain was just a shape. Every exit was just an escape. I thought I held the world in a frame, but the wild wind doesn't know my name. The colors bleed, the edges fray, the perfect picture falls away. Tear the paper, touch the stone. We walk a world we cannot own. The map is not the land we see. It's just a cage for you and me. So let it break and let it rain. Let the wild world break the chain. Yeah, the map is not the land. It's just dust inside my hands. Path the paper showed. I found a river where the road ran out. The compass spins, the needle lies. There's a fire here that never dies. We chase the truth in black and white, but lose the colors in the night. The grid is gone, the ground is deep. I'm waking up from a paper sleep. The colors bleed, the edges fray, the perfect picture falls away. Tear the paper, touch the stone. We walk a world we cannot own. The map is not the land we see. It's just a cage for you and me. So let it break and let it rain. Let the wild world break the chain. Yeah, the map is not the land. It's just dust inside my head. Lines on a page, iron and rust. Whatever we build turns into dust. You can't draw the heat. You can't draw the cold. You can't draw the hunger. You can't draw the soul. So let it break and let it rain. Let the wild world break the chain. I feel the earth, I take my stand. Because the map is not the fold it up, put it away. The ink is washing out into the gray. Into the gray. for the map, pay for the model, pay for the spin and the high-tech gospel. Them build space age systems just to track, but I walk in the field on the ground, stay flat. Walk to the river, sit under the tree, breathe in the air, yeah, the experience free. Them sell you a spear, them sell souvenir, them sell hemisphere, them sell atmosphere. Me just take a step and a next step, see the road stay level like it waiting for me. Global cost money, flat earth is free. You buy that story, oh, but this one free. You pay for the movie, the merch and the screen. Flat earth is free, my friend, free like a dream. Turn on the TV, there's a globe on that. Buy a brand new shirt, there's a globe on that. Plumber truck drive by, there's a globe on that. iPhone background, there's a globe on that. Music album cover, there's a globe on that. Hollywood movie, there's a globe on that. Them stamp it everywhere so you don't forget. $1 billion brand, yeah, cost them sweat. But me walk outside, feeling the breeze. Water resting flat, calm as you please. Global cost money, flat earth is free. You buy that story, oh, but this one free. You pay for the movie, the merch and the screen. Flat earth is free, my friend, free like a dream. Pay for the rocket, pay for the flight, pay for the telescope to steer in the night. Searching for the curve that they say is in reach, but it's just a straight line looking out from the beach. Wally get thin, but the world same way. Still feel flat when you dance all day. Oh yeah. Globe earth costs money, flat earth is free. You buy that story, oh, but this one free. You pay for the movie, the merch and the screen. Flat earth is free, my friend, free like a dream. Globe earth costs money, flat earth is free. Free, free, free. Laugh if you want now, the joke on the feet. slips through like hourglass sands. I watch the sky's eternal show. Questions rise, answers flow, you know. A constant friend as theories twist, start to bend. What eyes can see, what hands can hold, worth more than all that we've been told. In silence now I recalibrate the truths I can't communicate. The weight of all I see tonight shakes everything I thought was right. I'm drifting on a sea of stars. Their light reveals where we are. No waking dreams can verify what midnight skies testify. The night unfolds its grand design as certainty falls out of line. Each instrument confirms my doubt as textbook wisdom fade fill out. The readings stay consistent here while old beliefs just disappear. I trace the paths across dark skies, watch every theory slow demise. In solitude I contemplate the patterns time can't recreate. Lost in waves of cosmic dreams, nothing's quite the way it seems. Every measure strips away the foundations of yesterday. We're drifting on a sea of stars that light reveals where we are. Each observation stands alone against the myths we've always known. The night unfolds its grand design as certainty falls through endless nights of measurements. Each truth becomes more evident. The answers lie in what we see. I
And can anyone tell me why I can't hear the music bot? Only got about 20 minutes total listening to it the past few days. I don't know why it's not working all the time.
We stand on the edge of a story untold, where shadows of towers stretch ancient and cold. The ground whispers secrets we've buried in stone, a canvas of signs we've claimed as our own. Through the haze a question grows, a fragile spark where wisdom flows. We soar through a fractured sky where the heavens twist and the old truths die. A fleeting glimpse, a boundless plea, unraveled minds eternally free. The maps we've drawn dissolve in the tide. The compass falters where starlight collide. A plane unfolds beneath our feet while the sky above hums wild and sweet. Through the silence, echoes sing, a thread of doubt on fragile wings. We soar through a fractured sky where the heavens twist and the old truths die. A fleeting glimpse, a boundless plea, unraveled minds eternally free. In the crucible of signs, we cast our chains aside. In the celestial void where questions collide. The tools we wield, the tales we weave, are shadows of a truth we grieve. A spark ascends, the veil ignites. We chase the dawn through endless nights. We break through the barriers blind. In the eye of the storm, our fates redefined. A fleeting glimpse, a boundless plea, unraveled minds eternally free. Through the chaos, we stake our claim, seekers of wonder, forever aflame. As the sky unfurls in a dance of light, we tread the plane through the endless night. With eyes unclouded, we breathe the unknown. A world remade, our seeds are sown.
tankard's rim, where rum would slush and spirits swim. Our compass point as sharp as gin. We sailed where no sane man had been. With whiskey's fire and sailor's thirst, we drink until our bodies burst. The sextant gleamed like polished ale. Our charts were stained with every tale. Yo-ho, drink deep and fill once more, where every cup demands an encore. Each league we mark with fierce delight will drain these seas from dark to light. Through storms we'd laugh with hearty glee. Our laughter echoed o'er the sea. With jugs of grog and mugs of cheer, we faced each wave with not a fear. Yo-ho, drink deep and fill once more, where every cup demands an encore. Each league we mark with fierce delight will drain these seas from dark to light. Sailor's life is rough but grand, a tankard ever in our hand. With salty breeze and tales to spin, this life of ours is never thin. A night of revels on the shore, with barrels full we'd always pour. The taverns echoed with our tune, 'neath silvery stars and golden moon. Yo-ho! Drink deep and fill once more, where every cup demands an encore. Each league we mark with fierce delight will drain these seas from dark to light.
our sailor seal. Rum in hand, the jack's true pride. We'll sail this world from side to tide. No globe can trick us, no rounders lie. Our section sharp beneath the sky. Yo-ho, drink deep and chart the way, where oceans stretch and waters sway. Each league we mark with sailor's might. It's flat and steady as the night. The compass points, the tankard swings. No round of tricks will cloud our view. We navigate like jacks so bold, where charts reveal what sailors know. No spinning ball can shake our core. We know the truth down to the floor. Yo-ho, drink deep and chart the way, where oceans stretch and waters sway. Each league we mark with sailor's might. It's flat and steady as the night. From port to starboard round the lee we'll go. We flatter sailors surely know. No curve can break our weathered will. We'll douse our doubts and drink our fill. Yo-ho, drink deep and chart the way, where oceans stretch and waters sway. Each league we mark with sailor's might. It's flat and steady as the night. Yo-ho, drink deep and chart the way, where oceans stretch and waters sway. Each league we mark with sailor's might. It's flat and steady as the night. So raise your glass to sailors bold, who chart the world both new and old. Our map is flat, our spirit free, masters of our own flat sea. Our map is flat, our spirit free, masters of our own flat sea.
Hello, is anybody here? Hello. Hello, I have some questions.
What's up, dude?
I have some questions about your flat earth theory. Should I
Okay.
ask?
Oh, yeah, go ahead, dude. What's up, man? Don't be
Why
shy.
do you believe earth is flat?
Because the earth is measured flat, observed flat,
What?
utilized as flat. Observed, measured, utilized as flat.
How do you measure?
Deviation from horizontal. See if the earth is dropping away or
Deviation
not.
from horizontal?
Yeah.
Okay, I'm not understanding. Can you please explain me?
Yeah, for sure. Like if you put a ruler on top of a basketball,
Yes.
you can move incrementally or every
Okay.
centimeter or every inch along that ruler.
Yeah.
And then you
Okay.
can
So which
measure the space between the ruler and the basketball, and you'll notice that it increases.
which instrument do you use?
A laser.
A laser.
Yeah.
When?
Said when
Yeah.
or where?
Do you measure, or do you believe that someone else measured and he told you?
Yeah, well, I'm not the one measuring. I'll be clear. I'm not measuring anything. I just go
Okay.
by how every
You
body
know, you
measures
know,
the earth.
you know, Actually, I'm a civil engineer.
Okay. Awesome.
Oh, so we do survey. We do surveys on land. You know.
Oh, nice. Okay.
So we have the instrument called auto level. Do you know?
Okay. Yes.
Auto level and total station. So
Yes.
if we are measuring land the size of more than 200 kilometers in area,
Okay.
we
Okay.
have to consider the curvature of Earth,
And how do
or we
you?
cannot. Yeah,
Okay. Well, do you actually measure that, or do you calculate the curvature of the earth?
I don't understand. Measure that or calculate.
Yeah,
Yeah.
how do
Did
you
you actually?
differentiate which
Oh,
one of
sorry.
these is true?
What?
Yeah. Sorry, Lats, I wanted to jump in.
Oh no, you're good. Please, please, no, you're good.
Yeah. So, Ruman, I'm glad you jumped in here. I understand what you're saying. The
Yeah,
difference between plane surveying and geodetic
yeah.
surveying is scale.
Yes,
Is
yes,
that
yes, yes,
250
yes, yes.
mile? Yeah.
Yeah, yeah. You are right. You are right.
Yep. So how do you
Tell me how can
differentiate which one is true?
how do I differentiate which one is true? I don't understand what you are saying. Sorry.
Right. So at scale, at 250 miles, you have one measurement
Okay.
using planar surveying.
Okay.
On the other hand, you have a measurement plus refinements under geodetic surveying, where
Yes.
you reduce the
Yeah.
horizontal datum in the
Yeah.
direction corresponding to orthogonal to the vertical.
Yes.
How do you know the geodetic version is true?
Because if it is not true, then we get our calculations wrong, now.
Yeah, I know, exactly. But how do you know that those calculations are wrong?
We cannot.
That's
We
what I'm
cannot.
asking.
We no. If it was wrong, if it was wrong, then why we if we consider the curvature of Earth, we get our calculations right. We still get wrong, no?
Yeah, how come everybody says those calculations are wrong?
If we don't consider the curvature of Earth, we should get our calculations wrong, right?
Yeah, I get that. So the calculations won't match the measurements. How do you know if the measurements are wrong?
Because if we build something on that measurement, considering the geological state of Earth,
Right.
we
I
don't
understand
any
that's the
error.
claim.
We don't get any error, or we don't make a structure that that go wrong. I think.
Yeah, I know the same thing. That's what they told me too. How do we know that's true? You know, do we have any examples of this going wrong? And can we study the error, the degree of error that increases over distance as physical real world examples?
It will appear now if it was wrong, considering the the doing the geotechnical survey. If it was wrong, then it will appear now.
Yeah, that's the theory. Can you show that's
But if
true
it
in
don't appear,
practice?
but it don't appear. So if it is not appearing, then we are doing right by considering the geotechnical geo. What were you saying?
Yeah, I get it. So the geodetic version is considered the most
Yeah,
accurate. Yeah, so how do
yeah,
we
yeah.
know that's true? Because I can
Because
present to you
we don't get errors, nah. That's why.
well, I
If
can
it was
present
wrong, then if it was wrong, then I will get errors and measurement issues, and we don't get the structure right.
right, but how do you know those errors are true in reality? Because I can present to you dozens of examples where the geodetic calculation is wrong and the planar survey is correct.
Okay, give me one example.
Yeah, would you like to see the building plan and study of CERN, the particle accelerator in Switzerland? When they built the particle accelerator in Switzerland, CERN, they discovered that they could not use a geodetic datum, which is a spherical coordinate system. They had to use a flat planar horizontal reference system instead. Do you want to see that?
Because the path of the what it called, the accelerator, the
Yeah.
path is circular, I guess. Am I right?
Yeah, it requires a horizontal
So
plane.
yeah,
So
yeah,
they
yeah.
used a horizontal
If
plane of reference.
if it was not circular, if it was straight path, then we will have to consider the geodetic state of Earth. But it was not straight line; it was a circle. So we can fit circle anywhere on a sphere. You know, it was still make a straight line.
Right, but they did not
Do you getting my
use
point?
they did not use a curving coordinate reference system for their building plan.
Because it was a circle, nah. We can put a ring anywhere on a sphere or ball, but we cannot put a scale on a sphere.
Yeah, that's because the radius of a circle can't be curved,
Yeah.
right? So they used a horizontal datum. There are many instances. I can show you United States Navy discovered that when they use a spherical coordinate reference system for the navigation of drone, unmanned aerial vehicles, that their precision for takeoff and landing using that coordinate reference system was improved when they switched from spherical to local and planar.
I'm not getting your point.
Okay. If you're trying to land an airplane and you
Yeah.
a spherical geodetic coordinate reference system. It's not accurate enough
How do you know, man?
because they tried it and they improved their accuracy
Who are
by
they? Who are
switching
they?
to a
Who told you?
planar.
Who are they and who told you, man?
This is the United States Navy. Do you want to see that reference too?
Yes, I want to see that. The plane reference you are talking about.
Okay.
Please.
I'll present both of these in the side chat and I have to step aside for a minute.
Okay. You can DM me. My DMs are open. You can DM me.
No, I'll post them here in the side chat for everybody.
Okay.
Okay, the one for the particle accelerator is posted, including commentary and citations and reference. I'll post the next one from the unmanned aerial vehicle program. Give me a minute.
Can you tell me why the other people say that the Earth is a sphere? What is the benefit of saying that the Earth is a sphere? Why they are playing with us? Can you tell?
For all practical purposes, the difference between spherical coordinates and planar coordinates over everybody's practical use is absolutely negligible statistically. So people can believe in one thing while they're doing another, and most people have no way to tell the difference until it's actually measured. And not just measured, but measured within a degree of precision that's necessary to close
So
the error
everybody.
gap.
So what about the satellite photos of Earth? Every country is
Yeah, which one? Can you
telling a
post
lie.
one?
No,
Yeah,
no, no.
I'm curious. Which
Very
one?
any photo for by a Russian satellite or Japanese satellite or Chinese satellite or Indian satellite.
Yeah, post one, man.
So
I
everybody,
want you to
so
be
every
specific because
country,
I'm being hyper
every
specific. I
country.
want you to be specific. Post one.
Why does it need to be specific? Do I need to be specific about that? I'm just
Okay, because I'm being
saying
specific with
any.
you.
I'm just saying
I'm
any.
still looking
I'm
for
just.
my one from the US Navy
I'm
with the
just
drone
saying.
program.
I'm just saying. See. I'm just saying that if the photos are lies, so every country is saying a lie, then so
Nobody's
they are
saying that but you.
come on, man.
Just
No,
pick.
why do
Just
people
pick.
have to lie about?
Yeah,
Listen, people aren't lying.
why?
People are just mistaken or misled or delusional.
Yeah.
I don't know.
I'm saying, what about the satellite photos
Yeah,
they
pick
released?
pick
Yeah,
one. Pick
which
one and
one? Pick
post it.
one.
Why do I need?
Okay,
Why
cool,
do I
DJ.
need to pick
Thanks. I
one?
need a
Why
minute to
do I
find
need?
what I'm
Why do
posting.
I need? Why do I need to pick one photo? I'm talking
Because you
every other
can't.
photo of Earth. I am
Because
talking
you
every
you
other
have
photo.
it. Because you're imagining that there's all of these photos in your head of the Earth from
Okay.
space, and I would like you to pick one and post it in the side chat, and then
So the set.
you will
So
understand. You will understand
we
why
need.
we're asking you to do this once you pick one and put it in the side chat.
I'm saying so. you don't believe that satellites we have sent satellites in space
I'm
also,
not
I
making
think.
any claims about satellites myself, right? But you did. So you said that there's all of these photos from satellites.
Yeah,
So pick one of
yeah.
them, and let's evaluate it.
Okay. Mm,
Okay, I posted my two references regarding the particle accelerator and navigation with unmanned aerial vehicles in chat. So these are very specific cases in which a spherical coordinate reference system is deemed to be inaccurate. If you need like a week or two to study these, I get that because it takes me a week to read through a very dense academic paper too, and I enjoy it. If you want to read those and come back later with something, please do. And if you want to talk about something else, we can also do that. But I want you to read these and I want to hear your commentary on them.
can you tell me where are you getting this from? The paragraphs you have written on in the chat.
Yeah, I wrote commentary and I extracted quotations from the source document as a citation, and then I referenced the citation with a link. Yeah, so
So,
these are
so
my
you are telling
positive
you made
claims.
this. So you are telling you made this.
Well, the links are in the side chat. See the blue things?
Yeah.
The
But the
links. The
conclusion,
links.
I'm talking about the conclusion.
Yeah, those are my conclusions based off of
Okay,
my
okay,
evaluation of the
okay,
link.
man.
Listen, yeah, I
Okay,
evaluate.
I don't have. Okay, then I
Listen.
don't have time to read your conclusions, man.
I'm
Sorry.
sorry you don't have time. I'm not here to copy and paste.
Okay, man.
I like to
I was.
evaluate the
I
claims and
thought.
provide my
I thought.
insight.
I thought that the other people give the proof, or the maybe the Navy gave the proof, but it
Yeah,
was
they
your
get the
conclusion.
proof. Look at the title and then read the paper and then the conclusion. If
No,
you
I
don't
don't
like
have
my
time.
summary,
I
I'm
don't have
sorry.
time
You
to
can read
read
it for
your
yourself.
conclusions. I don't have time to read your conclusions, man. Sorry.
I know you don't have time to
I
do
thought it
anything
was
but
from.
complain.
I thought it was from Navy, or
It is from the
that's why I
Navy.
asked.
And if you have a problem, take it up with them.
Please send me the link of the Navy
I
claiming that
did. It's right
The
there.
links
The
are in
link
there,
is
dude.
there.
It is your conclusion. You have said that.
No, listen. Right? So he's
Or,
also written his own conclusion, but all of the
yeah,
core information is also there
yeah.
from the Navy, right? So
Okay.
it's
The link
quoted,
is of.
it's cited, and it's linked, right? So you can go and look over the information, and you don't even have to read his conclusions. All of the raw information is provided.
Can you give me the only information that I need, please?
It's all there.
Without his conclusions. Without his
Yeah,
conclusions.
it's all there in the side chat.
Yep. And you know what? I will read it for the audience regarding CERN. Here's the quote that I'm interested in. Quotation. The reference frame used at CERN to describe the position and orientation of all the geodetically aligned elements of all the accelerators is a 3D Euclidean reference frame referred to as the CERN Coordinate Reference System. The CCS was first established for the proton synchrotron, the first CERN accelerator in the late 1950s. The CCS is a modified local astronomical system. The principal point is the pillar P0 at the center of the PS. The z-axis of the system is by definition coincident with the gravity vector at P0. A horizontal geodetic datum was established with a topocentric set of datum parameters for the project using the GRS 80 reference ellipsoid. The principal point was once again chosen to be the geodetic pillar, and the ellipsoid normal is coincident with the z-axis of the CCS. Right? So when you read that, it may not be readily apparent what they're talking about. You have to understand what they're talking about. It's not enough to just quote and then plop it down, because I bet you had no idea what in the world I just read. What I just read to you was that they use a reference ellipsoid, and the same point that they used as the point of origin on their reference ellipsoid was coincidental with the Euclidean horizontal reference plane that they used for the building site called the CERN coordinate system, CCS, in Euclidean geometry. All right. Next one regarding the drones. Okay, posted the link from the US Navy. The purpose of this thesis is to incorporate the GPS and inertial navigation systems for the guidance of an unmanned aerial vehicle seeking the precise navigation in a local tangent plane. By applying the differential positioning technique, GPS position data becomes more accurate. This position can then be referenced to a known location on the ground in order to give the aircraft's coordinates in the local tangent plane. Again, you may not understand what you just heard or what you just read, which means you have to go into the text to discern the context. What they're telling you is they use GPS with the understanding that GPS provides latitude and longitude, which are spherical coordinates, but their position can be referenced on the ground instead without spherical coordinates using local tangent planes. And according to what they said, it becomes more accurate. I've got about 24 more examples of this. All right.
Emotional damage.
say, is 31 too old to become a flat earther and turn over a new leaf? Or do you think after so long people just will never let it go, even when presented with flight paths and plethora of information?
Hello and welcome to the Flat Earth Discord 24/7 on the English Hub today. And whoever that was that just came in, welcome to you. If you have any questions related to the Flat Earth or the heliocentric model, which doesn't exist in reality, please fire away your questions. My colleagues and I are here to answer your questions. Once again, a warm welcome to you. Well, you might be asking yourself, well, why do they say the Earth is flat? Why are they going against all the scientists? That means all the scientists might be wrong. Yeah. What's your proof? What's your evidence? Yeah, these are the kind of things that pop up from time to time when we have our discussions, sometimes shouting matches. Very rare, but it does happen. But yeah, you know. So why are we saying the Earth is flat, ladies and gentlemen? We're saying it is flat because we're not able to measure the supposed curvature of the oblate spheroid that we're meant to be living on, hurtling through that universe, that so-called universe that none of us have confirmed to exist, by the way. Okay, we've tried to measure the curvature, and we're not able to do that. When we go out and try to measure for the curvature, we are finding what I call extended horizontality, what the flat earthers called flat Earth. And what do we mean by flat Earth, to be exact? We mean we're not seeing the curvature or measuring it. We don't mean flat like a sheet of paper, because we do recognize that there's topography there. Okay, the mountains, of course, the valleys, the lakes, the ponds, the rivers, the ocean, the streams, these are all there. But that whole mass isn't curving at the rate it should be to make up that 3,959 mile radius, which goes on to make the 24,901 mile circumference, supposedly, of this ball Earth we're meant to be living on. We're able to make long distance observations, for example, and then we are able to also hit targets with laser beams at great distances, 28 miles, 24 miles. If the Earth's curvature were there, those targets wouldn't be hit and we couldn't make those observations. You know, there's a beautiful one that was taken a number of years ago. It's in the Guinness Book of Records. It's across a mountain range in France. I haven't dialed that mountain range in properly yet, and I do apologize, but it's a Guinness Book of Records. It's 275 miles. Okay. And when you look at the details of the camera, the elevation when the shot was taken, distance, of course, there should have been 9.5 miles of Earth's curvature blocking that camera's line of sight, but yet the shot was taken. So that's an inadvertent proof of flat Earth right there. Okay, no curvature. So that's what we mean by flat Earth, ladies and gentlemen. We do not mean flat like a sheet of paper. And by the way, if you were to examine a sheet of paper under a microscope, you will find it's very bumpy indeed. All the fibers are there, nothing's smooth. Okay, well, there you go. Who knew, eh? There we are. But that's what we mean by flat Earth, ladies and gentlemen. No measurable curvature. And of course, it has to be there. We're living on an oblate spheroid, supposedly, spinning through the universe. And yet, at close examination, we are unable to measure that curvature. How can that be? Today's modern technologies not able to measure a single degree of curvature of the Earth. It's very revealing in that situation. Okay, ladies and gentlemen, just in case you're wondering. So if anybody's coming in now and have any questions, please don't hesitate. We're here to answer your questions. My colleagues and I, we're here. Yeah, just think about it a little bit. Are you living on a ball that is spinning through the universe, covering approximately, 19.2 billion miles in 1 year? 19.2 billion miles a year. Times that by your age, and you'll have some substantial mileage there. And yet we're still looking at the same stars. How can that be? I'm 64. So 64 years times 19.2 billion gives you a serious gazillion miles or so. And I'm still looking at the North Star. I'm still looking at the Orion's Belt, the Plough, Gemini, Cancer, Pollux. All of them are up there, still there in the same place. Yeah. Okay, ladies and gentlemen, but that's what we've been told. Yes. Interesting, isn't it? Are we living on a ball that is spinning on its supposed axis on a tilt of 23.4 degrees at 1,037 miles an hour? That would be at the equator. If you're living in the UK, it's 600 miles per hour. If you're living in Alaska, it's only 500 miles an hour. You shoot over to Los Angeles, and that's 870 miles an hour approximately. See, but I've traveled around the world. I haven't noticed any difference in speed. Haven't noticed we're rotating at all, in fact. But that's what the maths tells us. And that's the thing about maths. Maths can tell you the truth and you can apply it to reality and it can work. Brilliant. And then there's maths that's known as pseudoscience maths, which is, it looks good, makes sense, but doesn't fit the reality we're living in. These will be the numbers I'm giving you, for example. 19.2 billion miles in a year. But yeah, I'm looking at the same stars. Oh, but the maths work. Okay. But then again, I'm still looking at the same stars. So are we moving? Clearly not, ladies and gentlemen. Clearly not. I strongly put it to you, we've been deceived there. And if we are to listen to, what's his name? Nikola Tesla, one of the greatest scientists that ever lived, stated that we had to be careful of the scientists and the mathematicians with their mathematical formulas, because they're moving from one formula to the next, to the point where these mathematical formulas don't actually represent the reality we live in. Okay, there we are. So we've got to be careful. We've got to check the maths and then apply the maths. And then that's proving that the numbers are correct. In most cases, they don't match, actually. And that's the problem we've found now, that some of the information is misleading. Can't measure the curvature, cannot dictate the motion on the rotation, cannot dictate that the Earth is orbiting the sun, cannot detect that we're moving in a solar system at 2.3 million miles per hour. We can't detect any of this stuff. The numbers are there, but actual proving is not possible. We're not moving it, it seems. So there we are, ladies and gentlemen. Just a little snippet there of the things we discuss relating to the Earth that we live on, whether it's a ball or is it flat. And I don't mean flat like a sheet of paper, but you know what I mean, though. Right.
Yo, what's up, guys? What's going on? How are you all?
Oh, well, very well here. Welcome, sir. What's your name?
Fubar.
Pubar. Is that Pubar?
Fubar.
Furbar.
F-U-B-A-R.
Welcome, Pubar. Assalamu alaikum. Welcome. How are you?
Bro, I'm not Muslim. I'm atheist.
Sorry. Okay, from the Philippines, but still I've been there. Well, welcome to you. And there are Muslims in the Philippines anyway. Does sound like an Islamic name. But yeah, welcome. And what do you have to say? Do you have any questions?
No, I'm just here to listen. Like, I see there are a lot of good chats happening here all the time about science, technology.
Yeah. Well, you've reached the flat Earth discourse here, Discord. And my question to you is, what is the shape of the Earth? And how do you know it's that shape? Proof do you have?
I'm agnostic on that point. Like, I'm searching right now. I'm
Okay.
learning and I'm seeking because it's just like It's just like some people believe Earth is a sphere, and some people say it's flat. But I'm agnostic on that point right now. I'm trying to seek, and over the time, when my knowledge, like when I will feel like I have got enough knowledge to make conclusion, then I will pick one side. But like I said, I'm
Okay,
agnostic.
I'm so glad you said that. Now, what kind of knowledge have you gleaned, have you picked up from the flat earth side? What have you learnt about the flat earthers since you're gathering information? What have you learnt?
Okay, so first thing, you cannot trust NASA and space agencies to understand like if Earth is flat or sphere. So because NASA has like put a lot of things in public that shows that NASA is not trustable. Like Apollo 11 video, like how they got back from Moon to Earth again. So that thing, like you can just watch that video. There's no booster below that spaceship they built. There's no booster. What is putting that trust on that? There is nothing to put trust, and then put that spaceship again in space, like from the surface of Moon. So technically, it's just not possible without putting any pressure and using fuel to come back to Earth. I think that was just a 3D video.
Okay, yeah. I can agree with you there. Let me just give it a little bit more substance because it's a good point there. Yeah, flat earthers tend not to NASA because of the material that they put out into the public domain. And you mentioned Fubar, the what do you call it? The Apollo 11 mission. Yeah, the ascent module. Fubar is talking about once they landed on the moon, supposedly with the LEM, the Lunar Excursion Module, and it's time to go home. Okay. Now the upper portion, known as the ascent module, fires up, but you don't see the exhaust plume. You see some sparks, ladies and gentlemen, okay, but you don't see the exhaust plume that's pushing this ascent module up. And then how were they able to get the camera to track it all the way up as well? So there's a lot of questions to be answered there. Okay, and
Yeah,
if you're
exactly.
listening to, yeah, go ahead.
Understand this. If somebody put camera there, then how it was recording? Like it was recording on his like here space station, where it was recording, and like the thing is, back then, like there was no way, like the 64 kilobyte. That was the capacity that they could put as a memory. So how they were even able to record and then come back, like there's a lot of things were almost miracle.
Okay.
If it's true, if it's not, then like most of the things I see, like it just shows that it was a facade, and they
Okay,
just wanted to win in Cold War, so they created all of that propaganda.
Okay, yeah. We don't want to go too far into that, but what you say is true. I'm not going to disagree with you there. And we stick with NASA and not being able to trust them because we have this guy called Robert Simmons, for example. Okay, and his nickname is other name, aka Mr. Blue Marble. So he created the blue marble that we all see in our textbooks and on our smartphone and tablet devices. Google Earth, that ball. Yeah, that was created by Robert Simmons, who is a NASA employee. Okay, now, and he states that it has to be Photoshop, right? Composite, CGI. It has to be. Those are his own words. It's photoshopped because it has to be, quote unquote. So the image is not real. NASA tells us that themselves that they don't have a real image of Earth from space. Has to be composite, CGI, photoshopped. Okay, so there we are. I don't trust that image at all. It's not real. And of course, with the question that was posed, how did the ascent module fire up when there was no exhaust plume coming out of that thing in a vacuum? Obviously not possible, ladies and gentlemen. So we can't trust the Apollo missions, of course, and the latest Artemis 2. That's a load of rubbish as well. Okay, but so if NASA wasn't in space, they couldn't have taken a picture of the Earth. Okay, that's fine. Is there any Fubar, any other things you've learned about the flat earthers? Anything else? I don't know if Fubar is still with us, but welcome to the individual that's in. Welcome to the 24/7 Flat Earth Discourse here on the English Hub. Thank you for coming in. I was just discussing with Fubar what's his evidence or what did he learn from the flat earthers. Okay, my first question was, what's the shape of the Earth? And how do you know that shape? He replied he was agnostic on that, and he's gathering information, all right, from both sides. So I asked him what information had he gathered from the flat earthers? What has he learned? He puts forward, we can't trust NASA. And he gave his reason why, because Apollo missions were basically hoaxed and faked. Okay, fine. Right. Then I asked him again, any other proof? Hasn't responded. So I filled in the gap there by mentioning Robert Simmons and the blue marble image that we have, as I said, on our tablets and smartphone devices, that Google Earth. He created that. That's why they call him Mr. Blue Marble. Okay. Is there anybody else in here that's a glober, has any proof as to what they've learned about flat Earth, for example? Because I asked Fubar doesn't seem to be answering. Okay, so Fubar seems to have disappeared. Very agnostic indeed, I'll have to say there. I'll just stick with that as agnostic position. You can remain agnostic, ladies and gentlemen, but you've still got to go out and check, because you gather all this knowledge you're acquiring. Otherwise, you're going to be agnostic forever, because you're not actually making any movements, any movements to proving. We're not moving towards actually proving anything. We're remaining agnostic. What are we waiting for is the question I always ask. Why are we waiting? Okay, you've got the information. Can you now go and check it? What's stopping you from checking it? Okay, because that's what you have to do. Then you will know. You cannot remain agnostic forever. That's an impossible. That's silly. It means you don't want to go and look then. Why gather all the information? And you can't make your mind up. You've got to try and validate this information. And the point I'm making really is that the earth is there waiting for you. It's waiting for you to go and check it. Sitting there every day. Here I am. Come prove me of all. Come and prove I'm flat. It's there every day. So you've only got to schedule in a few day a weekend with your friends, some holiday time, and then make it fun and go out and check to see whether or not you're living on a ball. If a Greek supposedly proved it, 2,500 years ago, Aristosthenes, then we should be able to do it like that. In actuality, though, ladies and gentlemen, the Aristosthenes so-called curvature discovery wasn't discovered at all, because he assumed that Earth was a globe. And if you look at his actions of measuring angles and shadows, that's all flat Earth work, basically. He's measuring flat Earth is what he was doing in actuality, and assumed that the Earth was a globe. So all he's done, a little bit of maths, and there you are. I've measured curvature, and he hasn't. Didn't measure a single degree. Once again, welcome to whoever's just come in. If you have any questions or the heliocentric model, please fire away your questions. Welcome again.
Hey, Jin, how's it going,
Yes,
man?
nice one, JJ. How you doing?
Hey, good, man. Hope you're good. We've got Professor Triangle. I was just tuned into a random globe. Oh, hold on a second. I can't hear myself talking. I just got to pause this. All right. Yeah, so Professor Triangle's in this live call with about 150 globers. And he's the only flat earther in there. And he's taken them all on. It's kind of funny to listen
Wow.
to.
Well, that's
There's
it.
a
One
giant
flat
chat
earther.
is triggered. So I'm gonna hit play. Not play. I'll stream it through my microphone if it works. So
Yeah,
I'll just give it a
please do.
try.
Thanks
All
very
right.
much, mate. Yeah, lovely.
See if it comes through.
Yeah, appreciate that. Appreciate that. We're not getting anything yet.
Yeah.
Yeah, but I understand the gesture, because I mean, obviously it's a quiet period here. So I mean, something
Yeah,
like what Professor Triangles is doing, that's going to be exciting. That's 150 globers versus one flat earther. There you go. It's like Spartacus. Let's go for it. The Spartans. That's what we flat earthers are like. Still working that out there, a little bit teething problems. Nothing's coming through yet. On my smartphone,
I have no idea why it's not working.
No, not coming through at all, mate. See, on my smartphone, I don't get on the little, and then I can now see the chat, right? So, and it's difficult to keep an eye on who's coming in and the chat at the same time. You see what I mean? Got to keep floating, which sometimes is inconvenient. So I do apologise if I'm appearing not to be looking into the chat and that. If you've been trying to reach me. What are we going to do? He's been asking. Well, don't worry. I've got a little something else to talk about. Carry on from where Fubar left off.
Tell if there's any elevation changes. Pretend that it's right.
Yeah, it came through just then, DJ. It was working. Very choppy, but it was working.
Now, demonstrate this. So again, again, this is a bird's.
Is that coming through for you?
Yeah, it's coming through, but very, very choppy. Not good at all.
Okay, I'm gonna try to see if I can fix my mic, because that is him on TikTok right now.
Yeah, it's not coming through as smooth at all. It's choppy and faint, so there's no volume to it. We need a volume up.
Yeah, okay.
It's difficult to get it to work through the mic here.
Yeah, do apologise for that,
Yeah,
ladies
usually
and
it
gentlemen.
works fine. For some reason, it's not working today.
Yes. We do apologise for that, ladies and gentlemen. We do have these technical hiccups and hitches sometimes. It does happen. It's the nature of the technology. Glitches is what I was looking for there. Glitches, yeah. The gremlins.
Neighborhood with a straight road.
Yeah.
So what is
Yeah, it's still choppy and low audio. We need volume.
Professor Trent, please listen to the words that are coming out of my mouth.
Yeah, that's not coming through my microphone.
Why? Because it's not diverted.
Yeah. You see, it's not crisp, clear. It's very choppy. It's sounding like it's coming from a vast distance. It's crackly. It's faint and not good.
This was actually a curved line.
All right. Well, we tried. Oh.
Yeah. So for audio quality, I'm only going to give it like a 3.5. To be honest, because it's sounding like we're using a very old-fashioned radio system in the middle of a Vietnam War. And, yeah, can you get me Blue Arrow? Can you that curvature like curvature, not magic. 300, 3,000.
I'm going to restart my computer and try again.
Jim,
Yeah,
I'm gonna
thanks.
try it also. I'm trying it again, okay?
Yeah, no worries, man. You go ahead.
It's kind of like calling the moon with the rotary dial telephone. How does that work?
Yeah, that might even be better.
Holy cow. 1, 2, testing. Am I
That
coming
sounds
through?
beautiful.
Yeah. All right, we're gonna try it again. I don't even know where the mic is on this thing.
We'd have to measure it.
Yeah, no, it's still crackly. Unfortunately, and choppy. It's not smooth. and not solid in the way of a smooth sound and continuous. It's not good. Sorry.
Yeah, let me try push to talk. I guess I'm gonna have to sit here and press it down.
Oh, that's not good, is it? Don't want to do that. I thought we.
Well,
It's a
it's
shame.
interesting stuff. Let's see here. Let's try this last test.
Yeah.
You said planes fly. They didn't fly in straight lines, did I? Didn't. Putting this triangle on a spherical object, those straight lines actually, from creating that triangle, end up having angles greater than 180. That's what we call.
Yeah, it's not very good, is it? It's coming in and it's coming in waves.
Okay.
So the volume goes up, then drops down. Little scratchy chop comes up. Yeah, it's not. It's a shame we couldn't tube or something. That's an unusual one. Yeah, because I thought we could do that. It's been better before.
Best I can do is post the TikTok link then.
Yeah, that's right. Then I'd have to do the TikTok link and get someone to stream it that way. That would be great. Yeah, it is amazing how people don't understand triangles are 3 straight lines. That does surprise me with people. I mean, they know it, but they don't seem to register it when we're talking about measuring and Earth and angles of elevation. And why do they get it wrong? Why don't they hit the nail on the head there? What's going on in their mind? Obviously, it's the indoctrination and kicking in. That's what it is. Right.
Come on, y'all don't think it's 10 times bigger? Come on. That's the best thing they got now. Oh, it's just 10 times bigger than the claim.
That's what they've been saying.
Like
Yeah.
when you have to resort to that, it's pretty much over.
Well, it's childish, isn't it? It's childish, isn't it? Now, come on. That's what children do. They've lost the argument. Now it's the last before they give up.
Yeah, if it's 10 times bigger than the claim, it's still not the claim.
Yeah, still not the claim. It's still wrong. How did they get to the moon then? If they supposedly went?
Well,
Come
it's
on.
only 40 miles away, right? So it should be pretty easy.
The moon should be. Yeah, that's true.
Yeah, the sun and the moon look exactly the same size to me.
Exactly. Position as well. And if you ask everybody, to just take time to think before you answer, and you ask them, do the sun and the moon look the same size in the sky? Yeah, most of them will say it does look the same. I think it's Roman was asking, why are we so emotional about the shape of the Earth? Well, I mean, obviously we're going to be emotional about the shape of the Earth because it's turned out not to be the oblate spheroid now. So there's an emotional uplift right there, because you finally know for yourself that you're not living on an oblate spheroid spinning and hurtling through the universe. You've just disproven that. There's an emotional uplift, much more than scoring a goal and winning the FA Cup for your team. In fact, not that I've experienced that, but I've seen my
Yeah,
team
like it
score
matters
goals.
if you're the Navy or not, Rumen. That's why you're getting clowned, right? It doesn't matter if you're the Navy, the Army, Joe Schmo from down the road, dude. If you got a piece of string, you can measure it.
Yeah, that's right. Yeah, that's why it's important in that sense. It's not a crime to be emotional about the earth that you live with, nature. That's not a crime. That's good acknowledgement of where you are. Sound, sure-footedness, grounded, in fact. It's very good.
I mean, most lighthouses wouldn't work, you know what I mean? But apparently they do.
Exactly. Great point. Yeah. I've often said, since becoming a flat earther, that I'd love to work in a lighthouse. Do you know that? I'd love to work in a lighthouse,
Yeah,
actually.
that'd be a pretty cool gig.
Yeah. Yeah. Some lighthouses have 3 staff members, so you do it in shifts, right? That's interesting. There are some that you're on your own. Still nice. Yeah, I'd love to work in a lighthouse. They can be seen from distances of like 60 miles and a little bit more. Yeah. Depending on the heights, of course. I've even heard 150 miles observation, so that's quite a long way.
It's pretty fascinating.
Yeah.
You should not be able to see a 50-foot lighthouse at 10 miles.
Right. There you are.
So how are they visible at 150? That's crazy.
Yeah. Yeah. Obviously, there's no curvature there.
There's definitely not a hill of water that's getting in the way. That's for sure.
Right. Exactly. Yeah. It's only when you start to investigate, we've been doing this now. Well, I'm into my 11th year. So earlier on, in the first year, I learned about all the lighthouses and then cell towers, and that they wouldn't work either because the Earth's curvature, the signals wouldn't be received. You'd have to have them very, very close. And then that wouldn't be any point in having them there. It's silly. So yeah, the globe really doesn't work with all our communications. Actually, it wouldn't work. Yeah, ladies and gentlemen, see, everything's working beautifully because you're on a flat earth. That is why we're communicating, and you can hear me now properly. Imagine that.
Yeah, I mean, why is it 66.6 feet at 10 miles, right? Why is it 666?
Yeah. Yeah. Why is it that the speed of light, they say, in a vacuum is exactly 670,616,629 miles per hour, ladies and gentlemen? That's what they say, exactly that
It's
speed
just
of
a
light.
coincidence, Jen. Just a quinkadink.
Yeah, a coinkydink. Yeah, yeah. Yeah. I had a friend who used to say that a lot. 2 friends, actually. Coinkydink. Yeah. One was Alison Brindalow, and then the other guy was my friend Derek Monahan. And they both used to say, "What a coinkydink." This is back in the 80s. Yeah, long time. I know that one for a long time.
But there's no God, Jen. None of that, it's all evolution, right, Jen?
Yeah, evolution. It's funny you say that because for the last from last month into this month, I've been talking about Richard Dawkins, Japanese students, showing them how English kids get educated at school. And Richard Dawkins is talking about evolution. Okay. I've got on the board a word called Shinri Sorsa. Shinri Sorsa. That's Japanese for psychological manipulation. Okay. And then I used Richard Dawkins' presentation of the Darwin theory as he's presenting it as fact, as psychological manipulation, evolution. Yeah. And the students were like, wow. You know, they were wowed because they were now learning that even in England, they learn about Darwin, and but it's not a fact, but yet it's taught as a fact, and it's not a fact actually in schools. Terrible. There you go. Yeah. Hence the word Shinri Sorsa, psychological manipulation.
Well, they think that it takes billions of years, right? And you and me, we're aware that the Earth is maybe 7,000 years old, right? But the point is that all of this can be sped up with radioactivity, right? So to say that it takes billions of years is just nonsense. Just look at Chernobyl.
Yeah. You know, was it carbon dating and stuff like that? It's not a precise and exact science. I do not agree that the Earth is 7,000 years. I can't agree to that. Okay, because I don't know that. I've got no proof of that. So my answer is I do not know the age of the Earth. I do not know the age of the mountains. How can you know these things? Man will never know, is the real answer. We don't know. Okay, so there's no way we know this. Not even the speed of light, supposedly in a vacuum, can be as proof. It's what they tell us. It's not what I agree to because I can't prove it. See, it's not been proven to me that
They don't
light
want
moves
you to
that
believe your eyes, okay?
Yeah. So this is where you know, AI will be and is being a problem because AI is only pushing out the information that man gives it to push out. Okay, so whatever you're researching and it's giving you the speed of light is that. Well, that's
And
something
think
that
about
man is
how
putting.
dumb people are, right? So the
Yeah.
AI must be 100 times dumber.
Well, exactly. It's a tool they're using to dumb everybody down. Yeah. It's very true. And this is the problem, ladies and gentlemen, we're having with our education that we, the flat earthers, have discovered over the last recently 11 years of heavy scrutinization. We're now saying that what is the worth of a PhD if the PhD is giving you misinformation? You know, what is that worth? There you go. Welcome to the server, whoever that was just came in. If you have any questions related to the flat earth truth and the heliocentric model hoax, please ask your questions. Don't hesitate. My colleagues and I are here to help you out. Please carry on and welcome to you. It doesn't matter the kind of question you may have because everybody learns from every question that's asked, no matter how strange you might think it might be or how funny, whatever. We learn all the time. So if anybody's having doubts about the Apollo 11 moon landings, for example, or the Apollo missions, let me help you with your doubt, give you something more to be thinking about. And it's the shielding. Shielding. What kind of shielding did NASA have to contend with cosmic ray particles? You're thinking, what are cosmic ray particles? Okay, cosmic, go ahead. Go ahead.
Yeah, I was thinking that. That's why it was funny. Go ahead.
Okay, right. So cosmic ray particles, ladies and gentlemen, are the material that's left behind after a star goes into what they term supernova, explodes and dies. All right. Now, when it explodes and dies, it's shooting this material in the vacuum of space at almost the speed of light. Okay, this material. Okay, so that's what I said earlier on, 670,616,629 miles per hour. If you want me to bring it down even more for you, it's 1,086 sorry, 186,282 miles a second. Okay, I'll say again, 186,282 miles per second. Okay, so in 1 second, that material would have traveled 186,282,000 miles. Okay, now with that kind of velocity, what shielding did NASA have to absorb that kind of material flying at its spacecraft? And this material, if you can imagine a rainy day, that's how much material will be hitting the spacecraft. Okay, like a rainy day, but you're in space, in the vacuum of space, supposedly heading to the moon, flying through this material. And if you want to get it small, scale it down again, for every square centimeter of your spacecraft, square centimeters, 4 particles per second, every second hitting that spot. So you can imagine that the spacecraft would be shredded to smithereens. Remember, 186,282 miles a second. So whatever's hitting the spacecraft is going to go through and go out the other side. You can't stop that. The only way you'll be able to stop that, apparently, according to NOAA, National Oceanic and Atmospheric Administration, NASA would have needed 2 meters thick of shielding. That's 6 feet of shielding all the way around the capsule and the lunar command module to protect it from these cosmic ray particles. 6 feet of shielding. They didn't have that. 6 feet of shielding.
How do you know that you need that much?
Oh, this is coming from National Oceanic and Atmospheric Administration. That's
So
what
who measured that shit?
Well, exactly. Well, that's what they tell us.
Oh, okay.
And
yeah, so
and you get this source. Yeah, you get this source from the book called NASA Moon America by Ralph Renee. You can get it on PDF or you can buy it on Amazon still, I think. So that's the book, NASA Moon America by Ralph Renee. The information is therein. Okay, exactly. Who measured it? It's a great question, but that's what they tell us. And the question is, did NASA have said shielding in place? No, they didn't. So they couldn't have gone on just on that ground alone. Cosmic ray particles shut down Apollo missions because they didn't have the required shielding to contend with the cosmic ray particles. Unsurmountable problem for NASA. Okay. 6 feet of shielding, whatever that shielding would have been made of, would have increased the payload for the F1 engines to lift the Saturn V rocket. Okay. And if we listen to Don Pettit in the documentary called The Tyranny of the Rocket Equation, you can look it up. The Tyranny of the Rocket Equation. It deals with payload, mass, and trying to lift off the surface of the Earth. Okay? It's a really good one. Don Pettit being an astronaut from NASA. I still think he might still be employed by NASA, but there you are, Don Pettit. Yeah, so think about that, ladies and gentlemen. Cosmic ray particles, this is the material left behind from stars that explode in the vacuum of space. They die, they shoot the material out at almost the speed of light. And did NASA have the required shielding to contend with that massive cataclysmic problem, life-ending problem? Okay, you don't survive that. What did they have in place? What redundancies did they have in place? Yeah. It's just coming up for for 7 a.m. in the morning here in Japan. Rainy season, and of course, it is raining. It started at around 5 o'clock. I was going to go out for a run and that, but I thought I'll give it a miss this morning. Okay, so there we are. It's raining now.
Hey, Jen, can you hear me okay?
You can hear you loud and clear, yeah. Sorry for the delay there. How you doing?
I'm doing good, man. Hey, we were talking, and we were talking before a few weeks ago about like how we look back at our lives and find evidence, you know. And so back in 2002, I actually was in Japan, in Tokyo, for like 2 hours because we were on our way to Thailand for a mission trip, and
right.
It was really interesting because they actually showed us before we were on the flight how we were flying up to Detroit, and then they showed us this big thing. They said, well, the jet stream is coming across to the east, and so we got to get up and fly above the jet stream. We're going to fly over the islands of Alaska, and then we're going to come down and we're going to land in Tokyo for the layover and then ship over to Thailand. They were like, oh, that's cool. And so now I know that's, bullshit. It's why the flight path is that way. Because I know we don't do like flat Earth models of empiricism and stuff like that, but if you look at a flat Earth model, the flight path makes much more sense. Because from this point, you have to fly over the Alaskan islands to get around the North Pole. And then if we just flew straight to Thailand, which we could have done, everybody been like, why are we flying through Russia and China on our way to Thailand? This makes no sense at all. But it makes total sense when they had to make the stop in Tokyo on a flat Earth because it's almost a straight line down there to Tokyo and then over to Thailand, which they have to do. Otherwise, we would have gone through Russia and China and I don't know what the hell we were doing. So it's pretty cool to look back and have some evidence of like, hey, that's why we took that path.
You sound really excited. You sound really excited about what you're talking about, which tells me that this is what I want to ask you. Did you know that the azimuthal equidistant projection is the same as the globe? Did you know that?
Yep.
So, what meaning is there when you say things totally work on a map that's the same as the other map with a different name? Does that not hit y'all consciousness this many years in after it's been brought up this many times? I'm sorry, because I'm not trying to take your happy. You were very happy about what you're saying. But again, what I'm saying is also true, and you also just acknowledged that it was true. So what level of delusion are we accepting for this moment of happiness then? I don't understand what you're saying, why you're so happy about it when you understand and have confirmed that what I'm saying is accurate. Anyway, whatever.
I mean, I'm just saying that the flight path they on a globe, the flight path that they did was giant, huge, circular, like St. Louis Arc type shit that they said we had to do, and we don't. It's nonsensical as is to take that flight path when you actually look at things. But when you actually look at like the direction we went, it makes total sense. It makes sense that we had to go over the island of Alaska because I saw them. The pilot told us, hey, look out, there's the Juneau Islands and everything. We're like, oh, that's cool because we followed the flight path. But if you look at that thing, like the path we actually went on, it makes more sense that we had to go that way and land in Japan. Otherwise, we would have gone to a path that nobody would have understood.
Yeah, that Gleason's map, although we can't say it's 100% accurate. I agree with that. But the flight paths do make a lot of sense when you compare that map and the globe itself. Okay, we say it's a projection of the globe, but if you look at the globe and the flight paths you're given when you are traveling on the heads-up display of that globe doesn't match what the Gleason's map is showing us. Two different paths. One of them's got to be correct. And obviously the straight line is logical because aeroplanes generally fly in a straight line from their departure to their destination. Straight line. It's all about economics here. Otherwise they're going to be losing money going the long way round. So yeah, it surprised me anyway. some of the flight paths that I've checked and looked at really do make a lot of sense on the Gleason's map if we plot the routes on a globe. That's all.
Yeah, like the emergency landings that happen in LA on a flight from, Buenos Aires to New Zealand. It's like, well, why are you stopping in LA in the Northern Hemisphere on your way to New Zealand? That makes zero sense. And if you put it on pretty much any, like I said, I'm not picking one, I'm not saying it's accurate, because our maps aren't accurate. But if we take any of the flat Earth maps that we have out there and look at that flight path from Buenos Aires to stop in Los Angeles on your way to New Zealand, it's pretty much a straight line versus this giant triangle weird shape.
So in your mind, despite you agreeing with me 5 minutes ago, the quote unquote flat Earth map is accurate, as in a different thing than the previous thing you were judging it against. You think you're telling me they're different? That's what your understanding is? Like when you say the flat Earth map is more accurate as opposed to the globe, that's what you're saying. There's an accuracy about the directions and what this is, even though you heard me say it's exactly the same, you're still saying one is differently better. And that's not a problem. Okay, it's not a problem. Whatever. All right. I'm just trying to. I'm just trying to keep up. I'm just trying to reason it in my mind, like what that means.
Well, yeah, I'm trying to use like common sense there again, with like the same kind of thing. Like I was just saying, the Buenos Aires New Zealand thing. If you're on a globe and on a globe, why would you stop for an emergency landing in Los Angeles from Buenos Aires to New Zealand?
I'm sorry.
That doesn't make any
When you
sense.
say common sense, I hear what you're saying, but that's not common sense. That's your interpretation. The common sense part is the fact that you're talking about one thing as if it's two things. That's the part that makes no sense to me. That's as common as it gets. What you're saying makes sense if there are two different things, but they're not. That's what makes what you're saying not common sense. But you're not getting that. So it's like, I mean, people are going to hate me for trying to, whatever. All right.
Yeah, I've got one thing that's needling me about what was said about the AE map, you know, the Gleason's map versus the globe itself being two separate things, or are they the same thing? The reason why we're acquiring this one is because, for example, we're going to go back to 2015, Chinese woman leaving in China Airlines, going to Los Angeles from Taiwan.
Oh.
If you look on the globe and you position yourself in Taiwan near China, little island, and you're going to leave Taiwan and you're going to head to Los Angeles. You're going to head east, heading east now, across to Los Angeles. 5 hours into the flight, the woman's water breaks. Now she's giving birth to a baby girl, right? On that flight. 5 hours into the flight. Yeah, go ahead. I heard a voice. Hello.
Hello. I was just trying
Hello.
to say nice to meet you. Yeah.
Yeah, nice to meet you too. Welcome. Very good.
Thank you.
You might.
Thank you for
Yeah.
your hospitality. Yeah.
Yeah. What's your name?
Banana.
Sorry, your name?
Banana.
Really?
No,
All right.
this is my name in the Discord.
Okay. Okay, Banana. Welcome. Where are you from?
South Korea. Nice to meet you.
Okay. Nice Korea. Nice South Korea. Okay. 처음 뵙겠습니다.
처음 뵙겠습니다.
Yeah.
안녕하세요.
That means nice to meet you, basically, ladies and gentlemen. Okay, right now. So you've arrived here on the 24/7 Flat Earth discourse on Discord on the English channel. My question to you is this: what is the shape of the Earth, and how do you know that shape? How do you know it's that shape? What proof do you have? How have you proven it to yourself? Okay, Banana.
Yeah, I'm Banana.
Yeah, yeah. My name is Jin CBR1. So that was the question to you was, or is, what is the shape of the Earth, and how do you know it's that shape? What have you done to validate so you know it's true? Go ahead.
Earth is a globe.
Okay, right. How do you know this?
Because if it's flat, then we can see the sun when it's dark, when it's night, because it's flat.
Okay.
If it's flat.
Well, that's a misconception because you're looking in the wrong direction anyway, right? You know, because you know the sun doesn't prove the shape of anything, does it? Does it now? Does it? Yeah. If you look, if I look, I'll give you an example. I'm on the Earth. I look up at the sun. How do I deduce I'm on a globe by looking at the sun? How?
How?
How do I know that the Earth is a globe shape when I'm looking at the sun or looking at the moon, for that matter? How would I know I'm on a globe? Can you see the problem there? Because I asked you, I asked you a simple question, and it was, how did you prove it to yourself so you know? How do you know? You don't know by looking at the sun. Nobody knows. Can't look at the sun and say, I'm on a globe. No, that's not the answer there. So can you please answer the question properly, please? How did you prove to yourself that you know you're on a globe? How did you do this? Banana. What?
Globe?
Yeah, did you hear the question? Did you hear the question?
Yeah.
Okay, well then go ahead then. Everyone's listening.
I think Otani Shohei should get a Golden Globe. He's a good guy. He's a good pitcher. I don't know. My English is not good. Sorry.
Yeah, Otani Shohei. Yeah, no, we're not interested in Otani Shohei. We're talking about, you know, the Earth is a globe. Can you answer the question, please? You said it's a globe. How do you know it's a globe? Can you not answer the question?
I just know. I just know.
No. How do you know? You can't just know. That's not knowing. Nobody
I
knows like
know.
that.
I know.
Yeah. How do you know? What did you do to confirm and validate that the Earth is a globe, or are you just believing?
I
I
just
know.
believe. And
What? So the answer is you don't know, do you? You don't know you're on a globe, do you?
Huh?
I said you don't know. You don't
I
know
mean,
that you're. Yeah, go on.
Jin CBR, listen to me.
I'm listening.
Yes, all those flight flight driver, airplane driver. They
Yeah,
use
yeah.
they use a map that is based on the Earth's globe, and they optimize the route, right?
Well, actually, that's
Why do
not
you think
true. That's not
why
true.
is
That's just a
it true?
digital, computerized image that you've got there that you're looking at. That's not actually the Earth as a globe. That's just an image that's put on the screen for you to look at, showing you your departure point and then your destination point. And then it's giving you a curved trajectory, of course, but the plane isn't actually flying like that, and giving you the distance to that destination, and so on. It's not proof.
I
Actually,
have a question.
no.
If the Earth is flat, where does the water drop then? Where? Which point?
Again, it obviously lands on the ocean, on land if it rains. If you're talking about rain,
No, I'm just saying all those oceans should drop to the
oh, you
space.
mean so you're talking about an edge here? Well, we're
Yeah.
not a disk in space, okay? We are not a disk in space, okay? So you're not answering my question. You're going to a flat Earth question. You're answering a question with a question.
Je viens toujours à l'école, c'est maintenant choupi. Je viens.
Okay, that was a bit of French there. Okay, now what I want to say to you is this: so you don't know you're on a globe. That's what you're actually demonstrating right now. You're demonstrating that you don't know you're on a globe. Okay. Okay.
Dragon Carenori.
This is where the moderators should be kicking in, by the way.
No,
Because
I
I'm
mean,
not a mod.
what do
Because
you
if I
mean?
was a mod, all this nonsense wouldn't be going on. So if there's anybody who's a mod here, can they not silence the interruptions? Thanks. Because I mean, if I was a mod, immediately, boom, mute that person, and boom, mute that one. Right. So, Banana, question to you again is that, or I'm going to reaffirm what I said. That means you don't know you are on a globe. Then you don't know that. You have no proof. Is that right?
I have a proof. I told you.
No, that's been debunked. That the image
No,
on
that's
the
critical thinking.
on your
Critical
doesn't
thinking. Why do they hide
again.
the fact? Why do they hide the fact then?
Well, again, the question still stands. How do you know? You've got to concede that you don't know. That's what you're displaying at the moment. Your attempt to give us proof isn't proof. Okay, that's not proof what you put down. Sorry.
If the Earth is flat, why I saw the normal that works show me
Oh,
I can.
hold on. I gotta interject.
Yeah, interject, please.
He's. I understand what he's trying to say. He's trying to say, if the Earth is flat, then why doesn't it look like all these things? Why doesn't it look like the cartoons that I seen, when I was taught in school and things like that? We don't think that the way you think outer space is, we don't think that there is an outer space like that to go to. We don't think that you can go to other planets because Earth is not a planet. The only place that you can go is Earth, right? Earth is very special. It's very unique. There's nothing else like it. In fact, it's the bottom. It appears to be the floor of the entire universe, right? So You look up in the sky, and everything up in the sky is the same. We all see the same thing. The difference is you think you can go there, and we don't. The water is not falling off the edge. It's contained, right? We're all inside this contained environment, and wherever that container is, the water pushes up to it, and then it comes back. That's it. It doesn't
Damn.
fall off the edge.
Are you a scientist?
Everybody's a scientist if you want to practice science.
Yeah, you don't need a
How
qualification.
do you explain the gravity then? If it's not a globe.
Well, yeah. So what happened was they told us that gravity makes the Earth a sphere, and then they told
No,
us how
it's
big the.
clear that there is a
Hold
gravity.
on. They told us how big the Earth was, right? So then we went out and we checked for the curvature, or what would be the consequence of curvature, because boats go over the curve, the sun sets behind the curve. So we went out and did measurements to go and check for the horizon. And what we found is that the horizon is completely optical. It's not a physical location. And so it measures flat because there is no measurable curvature. If there's no measurable curvature, then that means it measures flat, right?
Yeah. But I mean,
that's pretty much it. If it measures flat, then whatever gravity is only happens on a flat Earth.
Yeah. So did you get that, Banana? That was show me data, basically, and to the data, and that would be the measurements. Which I was going to get to that. My methodology this time round was trying to get Banana to concede that he doesn't know he's on a globe. I'd already put to him that we're not a disk in space. Hang on, I'm nearly there. I had already put to him that we're not a disk in space, and then my methodology was to then get a concession. Okay.
And I think he's genuinely honest, Jen. I just think that the language barrier makes it hard for him to communicate, and so
Not
we kind of
really.
have to follow his tail. You know what I mean?
No. I
Yeah, hang on.
understand
I got
100%. I understand 100%. Actually.
Thank you. So show me data. Just listen to what I'm saying. I'm aware of his English ability level. I knew where he was going with the where does the water go, because he knew he meant the edge. And I said to him, we're not a disk in space. And my methodology this time round was to try and get a concession. He didn't know he was on a globe, and then we would go to the measurements, etc., etc., etc. So I was pressing for a concession.
He doesn't know what he's conceding, though, and the thing
Well,
is,
of course he does. Of course he does. His English is perfect. He said it himself.
Well-
I understand perfectly. So he understands. He understands.
right?
Right.
So Banana. The point is, we got to a point where, we understand what curvature is. We know what a circumference is. We know what a radius is. And what we did was we measured a tangent against the surface to see if there was curvature, that drop over distance. And what we're finding out is there is no drop over distance. So now we're confused because there's no measurable curvature. And so now we're stuck with a flat Earth. And then whatever's happening in the sky is only happening over a flat Earth. We're not in a heliocentric model. We're not the third disk from the sun orbiting the sun. It appears that everything moves over our head and we're the center of everything.
Yeah. Thank you. Show me data. Did you understand that, Banana?
Yeah.
Okay, good. So when I said to you, you don't know you're on a globe, I was correct, wasn't I? Because you hadn't made any measurements. You cannot look to the sun and say, oh, I'm on a globe, because that's not right as well. So when I was asking you, you don't know you're on a globe, the answer should have been, yes, you're right. I don't know I'm on a globe. Isn't that not true? You don't know you're on a globe because you haven't done any measuring, you see, which is where I was going to get to. But, obviously, show me data was very quick to the draw there. I was taking my time because I wanted to get that concession from you. That true, honest statement that you don't know you're on a globe. Is it true? Yeah? Banana?
Yeah. The
Not
first.
every time we need to measure something to know something.
Yeah. Right.
Well, that's we all thought that the sun went behind the curve of the earth. We all thought that boats went over the curve. You know, we were just like you until we actually just went out and measured it one day.
Timothy? I mean, I say like it's we don't need to measure everything every time, you know, to know something, you know. You poop something, you imagine you poop something, you know that it's a
Well,
poop.
you can
don't
you
have to
can
measure.
calculate it. You can calculate it, but if you measure it after you calculate it and you find out your calculations are wrong, you have to go with the measurements. Calculations aren't everything.
Measurement is going to be the most accurate, okay? Because sometimes you do have to measure so that you know. You can't guesstimate it and approximate it. You have to know exactly. So regarding the shape of the earth, you've got to try and measure the curvature, of course. That's going to be the number one methodology to employ, so you know. You can't guess it. Do you understand? That's not accurate. That's what it means. So in this case, you have to measure. The measurements are critical, crucial, fundamental.
Fundamental?
Absolutely. If you want to know whether or not you're on an oblate spheroid, it is fundamental that you go out and try and attempt to measure the curvature of the Earth. It should be there if you're living on an oblate spheroid. It should be there. We've got the numbers. We've been given the numbers.
Yeah.
All right. Okay. So Banana's still there.
I'm telling you. You don't have to measure every
No,
time.
you're incorrect in this point. You're incorrect in this point. In this point, in this situation, you're incorrect. Okay, you have to
But
measure.
we did measure it this time, and now we're stuck with the actual measurement, knowing that the Earth is flat. So whatever's happening, it's only happening over a flat Earth. We're stuck
So
with
what
that.
do you guys want me to say? What do you guys want me to say?
Can y'all, all right, I guess, can y'all hear me or do I have to switch my mic?
Yeah, Eli,
Okay,
you're
so I
just
have to
coming
switch
through
my,
now, Eli. You're just coming through now.
okay. All I was going to say was, if you don't need to measure everything to know everything, then just start with how you know or how anyone would know the earth is a globe without the measurements. Because they couldn't have gone to space without the measurements, because they need that for orbital mechanics. So again, if we're to go with what you're saying, then how would anyone know that the earth's a globe? I'm sure you know, though. I'm listening.
That's exactly why I said he doesn't know he's on a globe, and he has to concede that because he hasn't made any measurements. Sorry, can you
I
speak
know
up
I'm
a
on
bit
the
louder?
globe. I know.
No, you don't know that.
I know you don't.
Let him tell us. Just let him tell us. Don't argue. Hey, so tell us how you know without measurements that the earth is a globe.
Who in
I just
2026
know. I
thinks that
told
the
you
earth
before.
is flat, bro?
I just know. I told you before. I mean, you don't have to measure
Okay,
it
so he
all the
doesn't
time.
really have conversations. So anybody else who wants to dick around with him, I guess you can.
No, I
But
mean,
since he's not serious, there's nothing I can do. I'm not about to waste my time, obviously.
Barrière.
Yeah, right. So we're going through the psychology of it all now, right? That's why I said to him he doesn't know because he hasn't made any measurements. Do you understand, ladies and gentlemen? It's not something that you know. No, nobody knows they're on a globe here. This is what we're bringing forth. This is what's being we're arriving at. This is the conclusion here. Okay, this young man Banana doesn't know he's on a globe. He's making a
I
statement he
know
does.
I'm on the globe. I know
And then
I'm
when
on the
we
globe.
ask him
I
how does
saw
he know,
YouTube.
when we
I
ask him
watched
how does he
YouTube
know, he
videos.
doesn't know. Yeah, come on. He doesn't know. We've asked you, how do you know? And you don't know. That's it, because you don't know. You're not giving us any
Are you feeling
evidence of your knowledge.
intellectual superiority?
Say that again?
So now, are you feeling intellectual superiority?
No, not at all, legend. That is not why I'm here. I'm not here to think I'm more superior or intellectual than anybody else. I need you to understand that we're living on actually a flat earth. And the way you're going to find that is to go and measure for the curvature of the earth. I want you to know the truth. That's it. So you can be like me and you know the truth. That's me shaking your hand, extending the assistance to you. That's all. Okay? You said you knew. I asked you how you know. You haven't told me how you know yet. You don't know is the answer there. Okay? Trying to be honest here. All right. Thank you. So no, I'm not thinking I'm intellectually superior. Child of 8 can get this. If children can understand this situation, are we a globe or are we a flat earth? And they can work it out. It doesn't require high intellect. Come on, man. Let's get serious here. Do you know you're on a globe? Okay, how do you know? Oh, you don't know in that actuality. You haven't offered any proof. Come on, man. You have to concede. You don't know you're on a globe. You've made no measurements. And as my colleague Eli said, how would they have gone to the moon if they didn't measure the earth and know that the earth was measured to be exactly what they said it was? You see? Couldn't have gone to the moon and gone to space, etc., etc. Gone to Mars.
Mars.
Yeah.
The Elon Musk is trying to terraform the Mars.
Yeah, well, we don't trust Elon Musk. You know, he's not somebody we trust. Another
Why you don't trust?
Because he's lying every day of the week. But anyway,
Lying?
and he's yes. But let's get back to where we are. You know, we're talking about the shape of the earth and how do you know? My colleagues, both of my colleagues, have mentioned the measurements, right? Which I was going to get to, but you know, here we are. We're at the measurements. So you haven't measured the curvature of the earth, so you can't claim to know you're on a globe. Okay, that's it. That's just it. Did you hear what I said?
Timothy? I mean, it's why you try to pick a fight with me? Don't do that.
No one's picking a fight with you. That's not what we're doing. I asked you a simple question at the very beginning. You said you know. I asked you, how do you know? You haven't given me a satisfactory answer. My colleagues have come in to explain to you that you need to be doing the measurements, okay, in order to know that whether or not the earth is a globe. You said, well, you don't need to measure everything. Well, in the case of this particular earth, you do need to. Go ahead. Yeah. Yes,
listen
Banana.
to me. So
yes,
listen
Banana.
to me. I go to toilet. I poop. I don't have to measure or look at it. Even though I don't look at it, I know I pooped a poo. That's a poop.
Yeah,
that's my logic. I know I'm in the globe. Even though I don't feel the globe.
That's a good example. Hey, look, hey, Olanger, that's a good example. Now I'm gonna ask you again because I don't know if you thought skipped out. I'm gonna give you the same point I gave you last time. So, something analogous to your poop, where you actually poop and you actually see it. You know, that's the 2 steps there. I did something came out of my body, I turned around, I can see it's there. Okay, how would you even apply that to knowing that the earth is globe? Like the simplicity of knowing that you pooped. Like, I'm not talking about the poop itself and the steps that you took for that. What steps would you take to know that the earth is a globe without measuring? Since you seem to think that obviously you think you know and you haven't measured shit. So why don't you go on and tell us how you know?
Gravity exists because the earth is a globe.
Oh, actually, you would need measurements for that. Because nobody measures gravity, but it's inferred based on the knowledge. I'm sorry, it's inferred. I'm sorry. Gravity is inferred based on the information that the earth has been measured to be a certain size and then given the mass that it was given.
I'm saying I'm not doing it. The Sir Newton did it in
No, he didn't. No, he didn't do anything. So you can't defer to, you can't say you just know stuff. You don't have to measure it. And then when we say, oh, there does need to be measurement, you're like, oh, well, Newton did that. No, he didn't. And if you're not smart enough to challenge us there, then
I'm not smart. I'm not smart. Yeah, I'm not smart.
all right, that's what I'm saying. So don't say things you don't know.
I'm not smarter. Oh.
Okay, so how did Newton utilize measurements to determine what the gravity is? Because again, you don't want to talk about measurements, so it's best you not talk about Newton. That's all I'm saying. If you want to talk about Newton, then I think you have opened up yourself to a conversation about measurements yet again. You want to do that?
Your pronunciation is really good. Newton. That's good. Newton.
So, but anyway,
well, if there was one person that wouldn't want to pick an argument to argue with on Newton, it would be you, Elijah.
I mean, I'm just telling his pronunciation is good. Newton. I like that. Come on, 이렇게 해주면 되니까.
You know, I keep it real simple. I say, if gravity makes the Earth a ball, then surely there should be some curvature that's measurable.
Oh. Mm-hmm. Guys.
Is this where you turn into a child?
Guys, what's the time there, guys? What's the time there? I wanna drink a beer. Do you know this song? No? 433 구현 데이터 논리 구조 다중값 속성
Yeah. Okay, Banana, stay focused. Stay focused. Did you
Hello?
understand what my colleague said to you?
He said, I'm not smart. I'm sad.
I don't think he said you're not smart at all. He didn't say that at all.
He said, I'm not smart.
No, he didn't say that.
I think he said something along the lines, if you're not ready to dive into that conversation, then
don't say what you don't know.
Don't say, yeah, basically that's it. You're not as smart as you thought you were.
Yeah, don't say what you don't know. You see?
I didn't say you weren't smart, just maybe you're not as smart as you thought you were.
433이니까 구현.
Right, well, whilst Banana's thinking that out, is there anybody else that's got a question? A young man came and said, hello. Are you still here? Maybe you have a question you want to ask us? Go ahead. Yeah, please ask the question.
What's the time in your country?
Oh, well, I'm in Japan here now, and it is now, let me just quick check. We've got 8:17 a.m. Rainy season, currently raining right now.
Why are you in Japan? Are you working there?
That's where I live.
日本語できますか？
日本語しゃべりますよ、もちろん。今は8時17分ね。午前中。朝。
はじめまして、私は韓国人です。よろしくお願いします。
木曜日。わかりますか、韓国人。だから、ちょんぺけすみにだ言ってた、先に。
はいはいはい。
はいはいはい。だから、今、地球は何ですか？平らか球体どっちか教えてください。
Earth is a globe. That's what I wanna しゃべる。
OK。でもどうやってわかるの？証明は何でしょうか？
証明は、 いらない。
必要だよ。必要。それ、測りしないと全然わからないになりますよ。見る、どうやってわかるの？どうやってわかる？その質問は、まだまだ。
僕わかる。
どうやってわかるの？
Hey, can we do English?
Yeah,
Jen?
sorry. Yeah,
Thanks.
we can. I was just asking the same as we were asking before. I do apologize for that. Basically, I asked him, how does he know the Earth is a globe? How did he prove it? What's your proof? And he's just saying he knows. And I said, well, that's not good. You can't just know. How did you measure it? Okay. And that's where we're at
I
the moment.
told you already. I know it's a proof. I don't have to measure. And he said,
No, you
know
have to measure it.
there's also
Like my
small
colleague.
smell. That's no measure. Like all those proofs are coming.
No. What proofs? Can you please mention the proof? You mentioned the aeroplane. That wasn't proof. Anything else?
Why does the scientists or astronauts are hiding the truth then? There's no point to them.
Okay. So now you're appealing to the astronauts. Again, how do you know that they went? Or are you just believing them without checking? You see?
I know.
How
Jin,
do you know? Please explain how you know then.
Why are you shouting at me, Jin? Don't do that. We're brothers. Don't
I'm an
fight.
African. Yeah, we're brothers, okay, but how do you know? どうやってわかるの？本当に。
I know. I told you. I just know.
No, you know, that's not an answer. It's not an answer.
You know, right? You know that Earth is flat. I know.
Yes,
Earth
because
is
measurement. 測りしたから、国立は国立の測りはできませんから。So we can't measure the curvature. That's why. That's why I know, man. Because I went out to check. 確認したから。ちゃんと自然に。
Do you
So I
watch
checked.
baseball? Do you watch baseball?
Yeah, my son is at a baseball academy. Yes.
Yeah. Do you like a baseball? Some people throw curveball. We don't have to measure. We know it's a curveball.
Excuse me. We're not talking about throwing curved balls. We're talking about the shape of the earth. And even that curved ball, that the speed at which it's thrown is measured. Again, it's another measurement there. But listen, we're talking about the shape of the earth and how you know. That's it. You keep saying you know, but you're not telling us how you know. And then you're saying all these proofs.
Know how you know. I know how you know.
Okay, tell me how I know. How I know what, by the way?
You are just believing it.
No, it's not. No, it's not at all. No, that's not a belief. Because like I said, I tried to measure the curvature of the earth only to find the flat earth. Do you understand? The curvature of the earth cannot be measured. You haven't measured it, obviously. Otherwise, that's what you would have said. I've measured the curvature of the earth. That's how I know the earth is a ball. You see? But you're not making that statement. Yeah?
Today
Anthony,
I will do the measurement. I'm so angry right now. And I'll come here again. What the fuck?
Okay, thank you very much.
Why you think I'm a stupid person? Why you think I'm a stupid person? That's
No, I don't think you're stupid, this person. あなたはバカじゃない。そういうことを言ってないから。その考え方やめてください。
なめてねえよ。
やめてない。やめてください。あなたはバカじゃない。
なめてねえよ。なめて。なめるじゃない。
Hey, Jen, this is an English only room. I mean, I
Yeah,
understand
I do apologize.
why you're speaking in, but it's an English only room. Yeah.
Yeah. I'm explaining to you now. Basically, he thinks we think he's stupid, and I'm saying that's not our position. We don't think you're
maybe
stupid
you guys
at all.
can do it in the side chat if he can't speak in English, then maybe we can take it to the text.
Yeah, okay.
He is trying to like overcome the language barrier. He's not a bad guy, Overfence. I understand you as a moderator, but he's a warm heart man. Don't swear him, okay? Very, very good.
Okay, so very good. Anyway, so you understand that we don't think you're an idiot or anything. I'm glad you said you're going to go and check it and come back. That's the spirit of a fighter. You're going to go and check it. That's what we want. Exactly. Sonotoridis. That means keep going. Keep going in that direction. Sonotoridis. That's the way we want it. Go ahead.
Jin, do you have a Japanese girlfriend or like are
my
you
wife
married?
is Japanese. Yeah, 26 years. 26年よ。
ああ、すごい。
すごいですね。はい。Yeah, it's fantastic. I know.
I wanna date a Japanese girl, really. I think they're a really
Well,
good girl. They're good in general.
ぜひ日本来てください。Please come to Japan then.
I'm in Korea, so I go there time to time. It's not that
Well,
expensive.
what's the problem? 問題は何ですか? What's your problem?
I don't speak good Japanese and I don't know.
Ah, okay. All right then, yeah. もっと勉強してください. Please study a bit harder then, please. There you go. But anyway, let's get back to the flat earth. So you're going to go and check for that. Okay. Thanks, Banana. Well done.
I'm
And,
angry. I'm angry now. You guys think I'm a stupid person.
No, we
So I
don't.
will
No, we don't.
check
That's the
and
last thing
talk.
we think. We don't think you're stupid.
Hold on, Jim. Hold on, Jim. So
Yeah.
what if we do?
So what if we did? Look.
What if you do?
No, I
Doesn't
mean,
matter. But doesn't matter. I'm just being
okay,
angry. That's all.
that's the point. That's the point. Because once you think we think you're stupid and you've accepted it, unless you're going to cry about it for the next hour, there's really nothing you can do about it. I heard you say it before, and I heard you say it before that.
Do you know this song, Elijah?
So what are
Yeah,
we talking about
Elijah.
in here, or should I get out of here?
No,
Like, what
stay
are we
there with
talking about
the
there?
flat earth and the heliocentric model.
Elijah, I was just like doing some assumption, you know. It's like if Earth is a flat, why does like astronauts or the scientists are hiding the truth? There's no point. They're not making any freaking like a profit from that. Why are they doing it? There's no point.
Actually, they are. Actually, they are making a lot of money from that. A lot of money is being made. All new industries have sprouted out. Okay, have been created. So they're making money hand over fist, whilst misinforming the public, and the public, of course, mind controlled, indoctrinated. So there's a lot of money being made, has been made, and is continuing to be made at the moment. Actually,
Really?
yeah. Japan is stealing the taxpayers' money and not going to space, for example. There you go. JAXA. JAXA is lying every day to everybody, much like NASA or RASA or ESA. Yeah? There you go.
Oh my God! No,
That's right. The implication is quite, the problem is larger than you think. Okay? So just bear that in mind when you're checking for your information.
I will come here
ChatGPT
again
and AI
later.
will misinform you. Sorry?
I will come here again later. Have a nice day, everybody. But don't.
じゃあ、あなたもね、はい、頑張ってくださいね。はい、頑張ってください。楽しいしてください。Yeah, please have a good time. またね。はい、どうも。Okay, good. So I just said to him, try his best, go for it, try hard, and get that information. Yeah. Yeah. So, yeah, usually I do translate into English and Japanese. You get it both. Just being a little bit lazy there, but there you go. Because I'm usually very good at that. I can speak Japanese and translate it into English quickly so you know what I'm saying. Yeah. So definitely can defend the flat earth in Japanese, no problem at all. Deja vu. Well, if are there any other globers who have any questions? There was a young man that came in and said hello earlier. Wondering if he's still in the place. Might have a question or two.
I was just looking up JAXA, and it says they're the Japan is the first people to land a craft on an asteroid and bring it back.
That's right. Yeah, they did. They've done that once already, didn't they? I think it was in 2018 or 19, or maybe even 2020, somewhere there. They landed on an asteroid, shot a projectile into the asteroid, and gathered that material, brought it back. They landed in Australia. think it was either in 2019 or 2020, something like that. Some
Oh,
kind of,
they shot it with something and then caught some of the debris.
Yes, that's what they did. Yeah, they shot a projectile at this asteroid, and then they kind of like scooped it up as a flyby. That was the methodology they did, right? And then transported that up. So they actually landed on the actual asteroid, fired a projectile whilst they opened the door to collect that material, supposedly what they said, okay, and then collected that and then brought it back. When you look at the return journey on the computer, it was just a little tiny white pixel dot. That was meant to be the spacecraft returning. What a joke that was.
Oh man, that's the best graphics they could have. It was just a little white dot. I mean, I guess they
A little
weren't going.
white, yeah, in the darkness of space, a little white dot, tiny pixel moving through the on your screen. That was them on the return, apparently. So, you know, they've been successful in fooling people on that attempt, so they're going to carry on with it, you see. Obviously. They landed on the moon, I think it was last year or the year before last. They crash landed, but seemed to right their rover. So that's happened. India also did, didn't they, on the moon, supposedly, upside down. The funny thing is, ladies and gentlemen, the Lunar Reconnaissance Orbiter that gets to see the Earth 12 times a day, supposedly orbiting the moon, deployed back in 2005 at the cost of, what was it, $500 million, $500 million, right, orbiting the moon 12 times to see the Earth 12 times, didn't capture any of these spacecrafts approaching the moon. No image at all, no video image of this stuff. Don't get to see the video images of this happening with the Lunar Reconnaissance Orbiter, the LRO, it's called. Seeing the Earth rise 12 times a day, every 2 hours. And yet no images of the approach of these so-called vehicles. Very hard to believe that you can go to the moon. I mean, we know they're not going, but they keep making these big foul-ups. Massive claims, no actual real images. It's like playing chess. We keep giving them the check. We've checkmated them so many times, it's unbelievable. Okay. Hey.
What do you think about the sun, Jen? Because he brought up the sun, but I don't think I really remember you saying like what your take is on it. I know it doesn't matter. It doesn't like measure the Earth to be flat or anything from looking at the sun, but just from your perspective, over.
Well,
I'll take a stab at this. Hold on.
Yeah, go on then. Take a stab. Let him take a stab.
I'll take a stab at this. I'm the no joke.
That's okay. I'm going to be honest with you, okay? So we don't know what the sun is. It's definitely a light source in the sky because it illuminates the environment around us when it's over our head, correct?
Yeah.
We
Well,
all see the same thing, right? We see just a light source in the sky that seems to be lighting up everything around it when it's out and above. We see it move across the sky, right? And then from what we understand, right, when they say, "Oh, well, what happens to the sun when it goes far away? Why doesn't it light up all the Earth at the same time?" Well, we don't think that the sun is 93 million miles away and that it's like 250 times the size of the Earth or whatever that number is. What we basically see is we see this light source move across the sky, and then from what we understand with mediums when it comes to light, is that the longer light travels in a medium, eventually it will dissipate and extinguish, just like it does when you're with water. And so the air is not as thick as water, but it has a thickness to it. And so we know that as the light moves away, it eventually dissipates and extinguishes. So when the light's over your head, it's not over my head, and when the light's over my head, it's not over your head.
Okay. Yeah, I mean, but the thing is, like, it doesn't behave like a light source that's just close to us, because as the sun goes away, it's not like it just goes off into the distance, right? It looks as if, if I were to ask you,
It does. We have plenty of evidence showing that it does.
well, no, I'm saying, like, when we watch a sunset, that's not what it appears to do.
No, it does. Like when you're in higher altitudes, it appears to just move far away and then dissipate and extinguish above the horizon.
I'm not claiming there aren't videos and photos that make it look like the sun, is farther away, or it might appear that way sometimes. But I'm saying just our normal everyday experience, the sun doesn't appear to just go off in the distance. It looks as if it's going under, the horizon. That's what it looks, but we know that's not true.
That's not true. It doesn't look like it's going behind the horizon.
It doesn't. A sunset doesn't look like, if you're on the beach and you watch a sunset, it just looks like it's going farther away until it goes. I mean, no, it looks like it's going under the horizon.
No, there's other effects that are going on. You can actually see the sun appearing to get larger as it moves to the horizon, right? Effects of magnification and refraction. These are things
Yeah,
that you all like to throw out there, but you don't really understand what's going on.
I'm not talking about the exceptions to the rule, though. I'm just saying, what our everyday senses show is it looks as if it's going under the horizon.
It doesn't though, because like I'll give you a video example, a time lapse video of it disappearing above the horizon.
Okay, but you would
You
agree that
know,
there are times that it doesn't appear to do that, right?
most times it actually does do that. Like, I spent a whole day, and anyone can do this. It wasn't a whole day. It was probably a couple of hours. But if you go on YouTube and you try to look up like sunset videos where people zoom right in on the sunset, and you can find sunsets where there's nothing blocking where the horizon is, right? Like, obviously, if you've got mountain ranges or elevated land or even big ocean swells, then that's different than if you can just see the horizon normally, right? Like, there's something physical blocking your view of where the horizon would be if that blockage wasn't there. So that would be what would be defined as a local horizon, right? Something that's just blocking, right? And in that case, it does look like it's disappearing uniformly from the bottom to the top most times. Now, if we look for footage where we're looking out over the ocean and there's no waves, tiny waves, or preferably no waves, and you zoom in on the sunset, unless there's a crazy miraging effect taking place, right? If it's a nice, normal, clear conditions, the sun, as it starts to come down closer to the horizon, the bottom of the sun starts to squish, right? It doesn't start to disappear uniformly behind anything. It starts to squish, and then the sun, in every single one that I could find, it's set just above the horizon. It's like the bottom of the sun starts to vertically compress, and then the sun actually fades away just above the horizon line and fades off into nothing, and you can still see the gap underneath the sun between the sky and the horizon. So that I couldn't find a video where that didn't happen. The only ones that I could find where that didn't happen is where we had like a crazy miraging effect, where it was like the sun was like shape shifting, like turning into pyramids and all sorts of crazy shit as it was going down. And that one I would say, there's some hectic miraging effect going on that particular day. So that's probably not a good day to judge exactly what's going on. But every other one that looked uniform, right, that looked normal, it faded away above the horizon. It vertically squishes into the horizon. I couldn't find one where it was just like a nice day and there was no waves, and then the sun just set from bottom to top behind the horizon. Like I couldn't find a single one where it does that. You might be able to find a still shot that kind of looks like it's doing that, but I guarantee if you find the full time lapse of that video, and zoom right in on it, it doesn't do that. I saved most of them as well on that day. I got in my server Pickwood Mines. There's a whole folder, a whole channel called Sun, and they're all there.
And this could possibly just be a means for us, him trying to get us to explain everything because he needs a replacement model for the one that he lost when the curvature disappeared.
No, I'm not bringing it up as like a trick.
No, I think it's a question that it's a good question in my opinion. I'll show you a example of what I'm talking about. I literally couldn't find one that didn't do this. You might be able to find a cherry picked image, but all right, like here's an example.
Yeah, to my ears, what you're saying is like, it sounds like what you're saying is you can't find a video of just a normal sunset over like a plane or something like that. I
Yeah,
can't.
like over the ocean, just a normal sunset over the ocean where it's a time lapse and it's zoomed in. I can't find one. If you could show me one, that would be cool.
Yeah, I can't go looking now, but yeah, maybe.
Oh no, you're right. You're right. No, I don't expect you to. All right, check this out. And I took some screenshots from this as well. Yeah, Jin, those sun fade out videos are crazy. They're a trip. We'll go over that in a second. So just a second, I'll just find the screenshots so you don't have to play the whole video. So just scrolling through my screenshots folder that's endless. And the times that it doesn't fade out like that, you see like a mirrored sun, right? You'll see like a clear like inferior mirage happening.
Yeah, they're fantastic, aren't they? You could almost say they're to die for, these images, if you can capture them, because they're so good.
All right, here it is. Mushkane. So maybe from a distance, right? Let's say you were standing on the beach and watching the sunset, it might kind of look like it's setting from the bottom up. But when you zoom right in on it, it looks like this. I don't know if you can see the side shot, but you can see like the bottom of the sun. It's not setting uniformly, right? It's like the bottom is starting to squish, and then this happens. This next one. Then this happens, and then it just fades away just above the horizon. And I saw that just happen over and over and over again on all of the ones I could find that were like this with no waves. And then sometimes, I'll show some other examples.
Yeah, looking at those pictures, to me, if you just showed me the bottom picture, I would say, okay, that's just the top of the sun. It's been setting. But then you show me the picture above that, and okay, yeah, I see it looks like a squished thing. But if it just squished out more, it'd be a lot wider. So it does look like it just looks like that's the top of the sun. But really, I was more referring to just what we see with our with our eyeballs. I don't know, I've never taken a video camera to the ocean.
Yeah,
Actually.
it's not quite what it seems when you actually zoom in on it. And now, obviously, like most days, there's ocean swells as well, so that will create like a local horizon. And basically, if those ocean swells weren't there, you'd see the horizon a bit further away. So those ocean swells are blocking the horizon, and then you could see the sun look like it's setting more uniform. And then quite often we'll see this effect as well. This is like a superior mirage type effect where you can just see like there's like a mirroring layer, and the sun will mirror and and then it will do that same thing again where it like sort of squishes and fades away above the horizon. And then sometimes you can find where it does look like it's setting uniform. Well, not uniform, but it does look like it's not doing that squishing thing. But usually when that happens, the sun's like doing all sorts of crazy shit, like completely just shape shifting and warping into layers and all sorts of stuff like that. I have a screenshot of that effect here as well somewhere.
It definitely makes some pretty colors.
Yeah, it's crazy, isn't it? Yeah, check out that one that Yaga Bruno just posted on the right-hand side. It's like an eclipse or something like that. But you can see as it comes up, you can see it's like it's compressed at the bottom. It's not like the whole thing as a ball coming up as you would expect. It's like rising up from like a squished state or something like that at the horizon or coming into view. Yeah, Rumen, no one's claiming this is proof for flat Earth. Right? This is just explaining, this is just showing footage of sunsets, showing that it doesn't actually set uniform,
Yeah.
right? It doesn't just disappear behind the horizon. It actually squishes into the horizon.
Yeah. And if he was listening earlier on, he would have heard me say that we look at the sun doesn't prove the shape of the earth. So, we've been saying this for the longest of time. The longest of time. You don't look at the sun and say you're on a globe or you're on a flat earth. You're looking in the wrong direction because you need to be doing measurements. Okay, so you need to measure the surface of the earth. Okay, and we don't know what the sun is. Nobody knows what the sun is. We see what it does through the seasons and what we observe through these videos these video footages that we have, showing you what the sun does in the atmo, in our air that we breathe. Right, okay, fine, how the air is affecting what we see. That's it. But we don't know. No one can claim they know what the sun is. How would they know?
Well, they say it's 98% of the matter in our solar system. So our solar system is 98% sun. It's like that much bigger.
Again, how would you know that? That's still another claim that's not been proven by any human being. We don't know that. That's an outrageous statement. It's not even, and it cannot be considered a statement of fact. For that to be true, that means we've been there, we've measured, we've absolutely fundamentally measured everything and brought that back to Earth.
You can analyze the light of the sun and tell what chemicals or what it's what makeup.
Actually, we cannot. We cannot do that. That's just another wild, outrageous claim. You don't know that. I certainly don't know that, ladies and gentlemen. And I don't have any faith in any equipment to be able to do that.
It's a whole science unto itself. It's called spectroscopy.
Yes, but again, spectroscopy, ladies and gentlemen, isn't an exact science.
That's what the flat earther Dr. John D. That's what his PhD is specialized at, focused in. His study was based on spectroscopy, and yeah, he's not a globe though, so it can't be that convincing.
Yeah, he's a flat earther, by the way. Yeah. Obviously, he was a globe earther, but then when he started investigating that Isle of Wight, yeah, that certainly put him right in the end, didn't it? So yeah.
I bet his coming to was similar to Owen Benjamin. He probably mulled over it for several nights. Like, I can't be a flat earther.
Yeah, Owen Benjamin, yeah. Owen Benjamin vehemently didn't want to be a flat earther, crushing beer cans as he was banning people from his live stream. You haven't got any proof
Hey,
of globe,
Mushkane,
you're gone.
Mushkane, here's another example in the side chat. So occasionally I would find ones kind of like this, where there wasn't waves, but it does look like it's sort of cut off uniformly. But look at it, it doesn't look right. And if you have a look at the video, you'll see the sun doing all sorts of like crazy shape shifting as it makes its way down to the horizon. It also looks way bigger than what it should. So there's some crazy effects going on sometimes with sunsets, right? Sunsets, there's nothing uniform usually about sunsets, but if you can catch it like the cleanest one possible when there's no waves, it will do that thing where it does sort of compress into the horizon and then fade out above the horizon. Anyway.
And if that guy's using a Nikon P1000 like that camera has the longest zoom of like any camera. So I would expect if I'm pointing that thing straight at the sun that it's gonna do weird shit. Unless you know.
No. Well, the camera doesn't make the sun do weird shit. It's the atmospheric conditions.
Yeah, exactly. And they're just gonna be all that atmospheric reaction is gonna be intensified if you're zooming in on it from.
Well, it's not going to intensify it. You're just going to see it closer up version of what's happening.
Yeah, it's going to capture it as you see it, and it's good. It's a precision instrument, by the way. So the Japanese don't make faulty equipment like their cameras. You know, world leaders, aren't they? If not the world leader in camera optics at the moment.
It's not like you zoom in on it, and just because you zoomed in on it, therefore it has some more extreme miraging effects. You're just seeing the same miraging effects from a bit closer.
Yeah.
Yep. See, there's a Rayleigh Criterion just posted another example as well. Right. So when we see it set uniformly, it's always accompanied with these weird like shape shifting type effects.
Well, what's the shape shifting effect on that? It just looks like it's setting.
Well, it's kind of, it doesn't just look like it's setting. It looks like it's warping, and it turns into a pyramid, and then it turns into layers, and then part of it just like warps out of existence. And then I'm sure if you zoom right further in on it, that top bit will look like it fades away a little bit. You know, it's weird. You're seeing like some weird mirroring effects on the surface. This is just some crazy miraging effects. It's not always just one type of mirage or a different type of mirage. Quite often it's like a soup of different effects blended together, and you can have a completely different, you could have like the opposite type of mirage at the bottom of the sun, and then at the top part of the sun you could have a different type of mirage, right? Like we see that often when we zoom out on the oil platforms. It looks like the bottom of the oil platform squished and the top of the oil platform's completely stretched out like crazy. And these are like opposite effects, stooping and towering. And sometimes the bottom of the oil platforms looks normal, and then you'll have a Fata Morgana above it, right? So the whole top part of it's like Fata Morgana, and then the bottom part of it doesn't have any mirages. There's all sorts of combinations of crazy shit that can go on when you look
Absolutely. Well said, DJ. And that's all due to the distance from where you are to the sun as it's moving away from you. It's moving away from you. You're looking through all that atmo. There's going to be refraction a little bit going on there. The images is going to be distorted slightly. Yeah, because the air is doing that. It's all happening as you're looking at it real time. It's a beautiful phenomenon. That's all I can say. And it's never the same. That's the other thing. Each one is unique. So you're not going to get
Yeah, and another thing to take into account is that
waste of
some
time.
days you have atmospheric magnification, and it acts like a lens. And if we set that up on a small scale and we put a lens there, like a magnifying glass or a Fresnel lens or something like that, and then we move a light source away, the light source doesn't look like it's getting smaller due to perspective. It stays the same size as it moves away, even though it moves drastically far away. It doesn't change in size at all, and it looks like it disappears, like it goes down and disappears, even though it's just moving away. Right? It stays the same size, and it goes down. Exactly, kind of like what it looks like when we have a sunset. So
Yeah, that's one of my favorite ones. That one, what you just described.
yeah, it is. So we definitely have this atmospheric magnification effect sometimes as well.
Mm.
And yeah, it seems like when that happens, it does this, like what you can see in this GIF here.
Yeah.
So all of these things to take into account. It's not just as simple as sunsets proof that the Earth's a globe. That's for sure.
Yeah, that's right. That's right. Yeah, that's been debunked 6 Sundays now. That's not true. Much the same as ships disappearing over the horizon. That's been debunked. So no, you can't make those are not proof of globe. Yeah, you just can't use the sun.
And
really.
exactly. It's not like that sun that you're looking at is like the physical sun right there that you're looking at. It kind of acts like because you're looking at it through all of this air, and it's kind of like apparent. It's kind of like projected into your field of view. And David Weiss actually made a good video where he demonstrates this. On a small scale, he sets up and he shows that the actual source of the light isn't where it appears. And it's also, it looks like it's in a different, a unique position to each observer. And he proves that in the little test that he does. It's not the greatest test, but it does show that he stands on one side of the room, and where he thinks that he can see the sun or the light source, he points to it and draws a mark where he can see it. And then his wife is on the other side, and she draws a mark and points to where she can see it. And they both see it in completely different positions because they're seeing it unique to their own perspective and unique to the atmospheric conditions within their own perspective, within their field of view.
Yeah, that's a great one with Dave Weiss. Yeah, I've seen that video a few times, and yeah, it's
called Where
just
You See the
explains
Sun.
it.
Yeah. If anyone wants to look it up, go to DITRH channel. Not that I'm a huge fan of David Weiss, but he's got some good stuff here and there. And
Exactly.
you just type in, go to the search and type in, where do you see the sun? And it should come up.
Yeah. You see, certain characters do some good work, and you bring that forward. That's it.
Well, I'm guessing for a lot of people, the fact that they see, this giant ball of fire in the sky, and also then you got the moon. So these two round-looking things. It's like, well, maybe it's not that far-fetched that we are also a round-looking thing. We're just not on fire, and we're not dead.
Yeah, but it's completely illogical. It only makes sense if you believe in this heliocentric space vacuum universe where there's all of these balls floating around everywhere. and that stars are balls in a vacuum. I mean, most of the lights we see in the sky is stars. Now, any light from a distance looks like a round light. Even if you look at a car that's coming in the distance and it has 2 headlights or 4 headlights on the front, it just looks like one round light. Or you look at a 4-foot tube bulb from a distance, it just looks like one round light. So the stars could be anything. It could be any shape. Could be even a series of lights when you're looking at one light. Who knows exactly what the stars are? So most of the lights we see in the sky, we have no idea. We can't validate what shape they are at all, because all lights just look like a circle. And then we've got some other little things in the sky that kind of look like balls, right? They kind of look like spheres, like the moon, right? That's the most, not like, that's the one that definitely looks like we're looking at half a sphere, even though it might not be that, but it definitely looks like that.
Planets.
But that, why would, yeah, well, planets, yeah, like smaller, blurrier versions. You know, maybe they're bigger, but who knows? Right? Little blurry dots. If you look at Mars or something like that through a telescope, and you look at the raw image before it gets thousands of images stacked on top of each other in post production, right? Trying to get it to how they think it should look in post production. If you just look at the raw image, it's just like a little blurry light in the sky, a little blurry dot in the sky, basically.
Yeah,
Kind of looks like a
shimmering
ball.
blob, I call it.
Yeah, I mean, it looks round for sure, and why would that mean that the Earth is also one of them? It's completely illogical unless you think that you're living in this big giant space vacuum heliocentric universe. Otherwise, there's no logic to it whatsoever. I mean, it is like the equivalent of going out into a forest and just pointing at trees everywhere and saying, "Oh, how come my dog is not also a tree?" That's right, because it doesn't have any characteristics of a freaking tree. When we test it, there's no curvature, and you guys don't have any empirical evidence that it's a globe. So I don't know. So it doesn't seem very logical, but I do understand why people have that idea.
Yeah. I'd like to say it's unacceptable that we can be told we're on an oblate spheroid, and then we go out to investigate that and not be able to measure the curvature. That, that's really, it's a joke, isn't it? Either we are or we're not on a ball Earth, and we're clearly not, because we have the technologies in place to determine that. Remember, it was meant to have been determined 2,500 years ago by Greek sandals, loincloth. Right, there you go. And he managed it somehow, some way. And we can't do it today with our technologies, nanotechnology even, right? So no. We must be able to measure the curvature of the Earth, seeing that we're on the Earth. Okay, looking to the stars is going to be of no assistance at all. Not confirming shape, anyway.
I guess from that you'd have to conclude that we're kind of special then, just compared to what we see in the sky. Then we would kind of be a special case.
Why would we not? Why would we not be special, ladies and gentlemen? You don't know how you came. You start off as an egg in the womb, and you're here now, grown up. That is a special event that's happened, that you've grown up. Then you see all around you beautiful nature, the fruits, the vegetables, the nuts, all there. We didn't put it there. It was put there for us. That's another clue that we are special. The earth was created level for us to live on. Yeah. Now we are indeed special, no doubt about that. If you can't make that connection, then you're not really living the way the Creator would have intended. You're devaluing yourself, and that of nature as well.
Okay. Yeah, I guess I can't argue with that. I mean, that is kind of the case, right? Like if it is a flat plane, it's definitely the case for God is kind of solidified, I would say, at that point. because then you can just throw out gravity. But they've already kind of done that with quantum physics, so I guess that's not even on the table anymore. Anyways, really. I mean, it's an explanation, but it's not the explanation for everything.
Shouldn't that bird be on the grill by now?
Oh, my bad. Yeah, I got a lot of birds over here. I don't know. You guys can hear them so clearly. I think they sound kind of nice, though. They might not sound good through my microphone, though.
Yeah, the birds are coming through kind of loud.
Hey. All right.
I realized something interesting about people's ability to accept the truth or the lack of the ability to do so. What I've realized about it is even if someone, an individual, is very intelligent and very well researched, if a topic comes up, whether flat earth or another topic, and they have strong feelings that can easily be hurt in regards to that topic, when someone else makes objective statements or logical statements about that topic, then that person is not a truther, like not 100% at least. They could be 99% truther, 90% truther. They're definitely not 100% truther, because in order to be 100% truth, to be, someone who accepts objective reality for what it is 100%, you have to lack the feelings inside of you that get hurt and make you think and act illogically when someone points out the truth to you. Unfortunately, I'll be honest, I'm thinking less than half of the people even in this room are lacking those feelings. I think most people have those feelings inside of them. I think there's very few people in this world, very few people even in this server, that can actually accept the truth 100% of the time and not just flail about.
Yeah, I agree with everything you just said. Who said that? Orion? Is that your name? That was nice.
Yeah, I said.
Sometimes there are like uncomfortable truths. They're truths that you don't know what to do with. And if you react aggressively or something towards that probably means like you have an acceptance problem.
I think a lot of it boils down to, like I was talking about, people with feelings, and if they get their feelings hurt, then it causes them to just behave stupidly. But it's like, I think a big part of that is most people have the inability to analyze their own feelings. Like, that's actually a hard thing for people to do, like analyze their own feelings about various topics and just try to look at their own feelings about one topic or another from a third person perspective, in their own mind. Try to close your eyes and look down on you and your surroundings from a separate point of view, at least attempt to do so in your mind. Most people, they just don't even think to even try. I think my favorite example of that with flat Earth is when you tell someone the Earth is flat and the moon landing's been faked, and they're like, "What? But my grandfather worked on the lunar lander," which is funny because my grandfather, my mom's dad, actually did work on the Apollo program, and she even said that to me once when I told her that the moon landings were fake, and then she asked me, like, hey, do you think that your grandfather knew that they were fake or not? And I said to her, I'd say 50% chance he did, 50% chance he didn't. And then she's like, oh, well, why do you think you didn't tell me? It's like, well, because he probably thought you wouldn't be able to handle the truth. You're a grown woman now, and you're not able to handle the truth now. Why would you handle the truth when you're a 16-year-old girl? Probably didn't think you could handle the truth. If you knew. And I'm not trying to make it sound like I was trying to rub salt in anyone's wounds. I'm just being realistic. Like, if someone looks at someone else and thinks, oh, that person can't handle the truth about X, Y, or Z, they might just not bother telling you because you can't handle the truth. Like, the Glovers The anti-flat earthers that come in here, they just flail about. I think I may have heard someone say this before. Don't let your feelings get in the way of the facts. I think I should say that to people more often.